Hi, I'm Christine Alvarado.
I'm Leo Porter.
And I'm Mia Minnis. Welcome to our fourth course in our intermediate Java programming specialization. This course is about how to succeed through all elements of a job application process in order to get a software engineering position. Front and center to that process is the technical interview.
Yeah, and that technical interview can be stressful. I remember my first one. I was in a small college in New Hampshire. I had to drive 2 hours down to Boston for this interview, completely unprepared, didn't know what to expect, and it was a train wreck. It couldn't have gone any worse. I just remember 20 years later, that awful feeling, how I felt after that interview. Now, things got better from there, but I don't want any of you to have to go through what I went through.
That's incredibly rough. If it's any consolation, my first interview, now this is back in high school, I actually finished with the interview telling me that I should call back after job interviews when offers went out to get interview advice.
Oh, ouch. It was nice of her to offer that advice, but still that stings.
You know, technical interviews are just plain hard. It's not surprising that interviews with companies like Google have a reputation for being really difficult. You're asked to demonstrate expertise in software engineering by solving new problems and writing code in a high-pressure situation. And it's not just about having strong technical expertise. It's also about how you convey yourself, your soft skills. Do you project confidence? Do you exhibit the communication and interpersonal skills that would make you a great team player?
That's why this course is going to address both of these elements of the technical interview. In this course, we're going to pull back the curtain and show you the secrets of what you can do to make a good interview look easy. Just as this course may look polished and easy, there's lots of work that goes into making it look that way.
Oh, I get it. That's why we're in the studio, not out in some beautiful scenic UC San Diego location for this little chat.
Exactly. So in this course, we're going to be going deeper with your technical skills, using the knowledge you gained in data structures, algorithm analysis, and programming that you've learned either in earlier courses in our specialization or elsewhere. And we'll teach you about the soft skills that can make or break the interview.
Now, you may think you're alone in worrying about these soft skills like conveying confidence and being well prepared for your interview, but everyone feels nervous before an interview. We'll teach you ways to combat that stress, overcome self-doubt, and put yourself in a position to succeed.
You know, there's one common cure for doing well at something hard. It's practice. So we'll make sure to give you the tools and avenues you need to practice these skills. If you look at other interview videos on the internet, you'll find that they don't give you this kind of practice. So what we're going to do is give you the programming assignments and the feedback that you need to succeed.
Yeah, and these assignments will give you practice on many things. They'll give you practice on how to introduce yourself in your work, how to write code during a technical phone screen and an in-person interview, and how to solve new algorithmic problems at a whiteboard.
Now, this practice will help you hone both your technical and your soft skills. It may take a while to get it all right, but the skills you learn aren't just about getting the job. There's a reason that interviews test you on all of these skills, and that's because they are so fundamental for success throughout your career.
We've had a lot of fun building this course, and we've had some great help from a team of engineers and recruiters from Google to help make sure that what you're learning is up to industry standards. So we're really excited to have you with us, and we believe this course can make a real difference in your career. Welcome again to the course. In this video, what I'm going to do is go over the goals that we have for the course. So let me just start off with a story about one of my previous students. A couple years back, one of my top students, a really talented student, got an interview at a company which seemed like a perfect fit. And the student went off for the interview. I thought he'd be highly successful. He came back, and when I debriefed with him, I found out it hadn't gone well at all. He was surprised by the format. He didn't realize who he'd be interviewing with. And then when he started telling me some of the questions that he was asked, I recognized them as really common interview questions, but he'd never heard them before. And only through a discussion with him, I realized he hadn't really participated in the prep that a lot of our students do to prepare for interviews. So it wasn't that he wasn't good at computer science. It wasn't that he wasn't a good software engineer. It was just that he hadn't been prepared properly. And our students here at UCSD spend a lot of time, in general, getting prepared for their interviews. And part of our goals for this course is bringing that experience, that preparation that our students do, to you. So how this usually works is we have a whole bunch of our students every year apply for internships and apply for jobs. And what they do is they get a whole bunch of experience back. So they go off to these companies, they interview there, so they gain a whole bunch of interview experience, and they also get jobs at these companies. And they learn what the skills are at the job that really matter. And then when they come back from those interviews and they come back from the job, what do? They talk. They talk a lot. And what are they going to talk about? They're going to talk about all that they've learned in the interviews and what they've learned on the job. So some of the things they're likely to discuss. Well, they're going to talk a lot about the interview format. They're going to talk about what kind of questions they heard. They're going to debrief those questions actually in quite detail, like what would be the optimal solution, what's a decent solution, could we code this up? They're also going to talk about where they struggled in the interview and what kind of tips they found to help be successful. When they come back from their work experience, they're going to do similar things. They're going to talk about what life is like at that company. What's the philosophy? What is life just generally like there? And they're also going to talk about the skills that mattered there. And sometimes the skills that matter in the workplace don't match exactly with what they've taught in an academic setting. So it's an opportunity to prepare for some of the skills that are more common in industry right now. They'll also talk about where they struggled in the job. And again, they'll give some tips about how they succeeded on their internship. Now, these kind of discussions actually form groups. For the interviews, they actually form interview study groups as a result. And they get together and they practice and they prepare. And they do that essentially all year in prep for their interview season. And for the people who have been working in industry, they actually form alumni groups. And we have our alumni come back fairly often to UCSD and talk about what life is like at various companies and give hints about how to succeed in the interview. And again, it's these groups that we're essentially going to try to give you the feel of and try to give you the same experience that our students have, again, through this MOOC. In this course, we're going to be focusing on two, what I'm going to call critical pairings. The first of these pairings is recognizing that success on the job and success in interviews requires both technical, or sometimes called hard skills, as well as soft skills. Now, the technical skills you're probably pretty comfortable with. These are the things like knowing what a linked list is. The soft skills are your communication skills and your ability to work with other people and your ability to persevere through hardship. These are the two skills that are both essential, again, in the interview and on the job. That pairing, that one I just said, is actually the second piece here. The skills that are required for a good interview happen to match quite well with the skills that are required on the job. So let me talk a little bit more about these pairings. So everyone has a large component of soft skills as well as technical skills. And if you think about it, essentially the bar to succeed in an interview or on the job requires some combination of both. Now, there are lots of different ways to essentially reach this bar of success in your career, and let me just walk through a couple of them. So you could imagine some people are really well balanced. They've got pretty strong technical skills and pretty strong soft skills, and that achieves the bar for success. But you also find people who are really strong technically and just a little bit weaker on the soft skills. That can also reach that bar of success. And lastly, you'll find people who are exceptional in soft skills and then just a little bit weaker in technical skills. And again, they also meet this bar. I have plenty of friends who have successful careers who match one of these molds. The bottom line, though, is that both are important. And this course is going to help you address both. I'm going to talk more about soft skills in our next video. Let me talk a little bit about this pairing of interview and career success. So what are the skills that's required for you in the interview, and what are the skills that are required for you on the job? So if you think about what's required in an interview, you're going to have to introduce yourself to new people. You're going to have to explain your work projects. You're going to have to write code. You're going to have to solve new problems. And if you think about what's required for you on the job, you know these things basically match one-to-one, right? You're constantly still going to be introducing yourself to new people, people outside your team, people outside your company. You're still going to have to explain the value of your work to other people. And of course, you're still going to be writing code and you're going to be solving new problems. Interviews are very well designed to test the skills that you actually need to succeed on the job. So the skills that we're providing you in this course actually match well to both. So let's talk a little bit more about what's going to happen in this course. So by the end of this course, you should be able to evaluate a successful interview or a successful job skill, both on technical and soft skill merit. In terms of that, you're going to be able to introduce yourself, which we're going to work on this week. You're going to be able to write code, which we're going to work on in week 2. You're going to be able to describe prior projects or describe your work, and we're going to focus on that in week 3. And you're going to be able to solve new problems, and we're focusing on that in week 4. Also, you're going to be able to describe best practices and tips and common pitfalls for successful interviews. This week, we're going to be focusing on understanding what's involved in the interview process. So by the end of this week, you should be able to describe the format of the interview and who are the people involved. As part of that, we're going to help you prepare for getting an interview, as well as look at some, say, resume best practices. We're also going to talk about the role of the technical phone screen as well as the in-person visit and what to expect in each. We'll also give you some tips and some hints about how to prepare for interviews in general, and we're going to end with some practice of introducing yourself to others, like you'll do in the interview. So what we'll do next is spend a little more time defining soft skills, and I'll see you in that next video. And it's not hard to convince students of the merit of technical skills. They know that if they don't know what a dynamic data structure is, they're going to be in trouble in the interview. But some students overlook the importance of soft skills, and I'm not really sure why that is. I'm not sure if it's that they generally lack experience working on teams, or if it's because soft skills can seem a bit too vague. Whatever the reason, these students are missing out on the fact that soft skills play a significant role in software engineering jobs and during the interview. So our goals here are to understand which essential job skills are soft skills and appreciate the large role that they play in interviews. Now, we already saw in the last video that both soft skills and technical skills are necessary to achieve your goals on the job as a software engineer and during the software engineering interview. But what exactly do we mean by soft skills? One definition comes from Wikipedia. This definition includes social graces, communication, language, personal habits, interpersonal skills, managing people, and leadership. In this definition, we see soft skills as critical interpersonal skills focused on relationships with others. It's not hard to see how these are absolutely essential for working on a software team. Let's look at one other definition. Although this definition is what's referred to as practical intelligence of IT professionals, we can see this as soft skills in the technical workplace. Here we see interpersonal skills and managerial skills reappearing, but we also now see intrapersonal skills included here. And these might include things like your willingness to learn new things or to persevere when things get hard. I actually like this latter definition a bit more, as it's more broad. But perhaps the easiest definition is that soft skills are all those skills you bring with you other than your technical. So let's think a bit about what kind of benefits come from some of these soft skills. Your ability to work with others, your interpersonal skills are pretty clearly important for successful teamwork. But they also lend to your creating both larger social networks and stronger relationships. This creates a key support network, which you'll be able to use to find answers quicker by seeking out the appropriate expertise, and will also give you support if you're struggling. Your ability to communicate is again key for working on a team, but goes beyond that. Communication skills allow you to do things like convey the value of a work to people outside your team, and that includes management and customers and so on. Leadership skills, knowing how to manage products and lead people, is essential for advancement really in any company. Perseverance allows you to overcome adversity and succeed. This intrapersonal skill has been tied to success in a wide variety of areas of life. So James Heckman is a professor at the University of Chicago who's written articles summarizing research on soft skills. Here we see him saying, cognitive and personality traits are equally predictive across a great variety of labor markets and social outcomes. Let's think about this. Your cognitive and personality traits are equally predictive of success? That's a huge endorsement of soft skills. In fact, Professor Heckman's findings were recently used in a popular book that you may have read. How Children Succeed is a New York Times bestseller, and I personally enjoyed the book. Here, the author examines how soft skills like grit and personality can determine a person's success in life. Now, as a researcher, it's really tempting to go on and on about the research and dive into individual studies, but the truth is that this is really just common sense. We've all had that teacher who's dull and drones on and monotone without making eye contact, and conversely, we've had that teacher who's animated and clearly cares about learning. We've also had that teammate who seems great when you first form the team, but then turns out to be somebody who's always sure they're right and won't listen to anyone else. Beyond that, we often hear stories in the sports news of great individual athletes who get cut from their teams just because of their attitude. All of these are failings in soft skills. Now that you have an intuition for what we mean by soft skills, I want to give you a couple concrete examples of how soft skills can impact a software engineering interview. What I'll show you next is an example from a bad interview. The actors in the video are actually successful software engineers role-playing what a bad interview commonly looks like. In this clip, the interview has already begun, and the candidate is being asked to write a data structure capable of insertion, deletion, and random retrieval. The details of the question aren't actually that important for right now. What is critical is that the candidate has already made a fairly common mistake of diving into the code before discussing the problem and its proposed solution with the interviewer. Let's look how the interview tries to get him back on track.
Okay, so before you start coding, can we kind of pause for a second and can you just go over your high-level approach?
So what I was thinking is have an array where I can start putting like the values, and then sort of get random would be just returning a random element from the array.
Okay.
And sort of, yeah, I guess I need an array.
Okay, so you're allocating 10,000 elements. But what happens if you have more than 10,000 elements in this array?
Are they going to fit in memory?
Yeah, you can assume they fit in memory, but you don't know how many elements you're going to have.
So I can't just like pre-allocate.
What we saw here is an interviewee missing a hint. Even after prompting, we see the candidate continue to dive back into his draft code rather than stepping back at a high level. The interviewer is trying to get the candidate to step back and see that his present choice of data structure may not be the best, so they'll have time to explore other options before actually coding. This may seem like a minor mistake, just missing a hint, but if you watch the whole mock interview, you'll see that going down the wrong path because of a missed hint ultimately costs the candidate so much time that the candidate never arrives at either a fully working solution or a highly efficient solution. But if you're thinking right now, but missing a hint isn't a job skill, that's not fair. Recognize that communication with your teammates is an essential job skill. The interviewer's hint and the candidate's response is partially there to test whether the candidate will be a good communicator with teammates and colleagues. Let me show you one more example. In the next video clip from the same bad interview, focus on the candidate's demeanor during this exchange.
Okay, so what do you know the runtime of binary search?
So it's like, I think it's, I don't know, like log. I mean, it's better than linear, right? So.
The interviewee actually knows the answer, but does his answer instill confidence in you? It might be that his technical knowledge is weak and he's just guessing, or it might be that his confidence is failing during the interview and he's not conveying his understanding very well. But either way, this is going to be seen as a weakness by the interviewer. Now, certainly practicing on problems like these, which you'll do in week 4, along with brushing up on your technical skills, can help with your confidence. But we'll also be discussing non-technical strategies throughout the course, which can help you with interview jitters and help you better present your understanding with confidence. As you've seen in these examples, soft skills can make or break an interview. That's why a central aim of this course is to help improve them so to help you succeed.
So you've heard Leo talk about the importance of both technical skills and soft skills in interviewing for and succeeding in a software engineering and development position. Now, there's lots of routes to developing these skills and to a software engineering and development career. And so we've been thrilled to have a group of engineers working with us, and some of them have agreed to share their stories of their career path to where they are now. And so we'll hand it over to them.
Okay, hi. I'm Roshni. I'm a software engineer on identity and authentication at Google, and I've been here about 2.5 years. So my dad is a total nerd, but he hasn't actually studied computer science. But because of him, I had a really great interest in computer science because he brought us a computer when I was 10 years old. And since then, I've been taking computer science classes, and I took a class or two in graphics, but I was actually more interested in systems. So now I'm a software engineer with a couple of degrees in computer science.
My name is Shane Brennan, and I am a software engineer. I knew from an early point, even as early as high school, that I was passionate about the act of coding. I really liked that deep state of focus that people sometimes called the zone. And for a while, I guess I thought this may be something of a software engineer. It wasn't until I graduated and started working a real job that I understood I really don't know what the heck it means to be a software engineer. And so in order to not look like a total noob in front of my coworkers, I started spending a lot of time trying to build up skills around good code health, good testability, having a clean, consistent style, making it easy for someone to come in and understand what the heck I'm working on. In building these skills, I came to realize that this is what people mean by software engineering. It's not the code you write or knowing all the algorithms and when to apply them in different situations, but it's the processes and practices that we develop in order to build software together collaboratively more efficiently. And I found that I really cared about these practices. It mattered to me whether my team had a principled set of skills that we would apply in developing code, or if we were just hacking things together willy-nilly.
My name's Howard. Now I'm a software engineer at Google. But I think long term, as is many of the folks within my industry, you want to kind of have your own company. You want to build a product that really focuses on solving a niche problem or providing a niche service in a very technical fashion. That's many years from now, but that's definitely something that is a career aspiration for me. Something else I'm very passionate about is just outreach in the nonprofit and educational space. I try to make myself available as a mentor to any and all who have aspirations in being a software engineer in the finance or technology industry.
Hi, my name is Matt. So when people ask me what I do for a living, I usually generically say I'm a software engineer because that's the canned statistic you see on different news reports and whatnot. If I get the impression that someone knows a little bit more about the industry, I'll tell them I'm a site reliability engineer or a DevOps person. We usually work down more in the deeper levels of the software stack, doing infrastructure software. That's usually what gets me excited, is operating systems, programming languages, networking, a lot of the infrastructure bits, not as much of the application on the top that the end user sees. It originally started with video games. I grew up playing Nintendo, and my school usually had really lame computers. They were old, and we just had number crunchers, number munchers, things of that sort. And eventually I had a friend, when my family moved, they had a computer at their house, and they showed me computer games that were much better than what I had on the Nintendo. So I eventually dusted off my family's computer, started trying to get those games running, and then I try to improve the computer so the game runs better, try and fit multiple games on the same computer, learn how to modify the games, maybe on some of them learn how to cheat. And eventually I spent more time with the computer than I did with the game, and I discovered the internet and information about the games. Maybe you find websites, how do I make my own website that I want to show other people what I did with the game, talk to other people about the games in chat rooms and things of that sort, play the games with people on the internet and compete with them. It was just sort of a rabbit hole that kept going of learning more.
What I'd like to do next is give you an overview of what's involved in the interview application and interview process. Now, many of these terms you're probably familiar with, but I just want to make sure we're all on the same page because we're going to be referring to these terms over and over throughout the course. So by the end of this video, you should be able to describe the common components of the interview and the application process, and you should also recognize that there are a couple of formats for interviews and know how to recognize which is which. So every application process begins with resumes, and tons of resumes get sent in for a single position. You can see that my arrow here is quite large, and that just represents that there's lots and lots of resumes going in. And those resumes are going to be read by someone. Now, at small companies, the person reading the resume may actually be another software engineer. It could even be the CEO, depending on how small a company is. But for larger companies, it's going to be recruiters who are reading these resumes. And for really large companies, it's going to be people that the recruiters hire to screen resumes. So it just depends on the size of the company, who's going to read your resume. And we'll talk more in this course about tips for success in writing your resume. If your resume passes the review, it essentially means that you might be a good fit for the position. And what they're going to then do is send you along for a technical phone screen. Now, the role of the technical phone screen is to ensure that you actually match what's on the resume. So they may have pulled out some pieces from the resume that they thought were a good fit, and they're going to talk with you about them in the technical phone screen. And you might get an in-person visit. At the in-person visit, this is often a whole day affair where you're going to meet with a whole bunch of different people, get interviewed by software engineers and potentially other people at the company, management, HR, and so on. And then after you've interviewed, there's going to be a job offer that gets sent off to a few people, and then those people may or may not accept. That begins the negotiation phase about the details of the job offer. So this is essentially the whole process. Again, I just want to walk through this so that we're all clear about the terminology we're using throughout the course. So there are two different models for interviews, and it's worthwhile recognizing which format of interview you're going to be going to. And it's very possible if you have multiple interviews that you may be going to one format at one company and another format at the other. So one format of interview is team-based. So you're going to interview with the people on the team that you'll ultimately be hired into. And this is great for both the people on the team and the applicant because you get to meet the people on your team and the team gets to meet you before any hiring decisions are made. Now the problem that comes around with that is that different hiring managers may have different standards. They may have different priorities in terms of who they hire. And in a sense, you want to make sure that someone can be successful throughout their entire career, not just on the first team they're hired, but on later teams as they advance. So it makes sense to have a more uniform standard of skills that you're looking for. This leads to the second model, which is that you get hired into a company. Here they have a more uniform process for what they consider the standard of acceptance, and there you'll interview with various people across the company and not people on the team you'll work with. You won't actually get paired with a team until after you've gotten a job offer. So each of these approaches has their own pros and cons, but it's worthwhile recognizing which format you're going to have for the interview. In fact, you want to know which format you're going to be encountering when you start preparing for the interview. In the next video, we'll talk about how to do just that, prepare for the interview. In this video, I'm going to give you an overview of the resources that are available for you to prepare for the interview. So by the end of this video, you should know what resources are available to you and what are effective methods for preparing. So first thing for preparing for an interview is knowing what to expect. If you remember my story right from the start of this course, I had a student who had a rough time in an interview, predominantly because he didn't know what to expect in the interview. And we want to remedy this. So if you're in this course, you're in the right place because this course is meant to help provide you with that knowledge of what to expect during the interview. So the second piece that's absolutely essential is practice. And I'm going to change context for a second. I want you to imagine that your team is in a game, in soccer or football, depending on the country you're in, and a penalty kick is going to decide the outcome of the game. And you're the one who's going to kick the penalty shot. Now I want you to imagine first that you've never shot a penalty kick before. If you immediately start panicking, that's the exact right response, right? If you've never shot a penalty kick before, the last thing you want to be doing is trying to do this in a high pressure situation. Let me give you a second scenario. You've gotten a little bit of practice. You've shot some shots on your own goalie during practice, but you haven't actually made one. Your goalie's been blocking them all. So you've had some practice, but you're not proficient. And now you're on this major stage, you're trying to shoot it to win the game. Do you feel comfortable? Probably not, right? You just don't have enough practice yet. Now imagine you've been taking tons of penalty shots in practice. You know you're proficient at the rate of about 8 out of 10 shots are made when you shoot on your own goalie. You know you're good at shooting penalty kicks. Now, if you're on this stage, which is higher pressure, you have to make the shot for your team to win, you're going to be uncomfortable, right? This is pressure. You're going to feel stressed. You're going to feel a little bit uneasy about having to take the shot. But it's okay because you've got tons of practice under your belt to know that you can do this. And you can rely on that practice to give you the confidence you need to succeed. I want you to take this analogy and start thinking about the interview. Let's imagine you've never coded in a Google Doc before. And now during your technical phone screen with an interviewer, you're being asked to do so. This would be a highly stressful situation, right? You've set yourself up for failure by having never done this before. And it's not enough just to have coded a couple times in a Google Doc because you may not feel that proficient yet. What you want is authentic practice. You want somebody giving you questions and you walking through in a Google Doc your code with that person helping giving you feedback. If you have that kind of practice, you'll feel much, much better having to do this when you actually go to the real interview. And again, it's okay if you feel pressured when you're in an interview setting. You can just rely on that practice you've gotten to give you the confidence to succeed. So this course is aiming to give you these two pieces: what to expect and avenues and resources to get practice. So the first resource I'm going to provide you for preparing for the interview is actually this course. So this course is going to give you the entire interview process, how to prepare both technically and with soft skills. It's going to provide all those goals we talked about earlier. But I want to recommend some other resources for you which might be helpful. So the first of these is Cracking the Coding Interview by Gail McDowell. This is a commonly used book to prepare for the interview. It has a number of good example questions, and we may actually suggest some example questions from this book as the course goes on. You also want to make sure that your technical content is incredibly strong. So if you haven't taken the first 3 courses in the series of the specialization, I recommend you do so. In these courses, we talk about core interview content, things like data structures, algorithm analysis, testing code, writing quality code. All those things are in those prior courses. If you want more practice with algorithms, I recommend the text Introduction to Algorithms. This book actually commonly goes by the title CLRS, which stands for the initials of the authors. In fact, our students actually joke a bit when they're preparing for the interviews that they're going to spend their next 2 weeks before the interview with CLRS. Beyond algorithms, you want to make sure your coding practices are excellent as well. And let me recommend 2 books. Neither of these books are introductory books. Both of these assume you already know how to program. What they do is they focus on making your code more efficient, more correct, and more readable. And these are essential skills for any software engineer. I personally have used Effective C++. Highly recommend it. It's a great book by Scott Myers. I've heard great things about Effective Java by Joshua Black. We'll also provide you some additional resources in a reading that follows this video. The last resource I can't recommend enough is a study group. So this is the time. If you have any colleagues at work, if you have friends at your institution, if you have family who might be interested in preparing for a technical interview, now is the time to approach them and say, you want to work through this course together. Form a study group. These are your team. These are going to be the people who give you feedback on your practice. We'll give you some opportunities to do this in the course, but the extra practice you can get from an interview study group is incredibly important. What we'll do next in the course is we'll start looking at how to find positions and how to apply for them. In this video, we're going to be talking about your first step, researching companies and researching available positions so that you can then apply for jobs. So at the end of this video, you should be able to research a position to help you determine whether or not it's a good fit. And you should also be able to research a position to help you with the application and interview process. So the term good fit is a little vague. And what I want to do is just give you an example to help give you a better feel for what we mean by good fit. So when I was in graduate school, I had a good friend who was in systems, so computer systems, he's a computer scientist, in networking. And he was also an avid athlete. So he spent a lot of time at the track, he was always working out, he was experimenting with lots of different gadgets to try to help him with his fitness success. Well, I found out that he had an interview with a company that made a fitness wearable, a fitness tracker, like Fitbit. What a good fit, right? It just screams a good fit. His technical skills of systems and networking match the needs of a company that makes a device that's going to connect wirelessly to a network to transfer information, and his interests happen to match well with this as well. He also knows the product lines well because he's already been playing with fitness wearables for a long time. So all we mean by a good fit is that your strengths and your interests align with your job. So when I'm talking to students, a lot of the time, when they're thinking about new jobs, they'll often ask themselves, can I get this job? Or they'll say something like that to me, where they're thinking, well, I could maybe phrase my background in this way to try to get this position. And I often discourage them from this line of thinking. I think that's the wrong question of whether or not you can kind of shoehorn yourself into a position. I think the right question to be asking is this position a good fit for you? Is this something that you could see making a career out of? Is this a company that you'd want to work for? And now determining a good fit can be difficult. So let's talk about the ways that you might go about determining whether or not this could be a good fit for you. So the first step is looking at the job qualifications and job description at that company. Does it match your background? If it doesn't match your background, this might not be a good position. The second thing I want to point out is as you're doing this research on job qualifications and job description, make notes because you're going to want to tailor your resume to match these the job qualifications required. And we'll talk more about resume development in the next couple of videos. The other thing you'll want to do in trying to determine whether or not this is a good fit for you is research the company. What's their philosophy? What are their goals? What are their products? Where are they at? If they're located in a place that you don't want to live, maybe this isn't going to be a good fit for you. If you know the company's philosophy doesn't really kind of match your own philosophy, again, maybe not a good fit for you. And all this you can do through researching the job description and the company itself. As you're doing this process, you're undoubtedly going to have questions. So write down those questions because if you get an interview, that will be an opportunity for you to ask those questions. This is also the right point to potentially reach out to somebody you know at the company. Now what you want to do with reaching out to them is just ask them more about the job. Ask them some of those questions that have come up while you've been researching the position. And you might think it would be weird to reach out to them. They might feel uncomfortable with you talking to them about a position, but it's actually the right thing to do. What you don't want to have happen is not tell someone who's at the company that you're applying to that you're applying because they might be on the interview screening board for you. It could cause some really messy situations for them if they run into you at the company and you knew them and didn't tell them that you're applying. So the right thing to do, tell them you're applying, and the best way to do that is just ask some quick questions about the position, and they'll probably give you some feedback. They may even streamline your application, but that's just kind of an extra bonus. This does not mean you should start trying to make connections at the company. This is for existing connections. Writing people out of the blue about positions at the company rather than following the traditional job application process is a mistake, and it could actually hurt your chances of getting an interview. So let's say you get that interview. Congratulations, that's awesome. What do you do next? Well, you're going to go back to that research. You're going to want to find out more about this company. You want to find out the history of the company. When was it founded? What was it founded for? What was their first product? Who are the major players? Who are the CEO, CTO, CFO? Who are the major historical players? Who are people who founded the company and might still be involved? You also want to figure out their corporate strategy. What products are they releasing? What is their edge in the market? What are the other companies that are out there? What's the competition? Research the product in more detail to figure out what are good features of the product, what are maybe some potential shortcomings. And the reason you want to do this is that if they ask you questions, you have this critical knowledge. You know what the background is in the product and you can talk about it knowledgeably. If they start throwing around names of like the CEO, you know who they're talking about and can talk about those knowledgeably. I do want to caution you not to use this knowledge to overreach. This is not to help you prepare so that you walk into the interview and immediately start telling them, here's the way I think you could redo your products. That's a mistake too. This is just to give you the background so that they ask you questions about the product or the history of the company or the different people of the company, you know what you're talking about.
When I was going to interview, I knew I wanted to interview big companies. Big companies usually deal with big data and analysis of information. So one specific technical concept I struggled with was map reviews. This was a concept I didn't learn at school, and I felt I needed to study it for my interviews. So the way I overcome this challenge was to go from getting to know the concept in general and then dive into the specifics. First, I just Googled the terms, I went to Wikipedia, I got familiar with the definition, the words, what they meant. Then I got to specific examples to learn why this technique was useful and where should I use it. Then I jumped into specific examples and learn those specific examples and be able to code and run my own example. Once I got a bit of familiar with the technical concept, I started looking back to my school projects and internships to see where could I have used that technique.
What we're going to do next is help you prepare your resume so that you can get that interview. In this video, we're going to be focusing on how to improve your resume to help get the interview. Now, preparing your resume could really be a course in itself. We're not trying to do that. All we're going to try to do is give you some tips to help succeed, as well as list the common pitfalls that are seen by recruiters and resume screeners so that you can avoid them. So at the end of this video, you should be able to employ some of the tips that we suggest for improving your resume, and you should also know how to avoid the common pitfalls when writing your resume. So the first tip, this is probably our biggest tip we're going to provide, is to focus on accomplishments, not assign tasks. Let me give you an example here. So we have a resume bullet item here for someone working at Tech Social from June to August 2015 in Tech Town, and their job was as a software engineering intern. And they've got their bullet under their software engineering intern, which is software engineering team. It's kind of redundant, right? I mean, if you're a software engineering intern, I'm pretty sure you're going to be on a software engineering team. This doesn't really add much, and it's kind of wasting space on your resume. A better approach here would be to say exactly what you did. So a better version of this would be to say that you were a member of the back-end optimization team. At least now you're saying what software team you're on, and if someone's screening your resume looking for someone with back-end experience, now they'll be able to find it. But this is still kind of task-oriented. Someone assigned you to be a member of the back-end optimization team. What did you do there? It doesn't really say much about what you did. It's more of just I was passively as part of this group. A better approach to do this would be this. Say something like you optimize the back end to reduce query time by 20%. That's an accomplishment, and it says what you were doing on the job. Much better bullet item. So again, focus on accomplishments rather than tasks. So the first really common pitfall is having your resume out of date. Now, this can come about in a couple of ways. So one example might be you've applied for a job in 2016, and your last item on your resume is from 2012. Well, what happened in the last 3-4 years? Someone might assume that you just didn't bother to update your resume when you applied. So if that's the case, you didn't bother to update your resume, obviously update your resume. But if you had extenuating circumstances, maybe you took time off to raise your kids or something, this is the opportunity to give some kind of clarification in the resume to help the reviewers know, oh, they're actually doing X for the last 3 years. This isn't an out-of-date resume. The other piece that's essential with out-of-date resumes is making sure that you update your skills and proficiencies. Maybe you spent 10 years as a C++ programmer, but that was 5 years ago. And you haven't programmed in C++ in the last 5 years. Do you really still want to list that as one of your strong proficient languages? Maybe, maybe not. And that's where you want to update your resume based on your most recent experience. The second piece here is just having your resume too lengthy or having bad formatting so it's hard to read. You have to realize that resume readers are often going to spend something like 30 seconds reading your resume. It's critical that they find the pieces of your resume that apply for this position immediately. So you can't have it too lengthy. You don't want them trying to search through 60 different items to try to find the 2 that actually apply for this position. It's your job to make sure that your resume is tailored so that only those 2 items are appearing, or only a small subset of those items are appearing that apply for this position you're applying for. We'll talk about tailoring in just a little bit longer. The other piece is poor formatting. If they're looking for your coding skills as the primary thing they're looking for, they shouldn't have to dig through this long text document to find it. It should say pretty clearly programming skills or proficient languages, and they can just jump right to it. Another common mistake, predominantly from folks just finishing their undergrad, is overreaching on skills. So I've been programming for somewhere around the last 20 years, and I'd be hard-pressed to list more than 3 or 4 languages that I call I'm proficient in. what we'll often see for undergrads who've just finished our degrees here is they'll list any language they've ever touched as proficient. They'll list like 12 languages there. And that's a real mistake, because anything that you say you're proficient on in your resume is fair game during the interview. So maybe you did do one assignment in PHP, but do you really feel comfortable if your entire interview is going to be in PHP? Probably not, right? So only list languages you're actually proficient on. Not tailoring the position is, again, a major pitfall. Everyone has a different background. You've got some activities in one area, you got other activities in other areas, and you're going to want to change your resume based on the position. Maybe you have a large background in hardware and computer engineering before you spent your last 3 years as a web designer. If you're applying for a web design position, you're not going to talk much about that hardware engineering background. On the other hand, if you're applying for a hardware engineering position, you're not going to talk as much about your web background. So you're going to reformat that's again based on your skills, but also based on company size and things like that. So maybe you have a long background working at really large companies. You might want to emphasize that if you're applying for a large company. If you're applying for a small company, maybe you don't emphasize that fact. And all this, again, comes back to researching the position to know exactly what they're looking for with the job so that you can tailor your resume to it. The last piece is that this is the right time to fix your online presence. So some common mistakes here are having a website that's out of date or not reachable. You give them a website in your resume, they try to click on that link, and they get a 404, or page not found. You don't want that happening. You also don't want them going to your website and it's 2 years out of date with your projects. I mean, they may have been following that link to your website to try to find out more about you, get more background on you. You don't want that to be out of date. This is also the time to fix your social media presence. If you have some pictures from 5 years ago at a party that you don't want on social media, you got to get them down. This is the time to get rid of them. So now that you have some effective tips for succeeding on writing your resume, what we're going to do next is look at a couple of resumes and see where there might be some problems.
What we'd like to do now is take a minute to debrief and really highlight what we want to avoid when constructing our own resumes. And so remember in the first question, we were looking at a sample resume that was really out of date. And it was out of date in an important way. Avery was submitting this application for a job or internship opportunity starting around January 2016. And so if we look at the resume, what we notice is some really interesting summer activities happening in previous summers. So for example, in 2012 and 2013 and 2014. But what happened to summer 2015? It's already in the past, and if the student was really as qualified as they appear to be from their previous experiences, the expectation of the recruiter looking at this resume is that there would have been some interesting projects happening in summer 2015. Now, not only is there a gap in internship experiences or summer experiences, we also notice that later in the resume, when Avery talks about their awards, there's awards mentioned for 2012 and 2013 and 2014, but again, what happened to 2015? So this might cause some red flags, and those red flags might be confirmed when looking even further at this resume, and we notice that 2015 is mentioned. It's mentioned at the bottom, and it's mentioned in terms of some leadership experience that Avery undertook. But the concerning part about that is that it looks like the resume may have been updated, but perhaps this indicates that there was some trouble in 2015. And this will cause the recruiter to wonder, and not in a good way. Now, it could well be that Avery just didn't have a chance to fully update the resume and remembered one activity in 2015, but didn't fill in the rest of the amazing things that he or she did. And the problem with that is that a lack of information can also convey some opinions or information to the recruiter, and often not in a good way. And so we really want to make sure that the resume is up to date and a good, accurate representation of the relevant activities that have happened up until now. Okay, so that was the first question. What about in the second question? We asked you to shorten a too long resume. So this resume had some really impressive accomplishments, but was just way too long. And so here's what we did to shorten it and really condense and highlight the important aspects of the experience of this applicant in just one page. what I'd like you to notice in this resume sample is that we focused on the experience and the education of the applicant, put them really up front and center, so that they could shine. We condensed a lot of the description of the education into few lines, and so we could really make it concise and have the information presented on just that one page. Also notice that for certain awards, we could group them together. And so instead of using multiple lines to repeat the name of the award over and over, we could, again, convey the same information much more succinctly. Similarly, things that are too detailed for a resume and maybe a little bit further afield from the job that we're applying for, we could move over to some online space. And so, for example, we move the publications off the resume and onto somewhere that's linked from the resume. And so an interesting recruiter or interviewer could then look at those publications, but they don't need to all be presented at once. Okay. So this was the second question. And in the third question, we highlighted the problems and the dangers of overpromising. And so let's look at a potentially problematic resume. So if we're looking at Avery Abel over here, notice that Avery is a first-year computer science student. But in their resume, he or she says that they've got a bazillion different skills. Look at all of the programming languages that are listed as skills of this applicant. And that's just going to lead to a lot of red flags. And even worse, it could lead to some questions on the interview that don't highlight Avery's strengths. So in particular, if we list that we're proficient in a whole lot of different languages on the resume, then each of those languages is fair game for the interview. And so we want to make sure that what we put on the resume is really something that we could speak to and speak to confidently, fluently, and demonstrating our capabilities. On the other hand, we have this other resume by Taylor Techie, who is similarly early on in their education and lists very realistically their skills in terms of distinguishing between languages that they're proficient in from those that they've just begun. And that will not be considered as a mark against you if you're realistic about those skills, especially if the description that you're given for your accomplishments is consistent with a recruiter's expectations for where you ought to be in your current trajectory. And so it's important not to overpromise. All right, one more question we had, and this last pair of resumes were about targeting the job. And so what we want to make sure in building a resume is that we think about the position that we're applying for. Now, for example, if in the skills section we just list all skills that we've learned in part of our work experience or education, then that's not so helpful to the recruiter. It's not clear that you've really thought about what skills are required for the position to which you're applying. The recruiter can, just as well as you, read the catalog of the university at which you're studying and learn that you've worked through all of these topics. That's not so helpful. What we want to do instead is demonstrated in this resume, where Avery talks about the specific skills that are going to be relevant for this job. And so this is a lot more focused and a lot more helpful to the recruiter. So we've had 4 sample pitfalls, and now it's your turn. What we really encourage you to do is take your own resume and give it that same critical analysis that you've given Taylor's and Avery's, and make sure that it's really doing a great job of representing your experiences, your accomplishments, and how you fit in the particular position to which you're applying.
In this video, we're going to be talking about who's involved in the interview process, mainly make sure we're all clear about the terminology that we're using, as well as the roles of the different people in the process. So by the end of this video, you should know those people involved in the interview process. Let's get started with the recruiter. The recruiter is essentially going to be your advocate. The recruiter almost certainly read your resume. Now, they may have farmed out a whole bunch of resumes to another screener to determine which resumes to look at to pay more attention to, but they've almost certainly read your resume. They think you're a fit for this position, and they're going to be your primary liaison between the company and you throughout the whole process. Now, you should feel free to ask them questions. You can ask them, especially when you've got an in-person interview scheduled or a technical phone screen interview scheduled, you can ask them, who am I going to be working with? Who am I going to see? Who am I going to talk to? What's my schedule for the day? These are great questions to ask of them. They're happy to help answer them. But I do want to caution you on one piece, and that is once you've already interviewed or once you're in the process and they've told you you're going to have to wait a little bit for the next step, don't hound them about it. So don't send them email after email every hour saying, how did I do on my interview? They're working on it. They'll get back to you. If you email them too much, that's essentially a poor soft skill, and it could hurt you. Next person I want to talk about is a technical interviewer. This is almost certainly a software engineer at the company. It may be someone already in management, but it's still someone who's close to the code. They know how to program, they know data structures, they know all the core technical content. They're going to be asking you to write code, to solve algorithms problems, and again, you can assume they have this background in programming. Now, companies do vary. This person may or may not be part of your future team. As I already described, some companies are hiring just for the position, in which case you'll meet the people who are on your team, or they may be hiring for the company as a whole, in which case the technical interviewer almost certainly isn't someone on your team. The last group of people you might meet are management. Now, management really depends by the company. So in some companies, you may not meet anybody, but in other companies, like small startups, you might actually have in-person hour-long interviews with the CTO and the CEO. It really just depends on the size of the company. Now, the management often will have a technical background, but they may not. So you want to be sure about what is their background, so you ask the right appropriate level questions and kind of answer the questions at an appropriate level as well. You could always ask them what their background is. You can find out pretty quickly whether or not they've got a technical background or more of a business background. The bottom line for all of these folks, though, is recognizing that you're going to answer your questions differently, and you're going to ask different questions based on who the people are in the interview. You're going to ask different questions of management than you might ask of a recruiter, and you're going to have to ask answer questions differently to a recruiter than you would with a technical interviewer. What we're going to do next is we're going to start talking about how to succeed on that technical phone screen. So in this video, we're going to be talking through some tips and tricks to succeed in the technical phone screen. So by the end of this video, you should be fairly comfortable with what's involved in a technical phone screen, as well as how to succeed and how to set yourself up for success. So first off, congratulations. If you got a technical phone screen, that's fantastic. You've already gone through the first hurdle in the process. So by having a technical phone screen, that means that the recruiters think you have promise and that you might be a good fit for this position. But it's worthwhile keeping in mind what the role of the technical phone screen is. If you succeed in the technical phone screen, you would go on to an in-person interview. Now, in-person interviews are actually quite expensive for companies. They bring you out, they spend a whole day's worth of time with you, and they're trying to avoid essentially a mistake in that process. They want to make sure that you match your resume quite well in terms of your skills. So technical phone screen exists mainly to make sure that you are as good as you sound on paper, and that it won't be a waste of time bringing you out for the in-person interview. The format of the technical phone screen is going to consist of an introduction, you introducing yourself to the interviewer and vice versa, followed by a whole bunch of questions. Now, these questions may take a number of different flavors. They might be programming questions where you are going to be coding often in a shared Google Doc. They could be questions about data structures, big O analysis or algorithm analysis, object-oriented principles, and they can also get into some other computer science topics, core topics like bitwise manipulation, how do you write scripts, proper use of libraries for your language, as well as what's the right way to really test your code. Now, if you're nervous about programming on the fly during an interview, that's actually going to be the focus of week 2. We're going to spend a whole bunch of time about how do you code effectively in like a shared Google Doc in the environment of both the technical phone screen and on the whiteboard during an in-person interview during week 2. Let me give you some practical tips. Now, some of these might seem obvious, but these are tips that come from experience. So we've heard back from interviewers that people have essentially done this wrong in the past, and this has been part of the reason they weren't able to succeed through the technical phone screen. So here's some tips. Make sure you have a good internet connection and a phone connection. You're going to make sure you have a backup as well. So maybe the landline fails and you have a cell phone as a backup or vice versa. You also want to make sure that the internet connection is solid. The last thing you want during your interview is to have your internet connection cutting in and out while you're trying to do a programming exercise. So it'd be great if you could have that wired, and it'd be great if you could test it during the same time frame as you're going to be having your interview. You'll also want to make sure you already have your Google Hangout and your Skype account set up to make sure that when you first fire up Skype, it doesn't do that update. Right? We've all had that experience. It's 2 minutes before your meeting time. You pull up Skype and it updates for 10 minutes. You don't want that happening during your interview setting. Right? So make sure it's already up and running long before your interview starts. Now, if you are going to be using a Google Hangout or Skype for your interview, make sure that you look at the camera, not yourself. It's really tempting to look at yourself during these interviews, but it's much more genuine to the person seeing you if you're looking at the camera instead. You'll also want to avoid small nonverbal cues. You don't want to do a really slight nodding of the head, because if you do that, it may not come through depending on the internet connection. So you want to do either, if you're going to do nonverbal cues, do big things like thumbs up or really long exaggerated nods, or just use a verbal cue and say, oh yeah, I understand, or okay. And then all of this, your Skype, your internet connection, your phone connection, has to be tested before the interview. And I strongly recommend you grabbing a friend who'll be somewhere else. They set up Skype, you set up Skype, and try to mimic the exact phone interview setting to find out, well, oh, shoot, the internet actually isn't very good in the office this time of day, or things like that. Some other tips. So if you're going to be working in a non-visual environment, so you're just doing a telephone, it's okay to have notes. I recommend having notes either if you have Skype or you're working on telephone. And those notes would be something like a resume, as well as some other things to take notes on. But if you have completely non-visual, you can have even more notes. Your notes about the company, or other things you want to highlight, some talking points for the interview that you want to hit on. But don't rely on those too much. If every time they ask a question of you, you're shuffling through papers, they're going to catch on and it won't come out very well. You'll also want to make sure you have some way of relaxing beforehand. It's really easy to get stressed out before a phone interview. And what we're going to do in a later video is talk about how you can relax before this interview so that you can succeed. But one of the biggest pieces to being relaxed is knowing that you're prepared. And the best way to be prepared is to have practiced this and to have known and to know your technical knowledge. I want to give you just a couple of pitfalls that are very common in the technical phone screen. The first is not talking. A surprising number of candidates will be asked a question and it goes dead silent for 5 minutes, and there's still nothing. And the interviewer will say, well, could you tell me what you're thinking right now? And they'll get a quick, okay, yeah, just 1 sec. Another 5 minutes of no talking. This is not good. You want to make sure you have a dialogue with your interviewer. Now, even if you've said just a couple of things with the interviewer, you really want to make sure that's a full two-way dialogue. An example mistake here would be they ask you a question and you immediately start coding. You don't want to do that. You don't fully understand the question yet. You want to make sure you go back to the interviewer, ask them follow-on questions, make sure you understand the question properly so they can give you hints. They could say, oh no, it's not actually this problem. I think you're trying to think about trying to solve this. We're trying to solve this instead. And that way when you do actually go to solve the problem, you're solving the right one. Likewise, you'll want to give them some high-level ideas about what you're going to do with your coding. And then they can give you feedback about, oh, that seems like a reasonable direction, or they might say, I think you might want to be thinking about this differently. You haven't thought about this scenario. So the more you have a dialogue with them or a conversation, the better. One of the other big mistakes is just not being prepared, not having your Skype connection set up beforehand, not having the technical knowledge you're supposed to have, and just not being ready for the interview. The last piece is actually a bit more subtle, and that's not having your resume highlight your strengths. So you might have thought when you're writing a resume that'd be a good idea to put in any language you've ever touched as a language you're proficient in. But this is a great way to make a mistake. Let's say you've coded just a little bit in PHP. You knew it once for a project 4 years ago. And now during the actual phone screen, they're going to say, could you code up this algorithm in PHP? That could be really bad if you can't program in PHP. You're going to have to say something like, well, you know, I'm actually not that proficient in this. Let's switch to another language. And if you do that a couple of times, that's going to be really problematic because they're going to say, well, what part of this resume is actually accurate and what part isn't? But it's also a mistake because you've just shown a weakness because you didn't know a language that was on your resume. If you just put on your resume that you weren't proficient in PHP, that you had some knowledge of it, but that you're proficient in Java, you would have set yourself up for success. So this is where the resume really ties in well with the technical phone screen. So now that you have some basic tips and tricks for the technical phone screen, we're going to talk some more about how to succeed for the in-person interview next. So now that we have a good feel for what's in the technical phone screen, the next step is the in-person interview. We're going to give you the format of the in-person interview as well as a number of tips to help you succeed during that interview. So first off, if you get that in-person interview, congratulations. That's great news. It means that they were happy with your resume and you succeeded during the technical phone screen. At this point, they think you could be a potentially good fit for the job. And now it really comes down to just that in-person interview. The format of the in-person interview is going to consist of a number of interviews with a number of different folks. And those folks might be software engineers, they might be, again, recruiters, they might be managers, but we're going to focus a bit more on just the software engineer interviews. And those interviews, whether you have 3 or 5 of them during the course of the day, are all going to be around 45 minutes, and they're all going to consist of an introduction, just a quick hello, and then almost immediately you're going to dive right into programming at a whiteboard and/or just trying to solve a large, complex problem by making a large complex algorithm. In solving the problem, you're going to use data structures, and you'll probably do some kind of runtime analysis of the problem. Other CS topics may be fair game, and that includes like bitwise manipulation or logic problems or testing. The other piece that's fair game is anything you've got on your resume. So if you've said you're an expert at something, you're proficient at something, this is our opportunity to ask you about it, and they will. Now, we've gone to industry and asked, what are you looking for during the in-person interview? And this is one of the answers we got back. And I want to just focus your attention on the section I've highlighted. They're interested in engineers who can solve new problems. That's fantastic. I mean, that's what you do during the job as a software engineer. But I know that also puts more stress on you. Now, the good news is, if you feel stressed about trying to solve new problems, that's our entire focus of week 4. All of week 4 will be spent helping you succeed in solving new problems during this in-person interview. So now we know what they're looking for. How are you going to succeed? And we got these tips again from industry. So first off, it's completely okay to question your interviewer. A number of candidates come in and they think that it's supposed to be a one-way street. The interviewer asks them questions and they answer, but they can't ask back. You can ask questions and you really should do so. Whenever you're asked to provide a solution, you should first define and frame the problem as you understand it. Just doing so will help clarify the problem and also make sure that you are actually solving the same problem as you've been asked to solve. And if you don't understand the problem or you get stuck at any point, you can ask for help or clarification. They're happy to help clarify what the problem is that you're trying to solve. If you feel like you need to assume anything, you need to check with them before you make those assumptions. It's important to do so because you may be making assumptions that aren't fair game, and just by having that conversation with them about the assumptions, they get a better feel for what you're thinking. You'll also want to describe before you start coding how you plan on tackling the problem. It may be that through that process of saying, well, I plan on solving this problem using data structure X. And as you talk through how data structure X is going to be used, you'll realize, well, maybe data structure X wasn't the right fit. Or they may even prompt you, well, maybe you should try thinking about other data structures. It's important to give them that high-level overview before you start coding. As you are working through the problem, the more you can talk to the interviewer about your thinking process, the better. In a way, they're testing you more on your thinking process and how you go about solving problems than they are about solving a specific problem during the interview. Now again, if you get stuck, they may provide hints. They may try to help you. But they can only really do this if you're thinking aloud. If you are talking aloud and it's clear where you get stuck, that's where they can help you. But if you're not talking aloud, they don't know where you're stuck, they can't help you. And finally, and I can't stress this one enough, you've got to listen to the interviewer. I know it's a high pressure situation, I know the interviewer is asking you questions and you're trying to think it through, but if the interviewer makes comments or adds suggestions, listen to them. They're often trying to help you and you can't afford to miss those hints. You will see these tips again. So these are going to be a common theme all throughout our course. You'll see them in different contexts as we talk about various components of the interview, but you'll definitely see these tips again, and they're absolutely critical tips from industry. I also want to give you just a couple of practical tips. And these may seem really obvious, but for all of these, I can tell you a scenario where I know of a student who went to an interview and forgot to do these. For example, sleeping. You need to take care of yourself. You want to sleep before the interview. And I've heard of students cramming in an algorithms text the whole night before their interview and then walking into the interview totally dead. That's a huge mistake. Don't ever do that. You also need to just eat. Make sure you eat foods that are going to make you feel energetic, not sluggish, and just take care of yourself in general. You also want to be prepared. And there's a saying that I remember back from sports in high school, which was, there's only two things you have to remember for a trip. That's your uniform and your medications. So if you have any medications that you need, make sure you're bringing those on your trip. Well, what's your uniform? Well, your uniform is what you're going to be interviewing in. So we've all heard the story of the person who flies their interview in shorts and not very appropriate t-shirt and flip-flops, and then loses their bag. And then they go for their interview in not good professional wear. Don't do this. So first off, make sure you put your bag that has your interview clothes as a carry-on. And the second piece is wear clothes you'd be comfortable in an interview with on the plane. I know it's a little less comfortable, but you'll feel a lot better knowing that you have a backup pair of clothes for the interview. Other things to bring, obviously bring your resume, copies of your resume in case interview is asked for them. Bring any projects that you've done in the past that you want to showcase if they're portable. Obviously bring a notepad and pen to take notes. The last piece is important, and that is talk to your recruiter. So your recruiter can give you your schedule for the day and may also give you some tips about who you're going to meet with and what they're looking for. And that leads to the third tip, which is relax and mentally prepare for the interview. Now, this is going to vary by person. For me, I like listening to some mellow music, and that helps me relax and feel more comfortable before stressful situations. For you, it might be meditation. Whatever is appropriate. You want to relax, put yourself in a good state of mind before you start the interview. Along those lines, I strongly recommend the TED Talk on power poses. So let me just show you an example of a power pose. So this is the classic Wonder Woman power pose. Now you might think that's kind of silly, but the reason for a power pose is they've done scientific studies that show that just standing that way for 2 minutes can improve your confidence for some time period after. So if you've got some dead time before the interview, find somewhere private, run into the restroom and just do a 2-minute power pose, and you'll actually boost your own confidence physiologically before the interview. So the 4 pieces of the interview are to introduce yourself, write code, describe prior projects, and solve new problems. Those are the 4 things you're going to be asked to do during interviews. If you want to jump to the one that feels most applicable to you, feel free to jump to the appropriate week. What we're going to do next is start diving into how to introduce yourself during the interview. I'll see you there.
So, one of my first phone interviews, leading up to it, I was so nervous because I had no idea what to expect. It was going to be a complete stranger on the other line, and I went into it just completely frazzled. And I tried lightening the mood with one of the problems that he asked me, so I cracked a little joke about not really remembering some algebra. And I remember the interviewer got furious with me because he was going off about how in computer science you really need to know your basics of like math and algebra, and he uses them every day even though he was in school, like out of school way longer than I was. And I absolutely flipped because here I am, I upset the interviewer, I was nervous out of my mind, I actually froze in the interview and I couldn't go on and answer the question. I was so nervous because I had offended him. And yeah, that was a really rough interview. And I finished it with this absolutely dreadful feeling of I offended the interviewer. I didn't answer anything because I offended him, and that was the only thing I could think about. And after that interview, I felt terrible. But what ended up really helping me was I talked to my brother, and he just let me know that your worth isn't in one interview. That could have been a bad day for me, a bad day for the interviewer, and together it was just a bad combination. And sometimes that just happens. There's always another day, another interviewer, another interview question, and for the most part, an interview doesn't define you as a coder.
In this lesson, we're going to focus on introducing yourself well and with confidence. So we're going to do that in a couple of ways. First, I'm going to give you some tips and hints about how to prepare your introduction. Then we'll work through some good and bad examples, and then you'll get some practice introducing yourself and then getting peer feedback. So let's get started with that first piece. So by the end of this video, you should be able to identify common best practices in an introduction and recognize the need to tailor your introduction based on your audience. So every interview is going to have an introduction. You're each going to say, hi, my name is this, and you go back and forth. But then what often follows, not all the time, but some of the time, is they're going to follow up with the question, well, tell me a little bit about yourself. Now, this is not the time to ad-lib. The answer should not be something along the lines of, well, I'm a Scorpio, and I really like running, and I had a really good bagel sandwich this morning. Not a good answer. So if that's not a good answer, what's a good answer? Well, to arrive at that, we have to have a better feel for why are they asking you this? Why are they asking you to tell a little bit more about yourself? Well, they're asking you for 3 reasons, at least 3 reasons. And these are, they want to know, they want some reassurance that they've made a good decision bringing you out for the interview. They want to know that you are still a good fit for the job, and they want to hear that you're a good fit. Basically, what's your background, and how does that background apply for this job? They're also using it to help spark conversation. Based on things you say, they're going to have questions to ask you, which will spawn more conversation. And they also want to see what you think is important. If you've only got 30 seconds or 45 seconds to introduce yourself, what do you choose to put there? It says a lot about you. So let's get back to what you're going to say. So you can vary this a lot, but I'm going to give you a rough template. And you can come up with different ways of organizing these on your own, but this might be a good place to start. So start with who you are. So what's your present position? What are you studying? What field do you work in? And then give a little bit about your background, what you're interested in, and what you've done in the past. And then give a recent accomplishment that fits really well with the position that you've applied for. And then tie that to the position if you can. So let's do an example here. So this is for one of our undergrad students, an imaginary undergrad student here at UCSD. And when they're asked who you are, they're going to talk about, well, they're a third-year undergrad. If you're already in industry, here you'd say something like, I'm a software engineer at company X. So the next piece is, what's your background? So if you're a student, you're almost only going to talk about coursework that you've done associated with this position and what you're interested in doing. If you're already in industry, again, you're going to talk about what you're interested in doing, but you might talk about, well, I spent the last 5 years working on developing the software stack or something like that. Then you're going to talk about a recent accomplishment or project that you've done that fits well with this position. So if you're in a company, you might talk about a major achievement at your company that's happened recently. Or if you're a student, you might talk about a large course project that you've done. So if you've done our entire specialization, one of our projects from one of the previous courses might be a good thing to talk about. You can also talk about potentially the capstone for this course, for the specialization. Either way, you're going to want to talk about a project that applies to the position and then relate it back to the position. So let's just kind of run through this example. What would this sound like? It'd be something like, hi, well, I'm a third-year undergrad student at the University of California, San Diego, and I'm studying computer science. I'm incredibly interested in designing intelligent hardware, so I've emphasized my coursework on computer hardware, computer architecture, and machine learning. And last year we had this incredibly interesting project where my team got to design from the top to the bottom, from the smallest circuit board all the way up to the software that was running on it, a semi-intelligent quadcopter. And I'm incredibly excited about doing projects like this at this company. Okay, so with that kind of introduction, let's see if that's going to meet the needs of the interviewer. So let's revisit these criteria. Did I reassure the interviewer that I have the background for the position? Well, if this is a position that relies on computer science skills, machine learning, and computer architecture, yeah, I absolutely did, right? I've told them I am in computer science, these are the things I do, and yes, I'm still a potentially good fit for this job. Did I spark conversation? I think I did. I mean, after that introduction, the immediate question from an interviewer would be, well, what did the quadcopter do? What could it do? You said it was something intelligent. Could it fly itself? Could it just hover on its own? Could it navigate obstacles? Where were you going with it, and how did you design it? And then we told them what was important with that introduction. We said that it's important. The key piece there is that you're really interested in intelligent hardware systems, and you have the background to match that. So if this position is intelligent hardware systems, you've done a really good job introducing yourself. There are a couple of additional criteria I want to mention. You want to be organized and brief with this. You want to have your introduction 30 seconds, maybe the max of a minute. This is not a time to go into a 5-minute discussion. You don't want to have it disorganized. This is not a time to say, well, I was born here, and then give a long chronology of your life. Again, you want to rehearse this and so that it's organized and brief. You also want to make sure you convey confidence, and you want to present it in a professional demeanor, and you want to make sure that the introduction is appropriate for the position. Now, all of these points we're going to talk about more in our next video, which will be some good examples and some bad examples. But I do want to talk a little bit more about this being appropriate for the position. After you've got a really good introduction, it's really tempting to just stick with that one introduction that you did, this one company that went well. But you can't do that. You're going to have to tailor it for each company. And I'll do a personal example here. I've got a background both in computer architecture and in computer science education research. If I were applying for a position at a company like Intel, I'm going to talk a lot about my hardware background. If I'm applying for a position at, say, Coursera, I talk a lot about my education background. Depending on the position you're applying for, you're going to tailor your introduction. So next, we're going to dive into some of those examples of good and bad introductions. I'll see you there. In this video, we're going to walk through some example introductions. We're going to see some good ones and some bad ones. So by the end of this video, you should be able to identify common errors when introducing yourself, both in terms of content of the introduction, as well as your demeanor during the introduction. So first off, for the context here, we've acted out a few introductions. In each of these cases, Christine or Mia has pretended an undergrad who's helped create one of these courses in the specialization. What we'll do is some common not-so-good introductions, followed by good ones in each case. So let's start with the content of an introduction, and let's look at our first example. So tell me a little bit more about yourself.
So I'm a student at UC San Diego, and I'm a computer scientist. I'm a computer science major, and I really love computer science. I love my classes, and I'm really excited about computer science, and so I'm really excited about this job because I just love programming so much.
So she was really enthusiastic, right? I mean, she was good in terms of enthusiasm, but there was no content here. I mean, she didn't tell us anything about herself. And this isn't really that uncommon for someone who's been put in this position to give an introduction. They're really excited about the position, they're really excited about the interview, and they just say a whole bunch of stuff about why they're excited and forget to say anything about themselves. So let's try another example. So tell me a little bit more about yourself.
Sure, I'm a computer science student at UC San Diego, and I have an extensive resume. I've worked on about, I'd say, 10 projects in about 10 different languages, so I'm very proficient. I'm an expert, really, at C++, at Java. I've done some server-side programming. I could do that. My expertise is very broad. I've done many different projects, and so I really think that I'm well qualified for this job, and I'll just be able to blow away any task you give me.
Wow, that's a slightly overconfident student. So this student is claiming they're an expert in 10 different languages and can succeed on any task given to them. That's pretty unlikely, and that seems pretty boastful. I mean, this is worrisome from an interviewer's perspective because there's a clear disconnect between that person's self-perception and their actual ability. And that's really scary for an interviewer and for a company. And you know, this kind of behavior isn't that uncommon either. And it's really the result of someone trying to artificially show confidence and coming off as just way too overconfident. So let's try to look at one more. So tell me a little bit more about yourself.
Sure, I'd love to. I'm a computer science student at UC San Diego, and I have been in the computer science major for a couple years. And in the last year or so, I've gotten involved in this MOOC development. I'm helping my professors develop a MOOC that's aimed at kind of intermediate programming students. I've been doing some support work, developing some of the graders, and I've just really become passionate about this idea of massive open education and making it really better to reach out to many more students. So I'd really love to apply that passion and the technical skills I've developed to this job.
That was fantastic. Did you notice all the positives here? She gave a background on who she is. She gave a concrete example of a big team project that she's been part of. It shows success both on projects and success working with teams. And she left a huge opening for follow-up questions about all the things she's talked about. That was a fantastic introduction in terms of content and really also in terms of soft skills and delivery. But let's focus on those soft skills and delivery next. So in the next video, I want you to focus on Mia's demeanor. Can you tell me a little bit more about yourself?
Okay, so I'm a computer science major here at UCSD, and I've been in the major for a couple of years now.
Can you tell me some projects you've worked on?
Oh, right. Okay, so I'm involved in this MOOC, and basically do what the professors tell me. So it's an intermediate Java programming MOOC. Yeah, so we do some beta testing and yeah.
Okay, I probably didn't need to tell you to pay attention to her demeanor. Did her interaction in any way convey confidence? No, right? She had poor eye contact, she was fidgeting, had all these gestures where she was covering her face, she had poor posture throughout. All those things combined just convey a huge lack of confidence. Now, perhaps the entirety of all these behaviors is a little uncommon during an interview, but you'd be surprised how many people exhibit at least some of these behaviors when they're nervous and put in a pressure situation. So let's see Mia try this again. Can you tell me a little bit more about yourself?
Sure. So I'm a UCSD student. I've been a computer science major for a few years now. And I've been working on this MOOC project that's really exciting. We get to work with a big team all together, and under the guidance of the faculty members, we've been doing beta testing and also developing some of the projects and thinking through some of the questions, really trying to tie together where the technical concepts would be challenging for a wide audience. And I really like solving tough programming projects, but also communicating them with other people and working together as a big team.
That was fantastic. Notice she had good eye contact, she had good posture, she didn't fidget. Her demeanor in this second video, which is really Mia's standard demeanor, shows really strong confidence. So what we're going to do next is we're going to have a peer review assignment. Well, you'll get to try to do this.
So last week, Leo talked with you about the different stages of the interview process. And one stage was the technical phone screen, where you're asked to live code in a shared Google Doc with someone on the other end of the line. Now, live coding is used to gauge your fluency in programming languages, and that can seem a little bit intimidating. And so this week we're focusing on demonstrating your coding skills and doing so in an effective way in the interview. Now, the most important part of getting ready for the interview is to practice. And so without any further ado, the first thing you're going to do this week is actually start doing some live coding and recording yourself doing it. Now, once you do the assignment, we'll come back and think about how to evaluate and improve your strategies for live coding. So now that you've heard about the importance of the technical phone screen and in general the challenges and the weight that is placed on live coding exercises, we're ready to really start practicing and preparing. And so what you'll be doing is recording yourself, but you'll be the only person who sees this recording. So we really want to try to make it as authentic as possible and really give yourself an opportunity to evaluate yourself and assess where you want to go further. You first want to make sure that you're set up, just like you did in week 1. And what you want to do is make sure you've got a working microphone, you've got some headphones, you might want to set up a camera. And then in order to get ready for this mock live coding example, you want to open a new blank Google Doc in which you'll be doing the live coding. So you'll be typing in that Google Doc. And then actually start recording before you see the question. And that way you'll be able to capture your authentic reaction to the question and how you do the problem-solving process from beginning to end. Now, once you start recording, really try to imagine yourself talking to a recruiter or an engineer on another line. And what you want to do is pretend that you are in this interview situation. And that way you can try to make it feel as real as possible. Solve the problem in a way that will highlight your knowledge and your expertise. And then afterwards, we'll talk about assessing those strategies. So you've started the recording, and now it's time to get your question that you'll be working through in this live coding exercise. We'll give you this question through a quiz on the Coursera platform coming up right after this video. And what you'll be doing is entering a little bit of information to get one of several possible questions. And that way you'll be a little bit surprised, perhaps, when you get this question. And that's going to be the case as well when you're doing an actual interview. You don't know ahead of time what you're going to be asked. And so you get this question and immediately start role-playing as though you are in this interview, and think through and talk through and work through how you would solve this question. So in the Google Doc, develop your solution while you're recording, and then once you finish, you can turn off the recording. And throughout this week, what we'll be talking about is how to assess that recording that you have of yourself, how to look for ways to improve, how to look for things that you've done well, and then at the end of the week, we'll revisit the activity and see how much you've developed and grown.
All right, you've had a chance to practice with that live coding in the Google Doc as you would do in a technical phone screen. It was pretty challenging, huh? Well, if you found it challenging, you're not alone. A lot of people find this task very, very challenging. So in this lesson, we're going to give you some skills to get better at this task. So by the end of this video, you'll be able to describe common pitfalls that people run into when they do a technical phone screen live coding problem. So first, we're going to introduce you to Huang. Huang is a computer scientist here at UCSD, and she's a rock star. She's fantastic. But she's agreed to act in these videos to illustrate some of the pitfalls that people run into when doing these live coding problems. So you're going to see Huang answering a question like one that you would get in a technical phone screen. Her question is to convert a string into a number. Write a Java method to convert a string into a number. So let's take a look and see how she does in her first attempt.
All right, can you write a method that will convert a string to a number, please?
Okay. I guess I'll start with writing a method that takes in a string and returns an integer. I think, if I remember correctly, there is a library called that I can just use. Yeah, I think I'm done.
All right. Can you do it again, but don't use that library call?
Not sure what to do.
Well, can you think of a way to process the string, maybe character by character, to create the number?
Okay. Okay, I think I'm done.
Okay. Can you maybe think about, I see a little bit of a problem with what you're doing in the body of the for loop. You have the right idea, but are you sure that's going to work?
Yeah, I'm looping through basically every digit, and then when they go to the next place, I'm multiplied by powers of 10, and then I add them together. It should give you the right value.
All right. Well, thank you.
All right, thank you.
Okay, so at this point, you're probably saying, oh, poor Huang. She's just not going to get that job. And in fact, the recruiter on the other end is probably thinking pretty much the same thing, like, oh no, this is a train wreck. How much longer do I have to listen to this poor woman do this coding? Because, you know, she's just not somebody that we're going to hire. So this is a bad situation all around. You don't want to find yourself in this kind of a situation. Now, what went wrong in Huang's video? we're going to look at 4 aspects that really are key pitfalls that people run into when they're doing these live coding problems. So the first thing was that Huang made a whole bunch of assumptions about the solution to the problem and about the problem itself that she shouldn't have made. The second thing that you probably noticed was there was a lot of silence in that video. While she was thinking and typing, she wasn't saying anything. So it was impossible for the person on the other end of the phone screen to really get into her head and help her out where she needed help. And believe me, interviewers do want to help you. They're not trying to make you fail. They want to see you succeed. So you need to let them into your head a little bit. The third thing was that when she did make errors, she wasn't capable of correcting herself in those errors. She wasn't taking the recruiter's hints and turning them into better solutions. And then finally, when she was finished, she just sort of quit and said, okay, I'm done. That's not how you want to end this kind of a problem. You want to really go back and think, oh, does my solution work? Let me work through some test cases. So we'll look at each of those aspects of what went wrong in her interview and show you how she could have done things better. Now, one thing that you might be thinking is, oh, well, if she was just like technically stronger, things would have gone better. But in fact, there's a ton of room for improvement, even in a situation where you still make mistakes. You're going to make some mistakes in your technical phone screens. That's okay. But the key here is, what can you do to make things go as well as possible, even in the face of where you don't exactly know the answer or you get off on a wrong path initially. It's not all lost. You can get yourself back on track and have a very strong interview. So let's dive in to look at how to solve these issues. All right, so the next pitfall we're going to talk about is silence. You remember from Huang's video that there was a lot of long stretches of periods where Huang was just typing and not saying anything. And that's definitely something you want to avoid in a live coding situation, especially on the phone. So by the end of this video, you'll be able to talk through your thought process as you're solving technical problems in that live coding situation. Nobody's going to expect you to be able to solve the problem immediately with no thought. But the important thing to keep in mind is that the interviewer who's on the other side of the phone, or even if the interview is in person, can't hear what's going on in your head. They have no idea what you're thinking about. So if you don't say anything, they don't get any information. So if you remember back to when Huang was doing that coding example, in particular when she was writing that loop that looped through all the characters in the string, she was just typing away and she was making some mistakes, and the interviewer really didn't have a good sense of what she was thinking at that point. And when she did talk, she really said not too much more than what she was already typing. So let's take another look. Let's take a look at Huang's next attempt and see how she does a much better job. Her approach is pretty much the same as it was in the first video, but she does a much better job of thinking out loud, letting the interviewer into her head, and you'll see how this causes the interviewer to really give her some key guidance at different points along the way and help her come to a better solution.
So I think I'll try to somehow get each individual digit. I think there's a library function that converts a string to a char array. Is it okay if I use that?
Sure.
Okay. So let me declare a char array. I think is it okay if I don't have the exact syntax for?
Yeah, that's fine.
Okay. Yeah, it's hard to remember the API without the Google Doc or the Java Doc. Okay, so input. Okay, so now I have the string parsed into a char array. I can loop through the array. And I listen. And I know it should be length, not, because length is a field with arrays, not a method call. And I'm going to increment my index, and here we are. And so if I'm looping through each digit, I'm going to multiply it by powers of 10s. So I'm gonna need an integer that keeps track of the value that I want to return in the end. And so I should add the digits to this value and multiply it by powers of 10, and there's a pal function in the math library. So 10i, and then I can just return value in the end. Value in the end.
All right, you said you wanted to add that value,
Oh.
value every time. You probably meant.
Yes, sorry, I missed the plus sign. There you go. Yeah.
Great.
All right, so you saw that when Huang thought out loud, things went much better for her. Because again, these interviewers really want to help you. They don't want to see you struggle. So by letting them into your head and know what you're thinking, you'll really give them an opportunity to do so. So no matter what is going through your head, no matter what idea you have, even if it seems totally off base, talk about it. You might preface it by saying, well, all I can think of is something kind of that I know isn't right, and here's what I think it is. That's a great thing to say. That really helps the interviewer help you with your process. So keep talking.
In this video, we're going to be focused on that first pitfall that Christine mentioned, which was making too many assumptions or failing to clarify the problem. So by the end of this video, you should know that when you're given a problem in a technical phone screen, you're going to start by asking clarifying questions about the problem, as well as identifying potential issues with the problem. When you're first given the problem, this is the time to make sure that you really actually understand the problem. In this clip, let's focus on how Huang does during her poor interview example.
Okay.
So in this video, you see her dive right into the code. But I've got to ask, how is she coding this problem? I mean, how can you solve a problem if you don't fully understand it yet? And you can almost immediately think of these various conditions she hasn't thought about yet. Is the input going to have negative values? Is it going to have E? Things like that. She hasn't clarified it all yet. And when you're first posed that question, that was the time for her to ask those clarifying questions. Asking those clarifying questions is an important part of the interview process. So let's see how she does in a better example.
Okay. I want to go through some examples to make sure I understand the question correctly. Can I, is the string going to be integer? Can it be floating point?
Well, ideally, yes, but let's start by just thinking about how you would do an integer.
Okay, so I can assume, let's say, if I'm given a string 1, 2, 3, and I should get back 123. Is that correct? Okay. And I don't have to consider numbers like E or pi, anything like that, right?
No.
Okay.
No, and in fact, you can stick with positive numbers for now.
Okay. And can I assume the input is just a string, plant string?
Yes.
Okay. So public int.
Much better. So she asks key questions about the nature of the problem, and then she asks clarifying questions like, does this have to handle decimals? Does it have to handle values like E or pi? Does it have to handle negatives? She's asking really good questions. And now that she has a better understanding of the problem, she can actually start coding. So I want you to step back just a second, though, and think, what did this tell the interviewer about her? It says that she knows how to think through corner cases, and she's careful about understanding the problem very well before she starts solving it. Now, she's done a great job starting this conversation with the interviewer. Don't stop talking yet. In the next video, we'll discuss the importance of talking throughout the entire technical phone screen.
So let's continue our analysis of this example of coding on the fly, and we'll focus on another pitfall this time, that of mistakes. So by the end of this video, you'll be able to think about how you find and recover from mistakes when you're doing live coding in the technical phone screen. We all know that when you sit down to write up a new program, there are going to be bugs. They're just part of development, and especially when we're trying to solve a problem while also implementing the solution at the same time, We all make mistakes. And so the interviewer who is seeing your process developing your solution in the technical phone screen expects you to make some mistakes. This is okay. It's not surprising if your presentation is not going to be flawless. But what the interviewer is interested in is how you recover from these mistakes, what you do about them. Do you even notice that they're there, and can you fix them? So let's look at an example of how Huang can recover from a mistake that she makes.
Okay, so let me go back to my example. So if my input is 123 as a string, then oh wait, then I'm going to have the number reversed. So let me see. Okay, well, basically what I want to happen is to have 100 plus and then I can just add the char array, or the character that I'm looking for here.
So notice how in this example, Huang was able to find her mistake by tracing through the code that she had written. So she had written some code, and then the interviewer prompted her to take a look at it because something wasn't quite right. And so she went back to the example that she started with and very carefully looked at what the code that she had written would do with that example. Now, something that's important to do when you're tracing your code with an example is to focus on what you wrote rather than what you intended to write. Because it's very easy to have a solution in our head and work through the example as though we implemented the solution that's in our head. But sometimes there's something that gets lost in the translation as we implement that solution in code. And so Huang was very careful to see how the for loop behaves with a particular example and therefore recover from that mistake. Now, she acknowledged the mistake, which is important, and she explained how to fix it and went ahead and fixed it and implemented the correction. But what's also important is that she didn't get overly flustered about the fact that she had made the mistake. She didn't get down on herself. She was able to continue in a professional and knowledgeable way. And that's very important as well. You want to make sure that, that you're demonstrating resiliency as you're working through this interview. Now, even once there was this correction, the interviewer prompts Huang once again. There's still something wrong. And so let's see what happens next.
No, not really.
So think about the way that...
So there was still a bug in Huang's code even after she made that first correction, and the interviewer spotted it. And notice how the interviewer wants Huang to succeed. She wants her to do well. And so what she's doing is prompting her, well, can you look at this again? And Huang at this point isn't seeing the mistake. And that can happen. Sometimes we just don't know where the bug is. We don't know what's going wrong. And especially in the Google Doc platform where we don't have the compiler that we can run and maybe do some testing on some sample cases and try to debug that way, we might feel stuck. And that can happen in the technical phone screen. And what you'll notice is that Huang asked for help. She asked for a hint. And if you're stuck, then what's important is to reach out for help. And the interviewer may well be able to give you a hint that can get you unstuck. And what's important then is to really listen at the hint that you're given. And so Huang listened to the prompt to think about string representation, integer representation, and she cracked the nugget. She figured out what was the issue, which was that she wasn't using the integer represented by the character, but the ASCII value of the character itself. And then she was able to make the fix.
Oh, I guess ASCII values are different from integers, and I'm adding the character right away. So
so careful listening and also asking for help is a really important part of recovering from mistakes in the technical phone screen.
In this video, we're going to focus on the fourth pitfall that Christine mentioned, which is failing to test your solution. So failing to trace through your code and failing to consider edge cases. So by the end of this video, you should be able to recognize the value of testing your code when you finish your technical phone screen. So let's just think back about you programming on a computer. So you finish a draft of your solution, and what usually happens? Well, you're going to hit compile, and it's going to almost certainly give you some syntax errors, which you fixed. And then you're going to run it, and you're going to encounter some errors, which again you fix. And this process is essentially done for you by the computer. In a technical phone screen or an interview where you're doing this at the whiteboard or on the phone in a Google Doc, you have to do this yourself. You have to play computer, emulate your code, and find the bugs. So in the next video, let's see what Huang does at the end of her bad interview.
What you're doing in the body of the for loop, you have the right idea, but are you sure that's going to work?
Yeah, I'm looping through basically every digit, and then when they go to the next place, I'm multiplied by powers of 10, and then I add them together. It should give you the right value.
All right. Well, thank you.
All right. Thank you.
Yikes. So in this video, she doesn't bother checking her code. So she has an opportunity right at the end to trace through it. There's a glaring bug in there, and she just says, nope, this looks like it's right. I coded it. It's good. And then she made another huge mistake, which is that the interviewer actually prompted her to maybe look at her code again, and she still didn't trace through it. I really believe if she just traced that code and listened to that hint, she would have caught the bug. But as a result of not listening, she actually finished her interview with not working code, and that's not a good thing. So let's see what happens in Huang's good example at the end of that interview.
Let me just run through this example again to make sure that it absolutely works. So again, I have the char array, and when I equals to 0, I have value equals to 0 times 10 plus 1. So then I have 1. And when I equals to 1, I have value which is 1 times 10 plus 2, and then that gives me 12. And when I equals to 2, I have this times 10 plus 3, which gives me 123. So this should work.
Okay, great.
Awesome, thank you.
Thanks.
Fantastic. So she double-checked that her work works. So she traced through her code. She found that it does in fact produce the output that it should for a given input. And her next steps might have been to try to consider other cases, but it's also possible the interviewer may have said, okay, well, let me change the conditions a little bit. Let's solve a slightly different problem. So just to wrap things up, if you're writing code on a Google Doc or a whiteboard, it's up to you to do the testing. So you want to trace through your code for errors, anticipate edge cases, and you'll want to do that definitely before you finish the interview.
All right, so you saw Huang struggle through a really bad example of this technical phone screen. And then you saw an improved example of how Huang used some of these skills that we've been talking about to avoid the pitfalls she had in her first interview example. Now let's take another look at how she would actually do in this technical phone screen situation. Because as we mentioned at the beginning of this lesson, Huang is actually a rock star. She's very technically solid. She knows how to solve this problem. She doesn't necessarily do it exactly perfectly the first time, but if she were in this technical phone screen situation, she would have a very solid technical background and get the answer to this problem right, pretty much in the first try. And many of you will be in a situation like that in your technical phone screens. You may not struggle that much solving the problem. You may have to think about it, but you'll get the answer right. So let's take a look at what a very good example of a technical phone screen interview would look like by looking at how Huang does it.
Okay, so I'm going to go through an example first to make sure that I understand this question correctly. So I'll be giving a string. So let's say, like, I get a string 120. So can this string be like a negative number, or?
It could be, but let's just start with positive integers.
Okay, so I don't have to worry about floating point or like number e or pi. Okay.
Not right now. Then I'll ask you to extend it afterwards.
Awesome. So, and then I should get back 123 as the output.
Yes.
Okay. All right. So okay. So so what I think I will do is I will convert the string into a char array so that I can separate the digits, and I will add them back up to an integer. So string to num, and then string as the input. Right. So is it okay if I use the library function that converts the string to char array?
Yes.
Okay. Okay. So char array. So I believe there's a library method that just converts a string to char array.
It's actually a method on the string object itself.
Oh, okay. So it's just input dot to char array. Oh, and is it possible for the input to be empty or not numerical? Should I consider that?
You should definitely consider that case.
All right. So in this case, if my arrays or my string is empty, I would throw an exception to tell the user that they entered an illegal argument. So input is not string, and then so then they can enter different. Or is it okay to like just return 0?
Well, what do you think? Do you think we should throw an exception, return 0? Which one's better?
Well, if we return 0 in this case, we might not know if what happens if the user actually enters 0. We could return a negative number, but then we have to worry about it later, what to do when this method does return a negative number. So I think throwing an exception is the best case here.
Sure.
Okay. So I'm going to throw new illegal argument exception. And I'm going to say must be a valid number string. And then I can check later if my digits are indeed numerical.
All right, so you said this, so I know you know, but I think you mean to throw that exception when input is not, when input is empty, not when it's not empty.
Oh, yes. So this should be equals, and actually I shouldn't be using equals at all because it's a string and string is an object. So in this case, I should be using equals to actually check the equality. And I want to make sure that the input is not null because I assume that it could be null as well. So if input is null or that is empty, then I'll throw in illegal argument exception. And I think I'm ready to loop through the char array. So this is just a for loop construct, and getting the length of the char array, and length is just a field inside the array. And then inside this for loop, I'm going to loop through each digits and then add it to a integer value. And this is what I will be returning later. So I can just do some simple math by multiplying 10 to increase the number of places, and I'll add in the digits. Is it okay if I use the character method to convert the character to digit?
Sure.
Okay, so character dot to digit char array I, and so and then I'll return value here. And then let me just walk through, going back to my example to see this actually works. Yeah, so the characters could be not numerical. So if it's not if I catch a case where it's not numerical, then I should just return right away. So I can either do the check inside the current for loop, or I can have a separate for loop to just not do it at all. So
you don't have to write that
okay.
Out. That's fine.
Cool.
And my other question is, to make things even simpler, can you think of a way to do it without using that library call? Just relying on the ASCII values themselves.
Okay. ASCII values. So I know these are ASCII characters, and they all have their unique ASCII value. They're all consecutive from 0 to 9. So I guess the differences between the values are the same as their numeric values, if that makes sense. So so if I have digit 9, the difference between digit 9 to digit 0 would be 9. Yeah, so I think I can use that.
Why don't you write the line of code to replace your library call?
All right, so I think it's really simple. I just need to subtract each digit from the actual, or the character 0, and then that should give me the right numerical value.
All right, great. Thanks.
Awesome, thank you.
All right, so now you've seen 3 examples of how you might, how one might answer this question in a technical phone screen, do this live coding. One was very bad. It was a train wreck. You definitely want to avoid that. The second sort of set of videos that you saw was improvements, taking somebody who's got some good ideas, a really good way of starting the problem, and they're fairly solid, and improving on that first example, which was terrible, to really do a better job on the interview. And then the last example you saw was someone who's really a rock star. They're very solid. They know exactly how to solve this problem, and the interview goes very, very smoothly. So what we're going to ask you to do next is to go back to that example that you filmed at the very beginning of this week, where you were the one who was solving a technical coding question in a Google Doc. We asked you to film it. We haven't asked you to touch it. We told you that you won't have to show it to anyone else, but you are going to have to go back and watch it yourself. So we're going to have some assessment criteria for you. We want you to go back and self-assess. Figure out what you did well and where there's room for improvement. And ultimately, in your final assignment for this week, you'll be redoing that activity to see how much you can improve based on what we've talked about. Coming up in the next lesson, we'll talk about some confidence building strategies, and in particular, a couple things that can really affect confidence. And so knowing about these things and then meeting them head on will help you not only apply the strategies that we talked about in this lesson, but go into these technical phone screens with much more confidence. So I hope you'll have fun. It'll be a little uncomfortable. It's always uncomfortable to watch yourself on video, but I hope you'll have fun and that you'll learn a lot from this self-assessment.
Recently, I struggled in a technical interview. It's because this is the first time I do interview, so it's very difficult for me. Reason is that I have to talk loud with the interviewer. This will significantly slow down my thoughts and interrupting my implementation of the algorithm. Also, I have to do in Google Docs, so it's a very unfamiliar environment. So I have to make the interview very difficult. So because of this experience, I would rather do more reviews.
All right, so you've completed this self-assessment activity, and if you found it to be a very humbling experience, you're not alone. Most people find self-assessment, especially of recordings of themselves, to be extremely challenging. And it may have brought up some feelings of sort of feeling like maybe you're not good enough or some negative feelings. And if that happened, you're also not alone. So in this video, we're going to talk about that phenomenon called the imposter syndrome, as well as something called stereotype threat and the growth mindset. So by the end of this video, you'll be able to define those terms, talk about what contributes to stereotype threat and the imposter syndrome, and then talk about some strategies for overcoming these, in particular talking about growth mindset as a strategy for overcoming stereotype threat and the imposter syndrome. So let's imagine a situation that I know I've felt before, and probably you've felt before, where you've been given some task or some job, and you start to work on it, and then you look around and you start feeling like, wait a minute, I don't feel like I'm the same as everybody else here. I feel like people are seeing me as something I'm not. I'm maybe not qualified to be doing what they want me to be doing. How did I get here? This was a mistake. Somebody made a mistake. How did I get in this position? And oh my gosh, I'm an imposter, and they're going to figure me out. So if you've ever felt like that, you're definitely not alone. This is a very common phenomenon called the imposter syndrome. This is this idea that you get into some position and you feel like you're not qualified to be there, that you're an imposter and you're going to be found out. And it can be very stressful. The imposter syndrome can be detrimental to your performance. It can really hurt you. So it can keep you from applying for positions that you are qualified for because you feel like in those positions you'll feel like an imposter and won't really fit in. It can make you not take appropriate credit for your work because you'll be found out that you didn't really do the work well enough. You somehow snuck it by and nobody else really figured out. So you won't stand up and take appropriate credit. And for our perspective in this class, it can make you doubt your abilities in high-pressure situations. For example, interview situations. You definitely don't want these imposter syndrome thoughts running through your head when you're trying to focus on technical explanations and technical content. And then at the end of the day, it's just extremely stressful. It can stress you out and make you very unhappy. So the imposter syndrome is real. And unfortunately, it's not always just in your head. So I want to tell you a little story that was published in the New York Times back in 2014 that can show that external factors can also influence these thoughts that are running through your head. So this story is about a young woman named Vanessa. And Vanessa was the first in her family to go to college. So her mother worked really hard, single mother, raised her well, raised her up to get into a really good school. So Vanessa worked hard and got into a really good school. She got into the University of Texas at Austin, the flagship university in Texas. And Vanessa is very proud, very excited to be going to UT Austin. But unfortunately, during her first semester there, she gets an F on a test. And she is just devastated. She feels like she's put in all this hard work, and how could she get an F? And so she calls home to her mom, hoping for some reassurance. And what her mom actually says to her has the exact opposite effect. Her mom says, well, honey, maybe you were overreaching. Maybe it just wasn't meant to be. Maybe you should have gone to a community college first. So Vanessa is not only internally facing all these feelings of imposter syndrome, but then she's hearing it externally as well. She shouldn't be there. She should be somewhere else. And so Vanessa is experiencing one manifestation of something that's essentially called stereotype threat. There's these expectations, these external expectations for what she should and shouldn't do as, for example, a first-generation young Black college student. She maybe should have gone to community college first instead of going to the flagship university. That's of course not true. Vanessa should do very well at UT Austin. She deserves to be there, but she's seeing all this external pressure that maybe she's made the wrong choice. It can happen in more subtle situations as well. So there are many stereotypes out there, and one in particular in the Western world is that men are better than women at math. So when you're asked to think about somebody who's good at math, typically a Western person thinks about this guy here, this white guy, nerdy pocket protector with a sheet full of equations. And that's just kind of the stereotype that exists. So let's say that I, being a woman, am going to go in and take a very challenging math test. Now, I'm good at math. The other people who are taking the test are good at math. But when I walk into the room, here's what I see. I see a bunch of people who uphold the stereotype that I have in my head that men are good at math and women aren't as good. Now, what happens to me when I walk into that room is that that stereotype activates in my head. And it turns out there are some researchers who did a study, Spencer, Steele, and Quinn, that when women are put into these situations and they're reminded of this stereotype that men are better than women at math, they actually perform worse on the test. It's not that they are worse at math, it's just that their performance is hindered by being reminded of these stereotypes. And this again is what's known as stereotype threat. It's the idea that I am now a representative of this class of people, of women, and so I have this added pressure to do well on this test because I worry that if I don't do well on this test, I'm going to be upholding this stereotype, this negative stereotype that I really don't want to uphold. And that thinking just gets in my way of my ability to think about the mathematical problems that I would need to be working on. And for people who are in the majority group, they've shown that they don't have this extra thinking that they have to cope with. They're not worried about upholding some stereotype because that's just sort of, that's the norm. That's what everybody accepts. And so they do better on the test itself. So this is something, obviously, we want to work to combat in a job situation, because when you're in a job, you might have some stereotype. There might be stereotypes about who fits into that job. For example, again, in the Western world, there's a stereotype that men are more competent than women in technical jobs. It's not true, but that stereotype exists. So when I walk into an interview and I happen to see a bunch of men sitting around in the position that I'm going for, that stereotype is going to be activated. So how do we combat both the feeling of the imposter syndrome and the stereotype threat? Well, one way is to find really good role models. So when you see people like yourself that you can relate to, that are in these really high positions and doing very well, that helps you believe that you can do it. And speaking of which, the more you can focus on yourself and your own accomplishments, the more you're going to distance yourself from those stereotypes and be able to perform without thinking of all those negative thoughts that kind of come into play. The other thing that really helps is shared experiences with peers and mentors. When you realize that you're not alone and that other people go through this too, that can help you take some of the pressure off that you're putting on yourself. The last thing that we're going to talk about is what's coming up next, this idea of developing a growth mindset. So in the next piece, we'll be diving into that. All right, so in this video, we're going to talk about a strategy called growth mindset that's particularly useful in helping you perform well in these high-pressure situations. So to introduce what this idea is, let's consider a student, again, taking a test. So there's a student, she's in her math class, she's taking a test, and she gets an A+. She does awesome. So there's two things that might run through her head as she gets her paper back. So the first is, yes, I aced this test. I'm so good at math. I'm awesome. But she also might be thinking, yeah, I worked so hard on that. I studied really hard and I got it. I'm so proud of myself. Both of those things are positive thoughts. And so, but they illustrate kind of a different way of thinking about performance. And the terms to describe these ways of thinking are called fixed mindset and growth mindset. So in that first example where she said, I'm so good at math, that illustrates something called a fixed mindset. In other words, she attributes her success to some innate talent that she has. The other way of thinking, where she says, I worked really hard and I got it, that can be attributed to something called a growth mindset. She's attributing her success not to some inherent talent that she possesses or doesn't possess, but to her hard work and her development or growth. So these two mindsets are studied by the leading expert in this field named Carol Dweck. She's a psychologist who studies this. And in this situation, there may not be too much of a difference between growth mindset and fixed mindset. But what Dweck has found is something really interesting, which is what happens when you have each of these mindsets and you're faced with failure. So let's take a look at the same student again. She takes another math test, for example, and this time she gets an F. So she didn't do so well this time around. So under the fixed mindset way of thinking, what she's going to think is, oh, I'm just no good at math. And she's going to be inclined to give up because she doesn't have the inherent talent that she needs to do well at math. But under the growth mindset situation, this is what might be running through her head. She says, oh gosh, I really messed up that time around. I didn't study hard enough. I really should have studied differently or put more work into that and I would have done much better. So I kind of failed this time around. So that's the growth mindset, this idea that she did poorly because of something that's under her control, because of something that she can improve for next time around. So here you can see that these two mindsets are going to lead to very different results. In the fixed mindset, she's going to be inclined to give up because she doesn't have what it takes. Whereas in the growth mindset, she's going to be inclined to work harder so that next time she's going to succeed. And the key piece here is that studies have shown that growth mindset interventions actually change performance. So if you can shift your mindset from a fixed mindset, either I've got it or I don't, to a growth mindset, I can have it if I work hard enough and do the right things, you will be much more successful in tests, in interviews, and just generally in life in these high pressure performance situations. So there's a lot of materials out there that can help you develop a growth mindset. But the gist of them is kind of to just get your head around this idea that it just takes more practice. You missed an interview question, that's okay. Don't get down on yourself. Just go practice some more. You didn't get that job, no worries. There'll be another opportunity. We'll get better, you'll practice, and you'll get that next job. So there are lots of opportunities out there, and coming up in a reading, we're going to have a lot of resources on developing a growth mindset, and we encourage you to explore those to improve, because at the end of the day, hard work is something you can control, and taking that control and being empowered is really going to help your success. Now, going back to the last video when we talked about imposter syndrome and stereotype threat, one of the things that can really help with imposter syndrome, as I mentioned, is realizing that you're not alone, that very successful, prominent people all suffer from imposter syndrome. So we've got a really special treat coming up for you. It's our imposter syndrome gallery, where successful people who are doing very well in their careers, like engineers at Google, the three of us, we're going to talk to you about how imposter syndrome is very real for us, how we experience it very regularly, and what we do to get over it. So I hope you'll enjoy that.
Hi, my name is Montserrat Gonzalez. I'm a software engineer in the speech recognition team at Google. Very early in my career, I experienced imposter syndrome since actually when I was in high school. I took some optional CS classes, and I realized that I was the only woman in the room when I entered those classes. I actually hated computer science when I was in high school. I hated the computers. They always gave me the blue screen. But when I started looking at these classes, they seemed more like logic and math, and also a cool way to do things that mattered and that could impact people. So I started these classes, and I feel like I'm not only the only woman in the room, but I'm also very different to the rest of my classmates. They are all programming 24/7 in the corner together, playing with video games with their computers. In the classes, I would always be like in the corner, and they would be all grouped together in the other corner. Anyways, I didn't let that stop me from going ahead and doing what I liked. So I went for a computer science degree in college, and then fast forward a couple of years, and I find myself at Google doing an internship in the speech recognition team, which was my dream team. And then in my first week, I realized that most of my teammates were PhDs with years of experience in the field, while I was an undergrad that had just one little project that was mildly related to speech. So in my first one-on-one with my manager, I decided to straighten things up and confess that I actually didn't have much experience in speech recognition. To what she said, "Don't worry, whatever you have to learn, you'll learn." And that was thrilling. For the rest of my internship, I spent all my time learning about speech, about Google, and working hard on my project. After a couple years, I joined Google as a software engineer full-time, also in the speech recognition team. And it turns out that my first project felt a lot like my internship. It was a very ambiguous and ambitious project where I felt like I maybe lacked the skill and experience to complete it. And I felt like the imposter syndrome all over again. Maybe they didn't know the complexity of the project, they maybe misunderstood my experience, and they gave me this huge project right after joining Google. But I did the same thing. I started working on it and slowly making progress. And a couple months after, I realized that every time you get a project, you feel this way. You feel the imposter syndrome. You feel like maybe you're not capable enough, maybe someone made a mistake, maybe someone misunderstood your skills. And it turns out that almost everyone feels this way whenever they have a new project, a new challenge. But the difference is that they always keep at it. And the secret is also that even though I always felt like a misfit, maybe like I didn't belong, either because I was a woman or maybe because I was the less experienced in the room, it didn't matter. The thing is that you have to keep working on it. You have to ignore the imposter syndrome. Just put it aside, and I won't promise that it will go away, but it won't stop you from doing what you like.
But the worst experience for me with imposter syndrome was actually when I was a graduate student, actually here at UC San Diego. So after I finished my undergraduate degree, I actually became a commissioned officer in the United States military, and I served in that role for 4 years. I learned great things in that position. I learned how to manage equipment, how to lead people, how to succeed in high-pressure situations, and how to trust other people on a team, how to work well with the team. But what I didn't do during those 4 years was use computer science in any way. So I'd had my bachelor's degree in computer science, and I took a 4-year hiatus from computer science before I went to graduate school. And I tried a little bit to brush up before I started graduate school, but honestly, I didn't brush up that much. And then that first quarter of graduate school is when this became the most apparent, and I remember this one moment really well. I was in a graduate operating systems class, and I was trying to remember undergraduate operating systems, which at that point I think I'd taken 5 years prior. And I'm just struggling to remember the very basics of operating systems. And one of the students in the class asked a question. I can't remember if he said explicitly or if it was the tone of the question, but he made it clear that he'd worked at Microsoft on a team that was solving the problem that we were all discussing in Linux for Windows. So I'm feeling already a little vulnerable because I don't remember this material, and now I'm hearing from someone who's clearly an expert in this area, who's supposedly my classmate, who is my classmate. It was a very stressful moment, and it took a while to get over it. It took around at least 2 years of succeeding in classes and getting good research projects going before I really actually started to feel that much better. And that's one of the things I've kind of realized over the time, is that everyone goes through imposter syndrome, and we all have weaknesses which allow our minds to have those feelings of imposter syndrome. But what we can do is, first of all, recognize what imposter syndrome is when we start feeling that way. But the second thing we can do is start thinking about all the strengths we bring to the table. We all have some measure of weaknesses and strengths, and where you're being hired for a position is based on your strengths, not necessarily your weaknesses. So again, I think by recognizing the issue when it comes up and by focusing on your strengths, you can help to overcome this.
My name's Howard. I'm a software engineer. When I think about the notion of imposter syndrome, I think about one's inability to really understand and value their competencies, knowledge bases, and skill sets, right? And so this typically comes out to play in interviews. When I think about interviews that I've been in myself, imposter syndrome is definitely something I've experienced. It's something I've had to overcome. More recently, in an interview, full round of interviews that I went through in order to work at the current company I'm at now, I had to address imposter syndrome head on by choosing to view my interviewer as an ally, someone who's on my team, someone who I already work with. They were simply just coming to me being already a really bright, smart software engineer with a really tough problem. And because I'm on their team, we're just in a room on a whiteboard coding to figure this thing out. When I looked at my interviewer as an ally instead of someone who was against me, it kind of gave me some of the power back, right? It allowed me to see her as someone who is on my side, who's rooting for me, who wants me to effectively solve the problem, and I'm simply helping her out. Now I'm a software engineer at Google, of all places, and it's only because of my ability to really address head-on imposter syndrome. Interviews aren't easy. They're actually really hard. It took me 4 times before I actually landed my role here. And so I think when you get declined in an interview, that means try again. It does not mean to stop.
All right, so I struggle with imposter syndrome all the time because I like high-level thinking, and I am a technical person, and I like technical details, but I don't tend to keep a lot of technical details in my head at any given time. So when people around me start throwing out a lot of technical jargon and technical details, I start to really panic and start to think, oh my gosh, am I supposed to know all that stuff? Is that word supposed to mean something to me? I don't know what I'm doing here. I shouldn't be here. I don't have enough knowledge to be here. So that happened to me a lot in graduate school. That's happened to me continually ever since then. Sometimes it happens to me in the classroom when I'm teaching. I start to question my ability to teach a class when students are asking me about some detailed specification of some language that I just don't know that detail offhand. So in those cases, I really have to just calm myself down. It's happened to me so many times that now I can kind of recognize it. But it took a long time before I really started to become comfortable with the fact that I don't need to have all those technical details in my head. And just because I don't have them in my head doesn't make me any less smart, doesn't make me any less of a good person, doesn't make me any less productive. So once I kind of remember that, everything starts to feel better again. But it happens to me regularly, even now. So I feel imposter syndrome a lot lately as I've started to become a little more senior in my career, and people are kind of looking to me as a leader or as somebody who has knowledge to share with others. And it took me a long time to get comfortable in that role, and I'm really still not comfortable in that role. I still see myself as this beginning person who's very early in her career and doesn't really know much. I'm still learning from others. How can I possibly have anything to teach people who are coming up behind me? And, so when I'm put into the role as a mentor or when I'm working with my new colleagues, I sometimes panic thinking, oh my gosh, they know so much more than me. What am I doing here? How am I possibly in this role that's senior to them when they're so much better than me? And I have this moment of panic. And what usually helps me in these situations is actually to just voice that feeling to the people that I'm mentoring. And they'll tell me things like, I can't believe you just said that. Like that. You seem like somebody who has so much experience. There's so much I can learn from you. But I'm glad you just said that because I feel that way all the time. So we kind of have this connection around this imposter syndrome. So that's a role that I'm still really getting comfortable in. And I know that I'll face this imposter syndrome probably for the rest of my life. But I now have ways to deal with it.
Hello, my name is Arturo. I'm a site reliability engineer. One of the biggest struggles I faced during my career journey was when I transitioned from hardware to software engineer. I remember that back then I was working in a hardware company and I realized that I was enjoying much more the software pieces of my projects than the hardware ones. I gave it a thought and decided to talk to my manager about changing my career path. When I talked to him, I got very surprised. He said, and I quote, "It is close to impossible." I got worried about it, but I decided to give it a try despite that. So I started learning a lot of new things, and almost everything was very different to what I was used to. This became very challenging to me, but at the same time it was very exciting. A cool thing about working in a tech company like Google is that everyone has an opportunity. So I got mine, and here I am. However, I was still afraid that I will have to work double or much more harder than all my peers because evidently all of them have computer science degree. Soon after I met my manager and all my team, I realized that I was wrong. Technology is changing. Software is changing so fast that everyone has to be learning and working in developing themselves. Even from the most senior engineer to the new hire, everybody is learning. So I learned that if you have the willingness and the passion to do what you want, you can actually do it.
The root of my imposter syndrome somehow comes from the fact that my interests are really interdisciplinary. And I work in a lot of different areas, which means that my background and my education has really sampled from a lot of different fields. So my undergraduate degree was in engineering and then philosophy. And then I went off to math grad school. And then now I'm working in a computer science and engineering department. And so the exciting thing about that is that I get to work and interact with lots of people and think about all sorts of really cool projects and problems and hard problems about different fields. But the tough thing for me, and where I feel like an imposter sometimes, is that I don't have that body of shared experience that some other people have if they've just started in one track and gone through that track their entire education or career. And so sometimes I feel like I'm going to have these big gaping holes in my background and my knowledge because I didn't take that one, processing architecture course, or that I didn't take that one, really heavy-duty Galois theory course, or whatever it is. There's like these fears in the back of my mind that I'm just not going to fit what a computer scientist looks like or what a mathematician looks like, because my journey's a little bit different. And then on top of that, there's the fact that women are underrepresented in both of these disciplines. And so sometimes I get caught up in myself about, my insecurities will show through, and it's not going to reflect poorly just on me, but on all women. And maybe I should just, I'm just not cut out for it. And then I have to take a deep breath and step back and say, actually, I do have a lot of experience, and I have done a lot. And what I find works really well is to make connections with other people and work collaboratively and solve those really good problems and really hard problems. And by keeping at it and keeping working and making these accomplishments and having these accomplishments, little by little, I feel more and more like I belong and like this is the right path for me.
Welcome to week 3. In the first 2 weeks, we talked a lot about the interview process and how to survive that technical phone screen. This week, we're going to focus on what you can do after you get that interview. So you've gotten through the phone screen, now you're in the interview, and we're going to focus in particular on a very common question that you're likely to get asked, which asks you to describe some technical work that you've done. So by the end of this week, you'll be able to clearly and confidently explain a solution that you've created to a technical problem. So the question that you'll be faced with almost certainly in an in-person interview sounds something like this. The interviewer will say something like, "Tell me about a problem you've worked on. What was the problem? How did you solve it? What was novel about your solution?" The question comes in many forms, but it's a key staple of a technical interview. And unlike the questions we were looking at last week, it's actually a question you can prepare for, which is really good. So this week we're going to talk about how to prepare for that question and how to give the best possible answer for that question when you're faced with it. We're going to start by looking at a few examples from myself, from Leo, and from Mia. And what I want to highlight about these examples before you watch them is that we're going to showcase different contexts and slightly different versions of the question. So we'll be pitching to different styles of audiences, focusing on different projects. But what's most important about answering this question is you're going to answer with something that's deeply personal, something you've worked very closely on. So you'll see Mia and Leo talk about their research, and you'll see me talk about an example from the development of these courses themselves. I'll talk about a technical challenge that we ran into when we were developing software for course 3 in this specialization. What I want you to do is I want you to watch these examples and focus on what we all do well. So how are we describing the problem? How are we describing the solution? What are you getting out of these descriptions? Now, we'll talk about how these would be evaluated after you watch these videos, and then we'll launch into some pitfalls and talk about how you can identify these pitfalls and avoid these pitfalls in preparing to answer this question yourself. Our goal is that by the end of the week, you'll be able to give a really solid answer to this question.
So can you tell me a little bit about a project that you worked on?
Yeah, I'd love to. So let me tell you a story from a project in computer architecture research.
Okay.
So you're familiar much with computer architecture research?
So.
Okay, so it's like the high-level design of processors focusing on like performance or reliability or power. Okay, and I think it'll become more clear as we kind of walk through. So let me give you just a quick example to get started, and then we'll keep going.
Okay.
So let's say you've got some program. Let's say I've got program A, and I want to run it. Well, I'm going to run it likely on a processor.
Okay.
Now, in the old days, and by old days I mean like 2004, you'd only have one choice when you ran the program. It could only run on the chip because the chip could only run one program at a time.
Okay.
But after 2004, we started getting multi-core processors.
Okay.
And have you heard about those before? Or?
Yeah, all the laptops these days have quad core, all these other.
Exactly. That's exactly what it is. So you have more than one core on a single processor, and what you have here is you got your 4 cores here, and now you have choices.
Right.
So I could execute program A on core 0 or core 1 or core 2. Any of these cores could run program A. And there were a couple of research proposals at the time that kind of exploit this for various reasons.
Okay.
So the first, and I'll just give a couple of concrete examples. The first was, so if I scheduled program A to run on core 0, and I always did that, I always ran my programs on core 0, what would happen is that this part of the chip would get really hot, and this part of the chip would be cold. And a thermal difference in a chip is really bad. It actually causes the processor to die faster. Okay. So what you could do is a really simple solution would be just to migrate execution from core 0 to core 1, from core 1 to core 2, from core 2 to core 3. And in doing so, then you kind of spread out the thermal wear.
Right.
So this was an approach to improve the reliability of the chip, but it relied on you jumping from core to core to core. I'll give you one more example. Actually, part of my PhD thesis was trying to take program A and divide it up into small, different threads, so different sections of code, and execute those sections of code on different cores. In effect, I would speed up program A, but to do that, I'd have to migrate computation again from core to core to core. The details of which aren't too critical. It's just the fact that we have the same behavior of migrations, but now to improve program performance.
Okay.
So what started happening when we looked at this idea of migrating from core to core was we found that it actually causes these major performance drops. So when I try to go from core 0 to core 1, I would see a drop in performance by about a factor of 8 for the first 10 to 100 instructions, and then I'd see a factor of 2 drop even out to the first 10,000 instructions. So you'd see these big drops in performance going from core to core. And the reason for that is that as you've been running program A on core 0, essentially the longer you kind of run on there, the more you learn about the program. So modern processors actually learn about what your program is doing in order to make it perform better.
Okay.
So an example would be like, it grabs the most pertinent data that your program wants and keeps it really close to the computation engines on the chip.
Okay.
And essentially by doing that, you speed up performance. Okay. So longer you're there, the faster it runs. Does that make decent sense?
Yeah, yeah. And so then when you go somewhere new, then it doesn't, this one wouldn't have learned the same computation and the same processes, and so it's not going to be able to run as fast.
Exactly.
Okay.
That's exactly right.
Okay.
So yeah, so when you jump from core to core, then you lose all that learning.
Right. Okay.
So what I really liked about this project was when you looked at the problem, the kind of obvious solution was actually completely wrong. So the obvious solution is you take all of your learning and you transfer it to the other core.
Right.
And the problem is there's just so much that the core's learned that you can't transfer all that information and still have it perform well.
Okay.
You'd end up taking so long to transfer the information that, again, it caused even more disruptions in terms of execution. And to be frank, it just was too much information. It wasn't all stuff you needed.
Oh, I see.
So what our research project became was basically designing this little piece of hardware on the core, which would keep track of the most relevant parts that you've learned.
Oh, cool.
And then at the time of migration, you just essentially transfer that little bit that really mattered about your learning to get this other one started faster. Okay. And there was a whole bunch of kind of figuring out which pieces to learn. Yeah. But if you got it right, you're looking at about a factor of 2 in performance gain. Wow. At the point of migration. So I do want to mention this was joint work. I did this with a couple of other researchers. My main component was looking at that thesis work, which was dividing up the program and running on these cores. And my colleagues also helped solve this problem as well.
Wow, that sounds great. Thank you.
So could you tell me about a project you've worked on?
Sure. So
my background is in theory, and so I'll tell you a project that I worked on about the bounds of computation. And so what I really like to think about is how far can we push computers, and where are the limitations? And this goes way back to before there were computers. There were still people trying to think about what it would be like if there were computers, and what would it mean to think about computation. And so Alan Turing in the 1930s devised this notion of a universal machine, a Turing machine that could, and you may have seen the movie, The Imitation Game with Alan Turing. And so we have this notion of computers being able to perform computations. And this is kind of an abstract notion. It doesn't have to do with whether you're a Mac or a PC or operating systems or anything to do with the nitty-gritty hardware or software, but just the notion of computation. And what's amazing about Turing's work is that you can actually distinguish between problems that are solvable by computers and ones that can't ever be solved by any computer, no matter how clever we are at building that computer or how much time we give it or how much memory we give it. There's just some limits to computation.
So they're completely unsolvable. You could never solve these no matter what.
No matter what, which I just think is crazy, but really interesting, because there's some problems that are just so hard that computers can't, access. And I actually think that's kind of cool, because it means that we as human beings can think about them, but computers can't solve them. And so that's what I think about a lot. And then a very specific research project that I worked on based on this notion of computability is trying to understand how we can recover some computability, some algorithms for solving problems, if maybe we restrict the resources that we give our computers. And so we can say, let's not go hog wild and give our computers as much time as they want to solve the problems and as much memory as they want, but say, what about if we have a model of computation that's much simpler? And so this is called a deterministic finite automaton, or a DFA. And I don't know if have you heard of finite automata before?
I have a bit, yeah.
Okay. So a way I like to think about automata are as smaller computers. So the functionality of the automata is somewhat similar to a full-blown computer, but it just doesn't have as many resources. It doesn't have much memory to work with, and it's got to make decisions on the fly. It can't really store a lot of information, and it can't defer decisions. So
do you quantify those amounts? Do you narrow the scope?
Absolutely. So all of this can be made very precise and very mathematical, but the cool thing about the research project that I'll tell you about is that you can see sort of the heart of the question without getting into all of those details. And then afterwards we can go back to them, because they're really cool too. But the idea is that when we restrict the computation power, then all of a sudden there's all sorts of questions that a computer would have been able to solve, but that these little machines, these automata, can't. And so there's particular questions that we can prove separate the class of computable objects, those that are answerable by computers, from those that are automatic, the ones that automata can handle. And so there's this very clear distinction between the automatic world and the computable world. And so then my work was to try to understand that interface. And in particular, I was trying to understand the complexity of objects that live in the automatic world. So we know that these machines are weaker than computers. We know that there's sets and functions that automata just can't describe very well, that they can't do everything that computers can do. And so is there a bound on the complexity of the objects that they can describe? Because maybe we want to understand how much we've lost when we've taken away those resources from the computers, how much remains. And so we looked at a particular, and this was joint work with a couple of my colleagues, we looked at a particular measure of complexity called Scott rank, after Dana Scott, who's a computer scientist. And this measure of Scott rank tells us how complicated the objects that are being described are. And we know a lot about the Scott rank of computable structures and computable objects, and we know that the Scott rank can get pretty high up there. And so we were thinking, well, maybe the Scott rank of the automatic world is going to be bounded quite a bit lower than the computable world, because they're so much smaller and weaker and, these tiny little things. But the amazing thing was that we proved that you can find structures that are arbitrarily complicated in terms of Scott rank, that they have really, really, really high Scott rank, but that are still automatic. And so even though these machines are like way smaller and simpler and stupider than the full-blown computers, they can still code up objects that have arbitrarily high Scott rank, as high as any computable structure.
That's really neat.
It's so cool. And the key technical insight that we had to have was that we had to use really clever codings and representations of these really complex problems. So we had the really complex objects that had the high Scott rank, and we had to code them up in clever ways so that the automata could still somehow represent them.
That's really neat. Thank you.
Thank you. So tell me about a project that you worked on.
Sure, let me tell you about some code we developed for part of the third course in the specialization.
Okay.
So the project in that course is we want the learners to take some map data. So some data, some street data in the world. So let's say we have some streets that look like this. There's a street here, and maybe there's a curvy street right there, and another street running here, maybe another street running there. And the goal for the learners is that they want to find intersections in this map, or take intersections in this map, and then plot directions from one point to another. So basically what they need to work with is these intersection points and connections between them. But this map data, as you can probably imagine, is real world, and it's extremely complex. So there's a lot more than just these intersection points in this data. In fact, in addition to these intersection points, you actually get all these other little points along each of these lines. So you've got all these yellow points here, and ditto for all the other lines here.
So those dots trace the shape of the road.
Exactly. So these dots are necessary so that we can trace the shape of the road. But in terms of finding routes, direction planning, they're not really important, right? Because the only time you have a choice is at an intersection.
Right.
So we could do some route planning on the full set of data here. But the problem is that the graph that the users would have to work with, the learners would work with, it would be very, very large. So that would be kind of a problem. So we wanted to be able to prune out all these yellow dots here so that the learners didn't have to include them in their graph and allow the learners to work just with these intersection points and the connections between them. So that was the technical problem that we had to deal with. So how did we deal with it? That's a good question. So what we did was we first considered all of the data. This is the data that comes back to us from the full map files. And what we did was we represented all of the data you see here, all the points in pink and in yellow, as a graph. So these are points in our graph, a full graph, and there are edges between each of the points that are connected by a road segment. Each of the road segments also has some meta information, so not just these points, but also like the name of the road, the type of the road, and so on and so forth. And again, our goal was to identify the pink points and discard all of the yellow points.
And were the pink points distinguished in the graph?
No, they weren't. That's a good
Oh,
question. So we had to figure out how to identify the pink points and then take only those and create a graph where the pink points themselves are connected. So the way we did that was we had to define what is exactly an intersection. How would we identify an intersection given this graph structure? And after a lot of thought, we went back and forth. How does an intersection look? Roads coming in, roads going out. What we realized was that it was easier to identify what an intersection isn't. So in other words, these points in here, you can see those aren't intersections because there's just a single road that passes right through them. Now to make this slightly more complicated, we have both one-way streets and two-way streets. So there are a couple different scenarios where we look at a point in the graph, and determine that it's not an intersection. And here's what these look like. So on the one hand, we have this situation where we have a point, this could be pink or yellow, and a road coming in and a road going out, and this road has the same name. Say this is Main Street. So this represents a one-way street going through this point. And in this situation, this node right here, that's not an intersection. So we can rule that out.
So it would be yellow.
Exactly. That's a yellow point. And we can ignore it.
Okay.
The other situation where we don't have an intersection is just the two-way street version of this. So we have a road passing through in this direction, but it's a two-way street. We have edges in both directions. All of these road segments have the same name. This is also not an intersection.
Right.
If either of those conditions is not true, then we know that we're dealing with an intersection.
Okay.
And we should consider it a pink point.
Nice.
So that's what we did. There are some little detailed complexities here, like how do we represent this graph so that it's easy to find the nodes, the edges coming in and the edges going out. So we couldn't just use a straight up adjacency matrix going out. We had to be able to find the incoming nodes as well. So that was made a little bit more complex. But once we identified the intersections, the pink points, using this algorithm, so anything that didn't look like this is considered an intersection, we grabbed those points out as nodes in the graph that we wanted to give to our learners. So there'd also be points down here, these dead ends, so on and so forth. Next, we had, and that's if the roads ended here. If they continued, there'd be more intersections over there. The next thing we had to do was connect them.
Yeah.
Well, that actually turned out to be pretty straightforward.
Okay.
It was just a depth-first search out of each of these intersection nodes through the graph to the closest neighbor. So just a one hop, essentially one intersection hop depth-first search. So we would start right here, and we would then trace out through these yellow points, which we could easily do with our graph representation, until we reached another intersection.
Right.
And then we say, okay, these two are connected with an edge. We'd come back here, and we'd go in a different direction. So we had to mark these as visited, so we didn't repeat that path. We connect these two, we connect these two, and so on and so forth. So that's how we took all this very complex, dense data and turned it into a much more reasonable, sparse representation for our learners.
That's great. Thank you.
Sure. All right, so you've seen us presenting some technical solutions, and hopefully we made it look pretty easy. But it turns out it takes a lot of practice. So what we're going to do for the rest of this week is we're going to give you the skills to practice your own technical explanations, and we're going to do a lot of practice, talk about some common pitfalls and how you can recover from those pitfalls. In this video in particular, we're going to look at some evaluation criteria. What are the people who are watching you, who are interviewing you, really looking for in these videos? And we're going to use these evaluation criteria as a framework throughout the rest of the week. So what are they looking for when they ask you to present or talk about some work that you've done? Are they looking to see whether you're a genius, that you're the next big thing, that you've got the next idea that's going to turn into a company as big as Google and revolutionize the world? Well, no, of course they're not looking for that. They're looking just to see that you are a competent person who is good at solving problems. They want to know about your thought process, and they want to know about your communication skills. So they want to know, did you solve an interesting problem, and can you communicate it? What was your solution? Was it novel? Was it interesting? So all of this, as you saw in our examples, can be made to look pretty easy. But as I mentioned before, it's really difficult, and it takes a lot of practice to develop a good explanation. So let's take a look at how you can approach this problem, and then in particular, let's frame it around how you're going to be evaluated on this task so you can avoid some common pitfalls in this process. So the approach that you may have seen online that's kind of all over the place is that when you're presenting this technical work, you'll use something called the STAR method. So this is a very nice approach to presenting your work. And STAR is an acronym. It stands for Situation, Task, Action, and Result. So STAR. So in the situation part, you want to talk about what was the situation in which you were solving the problem? Who was involved? What is the sort of context of the problem you were trying to solve? Then you'll go on to the task. So what was exactly the problem you were trying to solve? Why should people really care about it? Then you can go on to the action. What was the solution that you presented? What did you actually do? And then, of course, what was the result? Did it actually solve the problem? How did you know? How do you know? So all of these pieces need to be present in your technical explanation. What we're going to do in this week is we're going to take the STAR model and we're going to group it a little bit differently so we can really get at some of the real challenges to developing this technical presentation and talk about some of the common pitfalls that we see. So what we're going to do is divide this into 3 lessons where first we focus on the problem, so pitching the problem. How do you effectively pitch a problem and its context so that the people you're talking to will care about your problem and see that you know why that problem is important? And this roughly corresponds to the S and the T, the situation and the task portion of that STAR model. In the next lesson, we'll talk about the solution. So what was your technical solution? Why did it solve the problem? Why was it innovative and creative? That piece roughly corresponds to the A and the R, the action and the result. And then in the last part, we'll talk about technical communication and group work skills, more of these soft skills. Now, these soft skills aren't explicitly mentioned in the STAR model, but obviously they're going to be a critical piece of your technical explanation in an interview situation. So throughout the week, we'll look at each of these components and we'll be giving you some examples of good examples as well as some pitfalls and some bad examples to show you what to avoid and how to avoid making these same mistakes. So we're looking forward to getting started. All right, now you want to describe some work that you've done. And the first thing you want to start with is, what problem did you solve? So by the end of this video, you'll be able to present your problem in a compelling way, and you'll also be able to identify how to break down your problem from very high-level problems to more specific low-level problems that you actually solved. So why start with the problem? Well, because at the end of the day, it's the problem that matters. People are listening to you talk, and what's kind of going through their head is, who cares? Why am I listening to this? Why should I care? And that problem is the answer. Who cares? It's who cares about that problem being solved. So if you don't make the problem clear, nobody's going to care. So let's go back to Leo's video and let's consider how he makes the problem that he solved very clear and how he makes us care about this problem that he's trying to solve.
You got your four cores here, and now you have choices.
Right.
So I could execute program A on core 0 or core 1 or core 2. Any of these cores could run program A. And there were a couple of research proposals at the time that kind of exploit this for various reasons.
Okay.
So the first, and I'll just give a couple of concrete examples. The first was, so if I scheduled program A to run on core 0, and I always did that, I always ran my programs on core 0, what would happen is that this part of the chip would get really hot, and this part of the chip would be cold. And a thermal difference in a chip is really bad. It actually causes the processor to die faster. In effect, I would speed up program A, but to do that, I'd have to migrate computation again from core to core to core.
Okay.
The details of which aren't too critical. It's just the fact that we have the same behavior of migrations, but now to improve program performance.
Okay.
So what started happening when we looked at this idea of migrating from core to core was we found that it actually causes these major performance drops. So when I try to go from core 0 to core 1, I would see a drop in performance by about a factor of 8 for the first 10 to 100 instructions, and then I'd see a factor of 2 drop even out to the first 10,000 instructions.
Oh.
So you'd see these big drops in performance going from core to core.
So you'll see that it was fairly easy to identify the problems that Leo solved. And moreover, all of those problems were not at the same level. He started off with a very high-level problem that's very clear why we should care about it. We have these processors have multiple cores, but if you only run on one core, what's the point of having multiple cores? Moreover, if you only run on one core, that core is going to heat up, the chip is going to wear out. That's a problem. It's also a problem that you're not going to take advantage of the speed gain you could potentially get from using all the cores. That's pretty clear and straightforward. But that's also pretty high level. So he went on to break things down in a bit more detail. A lower level problem he talked about was, how do we then transfer our programs that are running across the cores that we have to work with? One problem that he mentioned was, when you just do it the naive way, things slow way down, and that's a big problem. So how do we manage to copy some state that this program and core has stored up about the program running over to the next core so it can pick up running and be just as fast as it was on that very first core? So you can see how Leo starts with a high-level problem that everybody cares about and then goes down and down and down into deeper and deeper problems that get more technical and closer to the problems that he actually solved with the solution that he presents. So at the end of the day, did Leo answer the who cares question? Well, I think so. I want my computer to run fast. It's clear to me that just giving me more cores is not going to solve my problem of having my computer run fast. I'll need solutions like the one Leo presented to really get the most out of these new chips. So we've now seen a good video of where Leo presented the problem very clearly. Let's take a look at our first pitfall in presenting the problem. And this pitfall is getting to the solution too quickly. So by the end of this video, you'll be able to identify and fix this pitfall, which is, again, diving in too quickly to the solution before it's clear what problem you actually solved. So this is a very common pitfall, and it arises because when you're asked to talk about your work, you're really eager to talk about what you did. You're like, I did all this cool stuff, I implemented this really awesome system, and it worked really well, so let me tell you about the system I implemented. And you forget that all the rest of us, the people who are listening to you, we don't know why you were doing this. We don't know what problem you were trying to solve. Yeah, we're excited that you did this system, but if we don't know what problem you're solving, we don't care all that much. So let's watch another example where Leo sort of falls into this trap. He's so eager to tell us about all the cool technical work that he did that he forgets that we don't really know what problem he's trying to solve.
And the project that we were doing was looking at trying to make thread migration cheaper, essentially. So what we were trying to do is, if you have a multi-core processor, so you've got 4 cores here, what we're trying to do is make it so you can go more cheaply from core 0 to core 1 if you migrate computation from here to here. And the way that we did this, we started by adding some hardware structures. And these hardware structures are going to be on both cores, but I'm just going to focus on the ones that are essential for a migration from core 0 to core 1. Okay, so the hardware structures, I'm going to zoom in on. What we started doing is we started with a memory logger, and the memory logger just kept essential things about your program, like the program counter, various addresses that you're working with, and stuff like that. And then that got sent to a summary generator.
Hold on. Okay. So how is that helping? The program counter and...
Oh, so I'm just trying to make this migration cheaper. So, and by doing so, I'm trying to capture all the stuff that this guy learned and then send it to the other core.
Oh, okay.
Okay. I think it'll come together more once I've showed the hardware structures.
Okay.
So I've got the program counter, I've got my data. I'm going to summarize all that in this summary generator. And all of this is on core 0. And then the summary generator is going to summarize all that information, compress it down, send it off to the summary-driven prefetcher over here on core 1. And then that's going to send a whole bunch of requests out to the memory subsystem.
So isn't memory slow? How is this helping? How is it speeding things up?
So it's helping things. It's focused just on improving the speed of the thread migration by having these extra hardware structures capture all the learning.
Okay, so that video was pretty different from Leo's first video. What went wrong? Well, he started off okay. He started off talking about the multiple cores on the processor and how we want to migrate between cores, but then suddenly we're way down in the details of his solution, and he jumped straight from really the high-level problem to the details of his solution. He forgot that we needed some intermediate steps there in order to understand why what he did was important. Moreover, he even ignored Mia's requests that he bump up the discussion a little bit. In the middle, she was like, I don't really understand why you're doing that. And he kind of just blew that off as if it were obvious. So we're presenting this is kind of a little made-up example. Leo wouldn't explain things this way, but it's so easy to fall into this trap because, again, you're just so excited to talk about what you did that you forget that we weren't all there with you. So the lesson we want you to take away from this is that solutions matter. Your interviewers really do care about the solution you came up with. But if it's a solution without a problem, they don't care as much. So take your time. Just because you created something cool doesn't mean people will know why it's cool unless they understand what important problem it was solving. In this video, we'll look at another common pitfall in presenting your problem, and that's pitching your problem to the wrong audience. So by the end of this video, you'll be able to identify this pitfall and take steps to correct it. You saw in the beginning of this week that Leo and Mia and I all presented these technical presentations. We presented problems that we solved and our solutions to these problems. But we were pitching them to different audiences. In particular, while Leo and I were pitching to more of a technical audience, Mia was talking to somebody who maybe was just her friend at a cocktail party who wanted to know about her work, but really had very little background in the area that she was studying. So you can notice from her video that she kept her explanations very high level, she didn't get into the nitty-gritty technical details, and she was very careful to lay out the problem from a really non-technical point of view. That's what you need to do when you're talking to a non-technical audience. So when you are going to answer this question of what problems have you worked on and how did you solve them, you need to be sure you understand what kind of background is your audience coming with. Let's consider what could have gone wrong when Mia, for example, tried to pitch her explanation, but misjudged the amount of technical knowledge that her conversationalist, her audience had. So what problem are you working on right now?
So I'm working on this really cool problem that divides automatic structures and computable structures. And so, you know, the computable structures are, so they're relational structures, they're, domain and relations, and you just have finally many of them, but they're all presentable by Turing machines. And
hang on, what are structures again?
Oh, yeah. So like things like graphs or Boolean algebras or partial orders, so any sort of mathematical object, and you just want to present them using Turing machines. So they're effective, they're computable. And so we're distinguishing those from automatic structures, and like automata are provably weaker than Turing machines, and so we want to compare the computational complexity that is built into these different structures. And so we've got these automatic structures, we've got computable.
All right, so what went wrong in that video? You could see that Mia was much more technical. Now, her explanation might have been okay for somebody who was really well versed in her field. And likely what went wrong is that Mia is so deep in her work, she's so deep into solving these problems and working with these problems, that she forgets that not everybody is in that world with her. So she's here at this cocktail party and she just assumes that everybody around her must be computer scientists and theoreticians. And so of course they would know what she's talking about. This is a trap that a lot of people fall into. So, how do we fix this problem? The best way to fix this problem is that when you're explaining your technical solutions, practice explaining them to as many different kinds of people as you can. So explain them to people with absolutely no technical background. Explain them to people who are also taking this course with you. Explain them to people who have much more technical background than you. Practice, practice, practice. Because unlike the problems we looked at last week with those technical phone screen live coding problems, which you can practice for, but not exactly, this is something that you really can rehearse. So the more rehearsal that you do, the better you're going to sound when you're in the interview situation. Now, what happens if you get into a situation you're talking to an interviewer and you don't know how much technical background that they want to hear or that they have? Well, you can always ask. So you saw an example of that in Leo's video where he asked, how much do you know about computer architecture? That's always an appropriate question. You can ask your interviewers, do you want me to go a little bit more deeply here? And they'll tell you. We'll talk about it at the end of this week. This is really a conversation. And pitching things correctly to your audience is a really good way to get things off on the right foot. All right, you've presented your problem. It's very exciting. The audience is on the edge of their seats. They want to know, how did you solve this problem? That's what we're going to talk about next. How do you present your technical solution? By the end of this video, you'll get started on articulating your technical solution in a way that's clear and compelling. So the solution is the fun part. That's what you did. That's your chance to say, hey, look at this cool solution I came up with for that problem I told you about. Isn't it exciting? So you want to convey that to your audience, and you want them to see how awesome and elegant and creative your solution really is. So let's take a look at some of our examples of how we talk about our solutions, and then we'll ask you some questions about our presentations.
We looked at a particular measure of complexity called Scott rank, after Dana Scott, who's a computer scientist, and this measure of Scott rank tells us how complicated the objects that are being described are. And we know a lot about the Scott rank of computable structures and computable objects, and we know that the Scott rank can get pretty high up there. And so we were thinking, well, maybe the Scott rank of the automatic world is going to be bounded quite a bit lower than the computable world because they're so much smaller and weaker and these tiny little things. But the amazing thing was that we proved that you can find structures that are arbitrarily complicated in terms of Scott rank, that they have really, really, really high Scott rank, but that are still automatic. And so even though these machines are like way smaller and simpler and stupider than the full-blown computers, they can still code up objects that have arbitrarily high Scott rank, as high as any computable structure.
That's really neat.
It's so cool. And the key technical insight that we had to have was that we had to use really clever codings and representations of these really complex problems. So we had the really complex objects that had the high Scott rank, and we had to code them up in clever ways so that the automata could still somehow represent them.
So the way we did that was we had to define what is exactly an intersection? How would we identify an intersection given this graph structure? And after a lot of thought, we went back and forth. How does an intersection look? Roads coming in, roads going out. What we realized was that it was easier to identify what an intersection isn't. So in other words, these points in here, you can see those aren't intersections because there's just a single road that passes right through them. Now, to make this slightly more complicated, we have both one-way streets and two-way streets. So there are a couple different scenarios where we look at a point in the graph, node of the graph, and determine that it's not an intersection. And here's what these look like. So on the one hand, we have this situation where we have a point, this could be pink or yellow, and a road coming in and a road going out, and this road has the same name. Say this is Main Street. So this represents a one-way street going through this point. And in this situation, this node right here, that's not an intersection. So we can rule that out.
So it would be yellow.
Exactly, that's a yellow point.
Okay.
And we can ignore it.
Okay.
The other situation where we don't have an intersection is just the two-way street version of this. So we have a road passing through in this direction, but it's a two-way street. We have edges in both directions. All of these road segments have the same name. This is also not an intersection.
Right.
So you saw that even though we're talking about different problems, we have different solutions, and our talks are tailored to different audiences, it's still relatively easy to pick out what our solutions were and how to relate the solutions to the problems that we were trying to solve. Now, again, hopefully we made it look easy, but it's not always this easy. In fact, every single one of us rehearsed that a lot. The first few times we tried to do this, it was not clear at all. We went on wrong paths. We fell into many of the common pitfalls that people run into when they're trying to present their solutions. So we'll take a look at those pitfalls next, how to identify them, and then how to avoid them. So now we're into what can go wrong when you're trying to present your solution. This might be my favorite part of the whole course because we see these issues all the time. It's almost impossible to avoid these pitfalls the first time you're trying to explain your solution. So let's take a look at a couple of the most common. The first one we're going to talk about is a pitfall called in the weeds, or trying to sound really smart. So by the end of this video, you'll be able to identify that pitfall and know how to avoid it. So you're in this interview situation. They've asked you to talk about the work that you've done. What do they want you to do? They want you to be really, really smart. Okay, how are you going to be smart? Well, maybe if I just use really big words and I use really big technical sentences and I try to confuse them. Yeah, that's it. I'm going to try to confuse them, and then they'll think I'm really smart because they don't understand anything that I'm saying. Maybe that's a good idea. Maybe not so much. Let's take a look at how that looks when that approach is actually carried out by Leo.
Okay, so the hardware structures, I'm going to zoom in on. What we started doing is we started with a memory logger, and the memory logger just kept essential things about your program, like the program counter, various addresses that you're working with, and stuff like that. Okay. And then that got sent to a summary generator.
Hold on. Okay. So how is that helping? The program counter and...
Oh, so I'm just trying to make this migration cheaper. So, and by doing so, I'm trying to capture all the stuff that this guy learned and then send it to the other core.
Oh, okay.
Okay. I think it will come together more once I've showed the hardware structures.
Okay.
So I've got the program counter, I've got my data. I'm going to summarize all that in this summary generator. And all of this is on core 0. And then the summary generator is going to summarize all that information, compress it down, send it off to the summary-driven prefetcher over here on core 1. And then that's going to send a whole bunch of requests out to the memory subsystem.
So isn't memory slow? How is this helping? How is it speeding things up?
So it's helping things. It's focused just on improving the speed of the thread migration by having these extra hardware structures capture all the learning that happened on the core and sending it to the next core.
Oh, okay.
That make sense? Okay.
Sure. Okay. Thanks.
All right. So you saw that Leo's talk was basically incomprehensible. He was using a ton of technical jargon. He was jumping very down deep into the solution without really motivating it by a problem. He was way beyond the background knowledge that his audience had. And even if they'd had more background knowledge, it really would have been really hard to follow his solution. Now, he may have thought that by confusing his audience, he was sounding smart, but in fact, you're going to do just the opposite if you do that. Your audience is very smart themselves, and making them feel like they don't understand something, they're probably more than likely just going to think, wow, that person really can't understand or talk about what they did. They probably don't even understand it themselves. Why are they using all this technical jargon when simpler words would do? So you really want to avoid confusing your audience. That's never a good plan. So think back to Leo's first example. He used clear language. He described the solution in an elegant way, not in as much technical detail, but it was very clear that he knew what he was talking about. And it was also clear that if you asked him to go deeper into any one of those technical issues, he could have. So what you're aiming for is a clear, elegant presentation of your solution, not a ton of technical detail all thrown on top of each other. Now, this begs the question, do you ever want to go deep? Generally, less is more, but you do want to show off that you have some technical depth. So a good rule of thumb is generally stay relatively high level with your solution. Make it elegant, make it clear, but choose maybe one piece of that solution to go into a little bit more technical detail on. This could be a piece that they ask you about in particular, or this could be a piece that you've pre-rehearsed. Be ready for either situation. But keep in mind, you never want to confuse your audience, and when in doubt, less is usually more. This next pitfall is probably my favorite. It's called the chronology, or what I did last summer. And we're going to look at in this video how to identify that pitfall and how, most importantly, to avoid it. So here's the situation. You worked really hard on this project. You put a lot of work into it. And a lot of the work you put into it was down dead-end paths. That's just the way work goes. You do a lot of attempts, you revise, you make things better, your solution gets better. But wait, you put a lot of work in. You want the person you're talking to, this interviewer, to see you're a hard worker. You did a lot of work on this project. So how can you convey all that hard work that went into this project? Well, a common pitfall is to simply talk about all that work that you did as if you were giving a book report or a what I did last summer report back in elementary school. So let's take a look at what that looks like. Well, what we did was we started off by assuming that all of the streets are going to be two ways.
Okay.
So when we were trying to identify our intersections, what we said was, well, let's consider all the points, and then all of these points come together like this. And so each point always has an edge coming in, edge going out, edge coming in, edge going out. And so that worked pretty well. So we could basically just say, as long as there are two outgoing edges, two incoming edges, and they all have the same name, then that's an intersection. So we thought that that was all we had to do. But then it turned out that we wanted to represent one-way streets as well. So we changed our representation. So our file representation looked something like this: point 1, point 2, and then some road information, point 1, point 2, point 3, and then some road information. So in the first version, these were two-way streets, and then the second version, these were one-way streets.
So how would you deal with two-way streets in there?
Well, you'd have to have two different segments, one in each direction.
Okay.
Which, was a problem because these now have different meanings, so we had to change the name of the file so that we wouldn't get confused between the first file type and the second file type. So now we added the extension .oneway onto the file name so we wouldn't get confused.
Okay.
But we also had to change our algorithm here to find the intersection. So instead of having always streets coming in and streets coming out, we might have also had things that look like this. They might have had one road passing through. There might have been, two roads coming out and just one coming in. They might have been like, 5-way, like this, with some of the roads going in. and things just got really complicated. And the data structures we were using, it didn't really support this added complication. So we went from using just a simple kind of adjacency list representation where we only had one direction, and then we had to add all of these helper methods, and it was getting really complicated. And so we decided to totally change it. And so we just like kind of threw that all out, and we decided that we needed just a totally different representation for this one-way street data. So it seemed like I cared a lot about all those dead ends I ran into and all that work I put into that project and that solution. Does anyone else care? Unfortunately, probably not. In fact, all of that explanation that I talked about, all the dead ends, all the things that didn't work, it just made the solution seem really complicated. And while you think you're showing off how hard a worker you are, what actually might be coming across is, wow, this person writes really complicated solutions. That is never the goal. You do not want to portray yourself as somebody who comes up with complicated solutions. We're after simplicity. We're after elegance. Yes, it might be challenging to get to that simple solution, but it's not a good idea to make your solution sound really complex and hard to understand. So as hard as it is and as hard as you work, your goal is to boil down the solution into something elegant, creative, and fairly simple. Now, occasionally you'll be asked to talk about a dead end you ran into or a specific challenge you had along the way. And in those cases, it's appropriate to focus on a particular dead end that you ran into. But in general, don't treat this like you're presenting a summer report from back in grade school. Your interviewer does not care about what you did on every single day of the time you're working on the project. They want to know what was elegant and simple and effective about the solution. So the take-home lesson here is simpler is almost always better. So the last thing we're going to look at in presenting your solution is not really a pitfall, but it's how to use visual aids appropriately. So by the end of this video, you'll be able to identify and employ some good visual aids in describing your solution. Now, visual aids are kind of a luxury. It won't always be possible for you to use visual aids. You might be in a situation where you're just talking to somebody face to face and you won't have any visual aids, and you'll see yourself maybe gesturing in the air a lot. But if you do have access to a whiteboard, then you should learn to use it so that it helps your explanation, your technical explanation, and it helps the person that you're talking to understand exactly what you did. So let's look back at some of the videos from this week and look at how Mia, Leo, and I use visual aids in our presentations. So let's say we have some streets that look like this. There's a street here, and maybe there's a curvy street right there, and another street running here, maybe another street running there. And the goal for the learners is that they want to find intersections in this map, or take intersections in this map, and then plot directions from one point to another. So basically what they need to work with is these intersection points and connections between them. But this map data, as you can probably imagine, is real world and it's extremely complex. So there's a lot more than just these intersection points in this data. In fact, in addition to these intersection points, you actually get all these other little points along each of these lines. So you've got all these yellow points here, and ditto for all the other lines here.
So those dots trace the shape of the road.
Exactly. So these dots are necessary so that we can trace the shape of the road.
So let's say you've got some program. Let's say I've got program A, and I want to run it. Well, I'm going to run it likely on a processor.
Okay.
Now, in the old days, and by old days, I mean like 2004, you'd only have one choice when you ran the program. It could only run on the chip, because the chip could only run one program at a time.
Okay.
But after 2004, we started getting multi-core processors.
Okay.
And have you heard about those before? Or?
Yeah, all the laptops these days have quad-core, all these other.
Exactly. That's exactly what it is. So you have more than one core on a single processor, and what you have here is you got your 4 cores here, and now you have choices.
So you saw some examples, and again, I want to go back to the notion that these didn't come automatically. It's not like we just stood up there and automatically drew these nice diagrams. We practiced this over and over and over. So oftentimes, people tend to write either too much or, more commonly, they write too little, and what they write is just sort of nonsensical and not well organized. So we encourage you to practice how to use your visual aids, in particular how to write on a whiteboard to illustrate a technical concept very clearly. The last piece that we're going to talk about here is communication skills. The important part here is not that you stand up and present for some audience, but that you really communicate with your audience. You're trying to convey to these interviewers or to your colleagues at work that you have a good solution to a problem. And soft skills, those communication skills, are a big part of what's going to make you successful. So by the end of this video, you'll be able to employ appropriate soft skills like eye contact, body language, and other soft skills to make your audience care and understand the problem and solution you're talking about. And you'll also be able to view this presentation not as a presentation at all, but really as a conversation. So at the end of the day, this really is a conversation. You're in conversation with the people that you're presenting to. You've got something really exciting to tell them, and you want them to care, and you want them to understand. So how do you use these soft skills to make that happen? Let's look at some examples from these videos that we've been showing you throughout this whole week of how Leo, Mia, and I really turn this presentation into a conversation with another person.
So tell me about a project that you worked on.
Sure, let me tell you about some code we developed for part of the third course in the specialization.
Okay.
So the project in that course is we want the learners to take some map data. So some data, some street data in the world. So let's say we have some streets that look like this. There's a street here, and maybe there's a curvy street right there, and another street running here, maybe another street running there. And the goal for the learners is that they want to find intersections in this map, or take intersections in this map, and then plot directions from one point to another.
So can you tell me a little bit about a project that you worked on?
Yeah, I'd love to. So let me tell you a story from a project in computer architecture research.
Okay.
So you're familiar much with computer architecture research?
So-so.
Okay, so it's like the high-level design of processors focusing on like performance or reliability or power. Okay, and I think it'll become more clear as we kind of walk through.
And so we were thinking, well, maybe the Scott rank of the automatic world is going to be bounded quite a bit lower than the computable world because they're so much smaller and weaker and, you know, these tiny little things. But the amazing thing was that we proved that you can find structures that are arbitrarily complicated in terms of Scott rank, that they have really, really, really high Scott rank, but that are still automatic. And so even though these machines are like way smaller and simpler and stupider than the full-blown computers, they can still code up objects that have arbitrarily high Scott rank, as high as any computable structure.
That's really neat.
It's so cool.
All right, so what did you see in those examples? Some of the important skills are eye contact. Look at the people that you're talking to. Even if you're talking to more than one person, look at various individuals. Look around the room. Make sure you're making eye contact with them. When you make eye contact, it will be easier to read their expression. So make sure they're really following along. If they look confused, you should feel free to ask if anyone has any questions. Or maybe you want to slightly change your explanation so that they have a better understanding. Along those lines, if they do ask you questions, make sure you really understand what their questions are. We'll talk about answering questions in the next video. But make sure that you're not leaving them behind in the dust. Then finally, be excited about your problem and the solution. So be animated, not over-the-top crazy animated, but don't just stand there and talk like this and this is the problem that I solved, because you sound bored by your own solution. And let's face it, if you don't care about this problem and the solution that you created, no one else is going to care about it. So practice with these soft skills, practice having as many conversations as you can, get people to really care about and understand your solution.
Recently, I had a technical interview with a local San Diego-based company. When I was going into this interview, what I didn't realize was how important interpersonal skills are to the interview process. When I went through 3 rounds of interviews with 3 different product teams, it wasn't so much the technical side that was challenging for me. The most important part that I took away from this was that I needed to be able to talk freely, and be myself amongst 3 different product teams.
The last piece of interacting with the person you're talking to is answering questions. So even if you've got a good rapport and you're doing really well explaining the technical concept, questions can often be very tricky. It's important to handle these appropriately, give good answers, and not belittle your audience. So let's take a look at a bad example of how Leo responds to my question about his work. So this sounds a lot like what a candidate we had in last week was talking about, and they presented a solution using hardware prefetchers. Did you consider that approach?
So hardware prefetchers wouldn't solve this problem at all, and there's no reason I would consider that for this.
Okay. All right, you can see that Leo really shot me down. Now, it may have been a not so great question, but even if it was a not so great question, it's never a good idea to make the question asker feel stupid. So you need to handle these questions with a lot of tact. And in this case, it wasn't such a bad question after all. So there was a much better way to respond to that question. Let's take a look at how Leo would actually handle this if he were asked this question in real life. So this sounds a lot like a candidate we had in last week was working on a similar problem, and they presented a solution using hardware prefetchers. Did you consider that approach?
That is an excellent question. So we actually considered hardware prefetchers. Hardware prefetchers are on a core essentially designed to try to guess what's coming next. And they work really well when your program's already running. But the point of migration that we're talking about here, your program runs to a halt because it can't execute because it doesn't have any information that it needs. And a prefetcher completely fails in that environment. So we actually thought the same thing, but it turns out it actually doesn't work at all.
Okay, thanks. All right, so that was much better. It acknowledged that the question was a good one. It tied in my question to what he had already explained, and it really helped me, who was trying to learn a lot from his talk, understand where my understanding, and something I learned about just last week, fits into his new solution that he's presenting. One of the reasons that answering questions is so hard is that you can't prepare for them. And sometimes it feels like you're really being attacked when people ask you questions. But keep in mind that if someone's asking you a question, it's because they're actually interested in your work and they really honestly want to know more. So we have some tips for you to help you handle questions more effectively. First thing you want to do is you want to make sure that you acknowledge the question asker. This is somebody who's genuinely interested in your work and you want them to feel good about asking the question. Secondly, make sure you actually understand the question. I can't tell you how many times I've listened to people answer the question in technical talk that's not the question I'm asking. So if you have any doubts about the question, be sure to clarify what the question asker actually means. The third thing you want to do is answer the question in a good way by referring back to the work that you've already done. So tie in what the question asker is asking with things that you've done in your work. It's all stuff you should be familiar with. It's nothing new. They're not asking you to rederive some formula on the fly. They're just honestly wanting to know more about what you've already done. Finally, after you're done with your explanation, make sure you check in with that question asker. Did your answer actually answer their question? Make sure that that's the case. Otherwise, encourage them to continue the dialogue. And if it ends up that the discussion is taking up a little too much time, you can always suggest that you meet later offline to further discuss their question and your response to it. Okay, so we've looked at soft skills of communication like eye contact and speech patterns. And we've looked at the very tricky skill of how to answer questions on your technical explanations effectively and appropriately. The last piece that we're going to focus on here in our soft skills lesson is about how to talk about your contribution to group work. So by the end of this video, you'll be able to appropriately describe your contribution to a group project. So what you're going to find in these interviews is that sometimes you'll be talking about a project that you've done, but oftentimes these projects that you've done take place in a larger context of a group. And sometimes interviewers are interested in your own contribution, but often what they're interested in too is how you work as a team, how you work in the context of a larger group project, and how you're a productive team member. So they want to get a sense of how you work in a group and what your particular contribution to a project is. So the question might come in many forms. They might ask you to talk about challenges you faced in group work, or they might ask you to talk about a large project and describe your contribution and how it fits into a whole. Now, the technical piece of your explanation can match what we've been talking about all week, describing the problem and the solution and how it all fits together. But when we bring in this specific group work piece, there's some added subtleties to what you'll want to think about. So one thing, as I mentioned, that they might ask you is to talk about challenges you faced when you were working as part of a team. So let's take a look at Howard, a Google engineer who's going to talk about that particular, who's going to respond to that particular question.
Okay, so why don't you tell me about a project you've worked on in one of your prior positions, and if there were any challenges working on that project, if you could describe them and how you overcame it.
So I recently finished a product serving primarily as a web software engineer in the mobile analytics space. And so it was an Angular JS, JavaScript heavy client application, and I worked on a new team with a large diversity of really smart people. I think there were a lot of awesome opportunities and experiences I had. One, just growing my web development experience and really seeing a project of this scale be released to production. But there are definitely some challenges, right? As I mentioned, I was working with a large team of a large diversity of types of folks, people with different skill sets and abilities, backgrounds, views, and perspectives. And so one of the challenges was to really ensure that I was positioning myself within the project to be as helpful, as most effective as I'm communicating and working with others as possible. I think another challenge was seeing the design and architecture process from a perspective that span outside of a technical viewpoint, right? And so looking at different people's aspirations professionally in technical areas of development and allowing them to grow, continuing as a software engineer through that design process was one of the areas as well that was a bit challenging, but we were definitely able to do.
All right, so what you can see is that Howard highlighted the challenges that he faced and how he was able to overcome those challenges to make the group's work even more productive than it would have been if everybody had just been working individually. That's a really good thing, because one very important thing that they're evaluating you on is, how will this person become part of our team? Is this somebody that we really want to work with that's going to make our organization more productive? Other times, they might be looking for something a little bit more technical, in particular looking for how your personal contribution led to the flourishing of the group's work in general. So for example, when I talked about the problem that I worked on as part of the Course 3 development, when we were developing that map application, I only told you about a very small piece that was my contribution to a specific part of that project. But in fact, this was a much larger project that involved the work of myself and 2 of my students who were helping me out. So we had to work together in a team. So as you probably remember, this was a mapping application where we wanted to pull down real-world data from the internet and then distill that data in a way that the learners could work with it using these graph algorithms, and then display all of that data in this nice front end. And if you haven't taken our 3rd course, I really encourage you to go check out that project. It's really cool. But this involved dividing up the work between myself and the students. So I was in charge of the project as the faculty member in charge. And so the way I divided the task was that I was going to focus on the pieces of the code and the project that were closer to the learners had to work with. And my students, Adam and Alec, could focus on pulling the data, so the back end, getting the data into the system, and then displaying the data through this nice front end that they developed. But of course, there were interfaces between these pieces. So we needed to establish the interfaces where I would know what data to expect and what data they could give me in what format, and then what data I needed to provide to them. So early on in the project, very early on, we established these interface boundaries. And this allowed us to develop our own pieces independent of each other while being confident that at the end of the day, they could all fit together. Now, interfaces are never seamless, so open communication and regular meetings were also key. We would meet at least once a week to hash out the technical details of each of our parts and make sure that those interfaces were still fitting together the way that we expected them to fit together. And through this process of open communication, repeated work, and very early focus on the way our pieces were going to fit together, we were able to create a really good, successful product. And all in all, this work experience was fantastic. I had a lot of fun working on this team because we all shared in this very same goal of getting this product up and running, and we worked productively through these interfaces and these open communication channels. We all respected each other's work, and that helped contribute to the general positive overall approach of the team. So you can see in that explanation, I went into a little more technical detail. How did we break the work down? What was my personal contribution, and what did my teammates provide? And how were we able to create a successful group working environment? So as you start working on your technical explanations, we are not in the assignment going to ask you specifically to talk about group work necessarily, but do keep in mind that these are questions that you could get asked, and we encourage you to practice talking about how your project fit into a larger piece of group work. Because just like everything else, practice is what's really going to make for a really good performance in an interview setting. You've reached the end of the week, and now it's your turn. In your assignment this week, we're going to ask you to submit a video of you explaining a technical project that you've worked on, just like Leo, Mia, and I did at the beginning of this week. And you'll submit it for the review by your peers. So in order to get set up for this assignment, you're going to need a few things. First thing you're going to need is a video camera. You'll need to be able to video yourself and whatever workspace you're using to describe your technical solution. It can be any video camera as long as it takes a reasonably high quality video such that your peer reviewers will be able to see what you're writing and hear what you're talking about. The next thing that you'll need is some writing surface. So you'll want to use some diagrams in your technical explanations, so make sure you've got somewhere to write. Could be a whiteboard, a chalkboard, even just a big piece of paper. Just tape a piece of paper on the wall and use a nice dark marker to do your diagrams. The other thing that you'll need is someone to talk to. So you don't absolutely have to have this person in your video, but it will work better if you do. So grab a friend, grab a parent, grab a sister, whatever you like, and have them play the part of the interviewer in this video. So just like you saw Mia and Leo and I doing in our videos, this person should pretend to be interviewing you. They should start off by asking you to describe your work, and then they should play along as if they had some technical knowledge. They should be, the audience for this video is somebody who is technically competent, but maybe not specific knowledge in your particular area. So once you've got those things, you're ready to go. What we'll ask you to do is we'll ask you to choose some project from your resume and then to present that project. Now remember that any project that you list on your resume is fair game for a question like this. So make sure you've pruned down your resume to include only projects that you feel comfortable talking about like this. But for this video, we'll just ask you to choose one of those projects. Then you should record yourself playing the interview just like we did and submit this for peer review. When you're developing your explanation, we encourage you again to use that STAR model where you describe the situation, the task, the action, and the result, and also to keep in mind the evaluation criteria that we talked about. How well did you explain the the problem and its context? How much did you make your audience and your interviewer care about this problem? How well did you explain the technical solution? And how were your soft skills? Because these are the things that your peer reviewers are going to be giving you feedback on. Now, unlike your video back last week that you took of the live coding in the Google Doc, these videos will be shared. We know this is an uncomfortable situation. We know it's not always comfortable to record yourself and then put those videos out there for everyone to see. Believe me, we know this. But it's something that is going to really help in preparing for your technical interviews. Just think about it. In your technical interview, you're going to be going in there and describing your work to perfect strangers. So the process of putting a video online should help you get more comfortable doing this sort of this presentation of yourself to people you don't know. The other way this video is going to differ from last week is that we do want you to practice. So last week, that first video, we didn't want you to practice at all. This video, you should practice a lot before recording it. Make sure you're ready, just like you will be ready in a technical interview. If you screw up one video, just erase it and start over again. This is not something where we want to get just the very first cold take. So good luck with this assignment, and we look forward to seeing some of your videos.
All right, we're in week 4 of the class, and this week we get to what I think is often the hardest or scariest part of the technical interview, which is where you're asked to solve a problem that you've never seen before, and that might be different from all the problems that you've worked on so far. And so what we'll be doing this week is talking about the strategy for approaching a novel problem and really giving you the tools to successfully solve it. We'll also talk about the presentation of that problem, both in terms of communicating with your interviewer to make sure you really understand what's being asked of you, and also presenting your solution on the whiteboard. So this week we're talking about algorithmic problem solving, and this is the strategy that you want to have when you're faced with a new problem that you've never solved before and you're being asked to work through during the interview. So what we'll be doing in this video is talking about a step-by-step approach to starting to solve such a problem so that you feel empowered when you're dealing with a question that you've never thought about before. So the first thing that you want to do when you're asked a question is to make sure that you really understand what's being asked, what the parameters involved are, and what the goal for the solution would be. And so your first task is to ask lots more questions. When faced with a hard question, ask as many questions as you can think of to tease out the relevant assumptions that the interviewer has in mind or that might be relevant for your solution, to tease out the scope of the problem that's being asked, and to try to understand what it is that you're trying to analyze and to solve. Now, once you've asked a lot of questions to make sure that you clarify the problem and know where to go, what you should do is confirm your understanding by working through an example. And working through an example is really useful because both it lets you get those creative juices flowing and start thinking towards a solution, but it also lets you take some time and think through the problem very concretely about what difficulties might be involved, where are the sticking points that any solution would have to solve, and also if there are any hidden assumptions or implicit questions that you might need to address again, and go back to that first step of asking more questions of the interviewer to really make sure that you've mapped out the scope of the solution that you need to come up with. Okay, so at this point, we have a very good sense of the task at hand, and we're ready to start to solve it. So in the next stage of the strategy, we just try to come up with a first solution. You want to make sure that at least you've got some approach to solving the problem that's being solved, so at least even if it's not a good approach, you've been able to do what's been asked of you. And so we call this the brute force approach. You take a hammer and you hit the problem with it, you make sure that you can nail that problem down. You've got some way of tackling it. This approach does not need to be clever, it doesn't need to be elegant, but you want to make sure that you've got a correct solution. And so as you're developing this brute force approach, this first naive solution to the problem, what you want to do is test it. Now, that means testing it with normal input, what you expect the problem to have to handle, but also with edge cases. Make sure that your brute force approach can handle both. And then think through a little bit, if you were to implement this first solution, how would you do it? What data structures would be useful? How would those data structures interact with the problem that you're working with? In particular, what performance would you get out of this implementation? And any trade-offs that you might be thinking about in terms of maybe using more memory to speed up the performance or vice versa. So we've got a solution, but we didn't spend very much time trying to make it clever or elegant. So our next step of the strategy is to iterate this whole process of coming up with a candidate approach to solving the problem, evaluating it, testing it, poking at it, making sure that it does what you want it to do, or if it doesn't, thinking about ways to fix it, and really trying to nail down as good a solution as we can. And you'll notice when you're in the interview that often the interviewer will try to guide you towards iterating your solution, asking you if it can be made better, asking you if there are any trade-offs that are in mind, and you want to think through this checklist of how you evaluate your strategy at each stage of the problem-solving process. Now, we iterate, we come up with a great solution that we think at the high level will do a pretty good job. We've done the asymptotic analysis. We have a sense of how long asymptotically, so in big O notation, each of the operations involved will take. And finally, In step 6 of our strategy, we finally write some code. And so only once we've done this very thorough analysis of the problem and have a very good sense of what we want to implement, now you can start writing some code on the whiteboard. Now, in the rest of the week, what we'll be doing is taking this strategy and applying it to 2 concrete examples of questions that you might be asked in the interview. And then we'll also be talking about how to do this programming on a whiteboard in the interview situation, which is really quite different from typing it out in a computer. And so that's coming up next. All right, let's dive into an example where we need to solve some problem. And so by the end of this video series, you're going to have worked through a full example using the strategy that we talked about last video. All right, so here's the question. We're given an array of integers, and we would like to find the kth smallest integer. All right, that's it. That's the problem. Now we have to solve it. So our first step is to ask lots of questions. Try to understand as much as we can about the task at hand. And so I'm going to leave it to you. In the next quiz, please try to think of however many relevant questions you might have that would clarify this problem. Take it from there. Welcome back. I hope the quiz gave you an opportunity to think about which questions would be useful to you in solving the problem. And it's a bit of an art form, trying to understand which questions you want to ask that will clarify the problem, but still be relevant and useful to you once you learn about the answers. So here are a few that I came up with. When we want to think about finding the kth smallest element of an array, we want to make sure that we are on the same page about what smallest means. Do we mean smallest magnitude, or do we mean smallest on the number line? And this is relevant if we have negative integers in the array. So for example, if we have negative 1,000, that's got a very high magnitude, but it's very much lower on the number line than, say, the integer 1. So we want to just make sure that we're on the same page with the interviewer about what they're intending from the question. We also want to ask things about the structure of the array and what we're allowed to do with it. Are we given the array as a pre-sorted collection of elements? Are they already organized? Or is that maybe up to us to decide how to organize those elements? And speaking of which, when we're deciding what to do with those elements, are we allowed to change the array as given to us? Is it mutable? Are we allowed to change it in place, or do we need to make a copy of it and then manipulate it as we see fit? Also about the array, it's useful to know if there are duplicate entries. Do we need to think about possibly some array elements having the same value? And then in that case, what do we exactly mean about kth smallest? Do we mean the kth smallest distinct value, or do we mean the position in the number in the kth position when we order all the array elements, including duplicates? And so this is something that we would want to clarify with the interviewer. Going along with that question, when we're talking about kth smallest, we want to make sure that we understand how k behaves. Are we starting the indexing at 0 or 1? And so we want to look at each of the words in the questions being asked and really dig deep onto that word and understand how it's going to relate to the solution that we want. So now that we've understood the problem very well, it's useful to work through an example with not too few but not too many array elements so that we really confirm all of the answers to the clarifying questions that we've asked. So it's good to think of an array example that has some of the possible strange behavior that you would expect if you want to maybe take into account negative integers. You might want to take into account 0, some positive integers. And this example is going to assume that our interviewer said there are no duplicate entries. But if he or she said that there might be duplicate entries, then you definitely want to take that into account in the example that you work through. But right now we're going to assume that there's no duplicates in our array. So we plop down a few numbers, and now we ask ourselves, what would the solution, the expected response to our algorithm be if k were to be, say, 1 in this array of integers? And if k is 1, then we're looking for the smallest array element in this given array. And so we scan through the array elements, and we see that the smallest value is -3. And so that would be our expected response. And then we could ask, well, what if k was 2? Well, then our problem is asking for the second smallest element, and so we don't want to output -3 anymore. We want to output the next smallest, which is 0. And one thing that's useful to do as you're working through this example is think about how you as the human is solving the problem for the small example, and keep in the back of your mind how would you generalize this strategy and write it down systematically so that an algorithm could perform the same tasks. And then last but not least, we also want to think about maybe some edge cases in this example. What would be the highest value of k that would make sense? And the highest value of k that would make sense would be the number of elements that were given to begin with, because if we ask for the 8th smallest array element in this collection, then what we're really asking for is the biggest element, and so that would be 42 for this small example. And so as we're thinking through these cases, we might recognize that to ask for the 8th smallest element is really asking for a symmetric problem about the largest, and so that might already get your wheels turning about a possible optimization later on in our algorithm, and we'll come back to that later, but first we're going to do the next step in our strategy, which is just the naive implementation of brute force solution to the problem. So that's coming up next. So we've worked through this example, and now we really understand the task at hand. And so it's good before we do the solution to just reaffirm what the assumptions that we're making are. And at this point, we know that our array is given to us without any information about how it's organized, and it may have some duplicate elements, but we're allowed to change the array as we proceed with the algorithm. And so we're looking for the kth smallest element, and what we might want to do is build up to the kth smallest element by looking for the smallest element, and then the next smallest element, and then the next smallest element after that, and then keep on going until we've gotten to the kth one. We notice that that's somewhat similar to the procedure that we have to do for selection sort. And with selection sort, we find the smallest element and we swap that to the first position of the array so that we can think about ignoring it afterwards or discarding it in some sense. And then we focus on the rest of the list and find the smallest element among those remaining elements and swap that to the beginning, and then just keep on focusing on the remaining elements. And this would give us an algorithm that's a variant of selection sort that we already know. And so it's always nice when we can use our previous knowledge to inform design of future algorithms. But before we go ahead and code this solution, let's analyze it to see if it's worth coding, because it was just our first hunch at how we might solve this problem. And so it's good to stop and think and evaluate before we go further in any one direction. And so if we evaluate the performance of this approach, what we're doing at each point is finding the minimum element of an array of numbers. And if we want to find the minimum amongst an array of elements, what we have to do is look at each one of those elements. And that takes linear time. And so even though the number of elements that we're considering each time decreases by 1, we still might be doing this, we still are doing this k many times. And so for really small k, if we just need to find the very smallest element or the second smallest element, in that situation, this would give a linear algorithm. But in the more general situation where k maybe is n over 2 and we're finding the element that is right in the middle, the median, then if we have to do this approach, say n over 2 many times or any O of n many times, then all of a sudden our algorithm becomes quadratic. And that's a problem, because quadratic algorithms, they're kind of slow, especially if our problem has something to do with sorting. And so we've already seen how the algorithm that we're devising is related to sorting in the sense that it's related to the selection sort algorithm. And so maybe we can use that insight to come up with a better solution. And so what if we sorted the array before doing anything in terms of finding the kth element? And as a pre-processing step, let's just apply our favorite sorting algorithm and organize all the elements from smallest to biggest. And the advantage of doing that is that at this point, the element that we care about, the kth smallest element, is in position k in the array. And accessing an element in a particular position in the array is a constant time operation. So overall, we've now come up with an algorithm that takes however long a sorting takes for the pre-processing step, and then O of 1 time for the second step, which is retrieving that kth smallest element. And the advantage of having these two separate steps is that sorting is a really well-studied problem, and we know that in the worst case there are still algorithms out there that solve sorting with n log n time. And so that's a really big improvement to quadratic time, and so we're feeling pretty good that we've made a pretty dramatic improvement to our original naive approach to solving the problem, and now we have a slightly less naive approach. And at this point, we might be feeling comfortable enough with this approach to go and code it on the whiteboard. And so that's what we'll be doing next. So now that we have a strategy in mind, we're ready to move to the whiteboard and actually start implementing it, pretending that we're in the live interview situation. You'll be talking with an interviewer and you'll be working with them next to a whiteboard, which means that we're not coding in an IDE or even on a computer. And so the strategies that we have for describing our code on the whiteboard will be a little bit different from what we've talked about before. So let's work with the example that we have so far. And remember, our strategy for finding the kth smallest element in the array is to first sort the array and then just pick out the kth element. And so let's go ahead and write that. And at this point, we might have asked the interviewer whether we should assume that the method is public or private. And maybe they said it doesn't matter, or maybe they said that it was public. And so we start with our header. And we know that we're supposed to be returning the value of the kth smallest element. And so we're returning an int. And we want a descriptive method name. And so maybe we call this kth smallest. And as inputs, we have both the array of elements that we started with as well as the rank. And so we have int array, and we have the rank that we want to return. Okay. And so here's our method header. Now, the first thing we might want to do in our method is just make sure that that we have some validation of the arguments and make sure that the parameters make sense. And so what we will do is check if k is less than or equal to 0, or if it's greater than array.length, in which case it doesn't make any sense to ask for the kth smallest. So in this situation, we want to throw an exception because the arguments are just no good. And so we're going to throw a new illegal argument exception. And that's that. But really, the heart of the strategy is going to be if we do have good arguments, and then our plan was to sort, and we can use a library method for that. We've got arrays.sort the input array, and then we're going to return the element in the kth position after we've sorted the array. We have to be a little bit careful. Remember, we talked about what we're assuming k is indexed by, and if we're thinking of k as starting with 1, so we were talking about the first smallest as the minimum and then the second smallest, etc., then what we want to return is the element at the array position k minus 1 rather than k. And that will be that. And so what we have now on the board is a description of the algorithm that we've articulated for solving the problem. And what we would do now is perhaps walk through with an example. But before we do that, I want to step back away from the context of being in the interview and just talk a little bit about some good whiteboarding techniques and strategies. And so one thing you might notice in this sample code is that we use relatively meaningful names. So the method name is helpful to the reader as to what we're doing. Also, in this code, I tried to keep a lot of space between the lines. And so if I needed to go in and then edit or add or change some of the code later on, I would be able to fit some extra pieces of code in between the spaces, because unlike a computer, we can't copy and paste and we can't move things around very easily. And so it's good when we're first throwing some code on the board to try to give ourselves the potential for modifying it later. Something else you want to keep in mind is that you want to use variable names that are easy for the interviewer to see. So for example, K is a good choice for a letter that's being used for a variable name. You might say that if you were typing it up, you would use maybe an even more meaningful variable name like rank, but in the interests of time, so you don't have to write out all 4 letters each time, you're just going to use K. And a rule of thumb is that K is often a better choice than I or J, because those can, for one thing, look really similar to one another on the board, and also they can be mistaken for semicolons. You also want to make sure that you're writing big enough and legibly so that someone who is following along and reading with you can make sure they understand what's going on in the code, and then you can work on developing the algorithm further. And so at this point in the interviewer might go in a few different directions. They might ask for us to actually implement the sorting method instead of using a library call, or they might ask us to go further with the algorithm. And so that's what we'll do in the next video. So at this point, we're going to switch to slides, but I don't want you to switch to the computer. And so what I mean by that is that when you're thinking about practicing these algorithmic problem solving on the fly, it's really important to try to make the situation as realistic as possible. And whiteboarding is something that we as programmers don't do very naturally. We don't often write out code on the whiteboard when we're developing a new program. And for the future practice problems that we invite you to do, we really, really, really encourage you to be as far away from a computer as you can, be at a whiteboard or at a piece of paper taped up on the wall, and actually write out what you would be doing as though you were in the interview situation with someone next to you helping you practice, or role-playing in a room, making sure that you have that authentic experience that will get you prepared. So at this point, what we're going to do now is go further in the algorithm that we're developing. And if you think back to what we did, we sorted the whole array before picking out the kth smallest element. Can we probe the solution? And can we really think about optimizations? And for example, maybe we don't need to sort the whole array. Maybe the array is a huge chunk of memory, but we only care about k that is, on the order of millions, not billions. And so what could we do if we were in that sort of a situation? And so at this point, you want to brainstorm and see what are other strategies we have for coming at that kth smallest element. And one data structure that we have that helps us keep elements in a somewhat organized fashion is a max heap. And so we know that in a max heap we have this tree structure whose root is the maximum element. And so if we're looking for the kth smallest element in a group, and we have all k smallest elements arranged in a heap, then the root of that heap will be the kth smallest. It will be the biggest amongst the k smallest. And so maybe what we could do is build a heap of size k where we want to make sure that the elements in that heap are the k smallest overall. And so let's think about how that would work with an example. We don't want to have all of the elements in our array in that heap. That heap would be too big. We just want to focus on the k smallest. And we're really taking advantage over here of the difference in magnitude between k, which is the rank that we're looking for, and the overall size of the array. And so if we restrict our heap to just 3 elements, say if k is 3, then we might walk along our array and insert elements into the heap. And so we insert 17, that first element, into the heap, and then we insert the next element, 42, and of course 42 becomes the root because it's bigger than 17. And then we insert 0 as well because we need 3 elements in our heap. And now we go ahead and look at 5, and we want 5 to be in our heap as well because it's smaller than 42, it's smaller than 17, and so it is a candidate for being one of the 3 smallest elements. And that's what the heap is trying to capture, the 3 smallest elements overall that we've seen so far. And so what we're going to do is to swap out the current maximum element in the heap, remove it from the heap and put 5 in instead. And so 5 goes in, and it has to go in its correct location, so we still have a heap structure. And the advantage of that is that now 17 gets put to the root. And so if we find some small element later on, then we know that we're going to remove the biggest element in our current heap and put in the smallest element, so that at each stage we have the heap is containing the 3 smallest elements that we've seen so far, and the root is the maximum of those. And so we continue, we look at 10, and it's got to go in instead of 17. We look at -3, it's got to go in, but now 5 becomes the root. And we keep on going with 2 and with 9. And at this point, we notice that our heap has 3 elements, and so the 3rd smallest element in our whole array is going to be the root of that heap. And that's beautiful because we can just read off the root of the heap. And so what we've done here is we've used somewhat fancy data structure, but a very standard one that we have in our back pocket that we're prepared for. And we've used this property that the root is the maximum element of all of the elements in the heap. And that's helping us to solve this problem. And so this is a nice strategy. It's nice also that we're demonstrating some creative problem solving, some flexibility, so we're not focused on one particular problem solving strategy, but we're demonstrating that we're thinking about different avenues. And at this point, we might go ahead and code up this strategy. Now, this is a lot of code, and it would probably take us a few minutes to develop it on the whiteboard. What I want to focus on is that as we develop this code, we notice that we're using some data structures, and in those data structures, we're demonstrating that that we're familiar with some Java libraries, like the collections library, like priority queue. In particular, when we're implementing a max heap, we need to reverse the order of the comparator. And so we're demonstrating that we are relatively sophisticated programmers. We also want to test and analyze our new strategy. It's great that we were creative and came up with a new one, but we also want to see if we made any progress, if it performs any better than our very, very simple sort and then pick off the kth element strategy. And so we can look through our code and look for where do we have function calls that take some time, and how does the performance depend on k and on n. And what we notice is that at the beginning stage, for the first k elements of the array, we're just adding each one of them into the heap. Add them into the heap. And then afterwards, we're only adding into the heap if the current array element that we're looking at is really smaller than the maximum element at the root of the heap. And only at that point do we swap the current element into the heap. Now, in each of those situations, we have to do some heap operations. We're adding into the heap, and we're removing the root of the heap as well. And so here, it's important to know that heap operations like insert and remove take time that's logarithmic in the size of the heap, because we might have to traverse all the way down to the bottom of a path, and the maximum length path, it could be at worst log the size of the heap, log the size of the tree. And so we see that we're doing these operations, we're doing a constant number of these operations for each array element that we're looking at. And so all in all, this algorithm is going to have performance that's O of n log k. And that's interesting because we can compare this performance to what we had before. And again, we're demonstrating our critical thinking, our analysis of the two algorithmic approaches that we have. And before we had an algorithm that was O of n log n, and now we have O of n log k. And so we've made some improvement if, in particular, k is going to be much smaller than n, but still grows. And so we still want to take that into account. So this is a very, very different problem-solving strategy from the first one we saw, and we might go even further, and that's what we'll do next. All right, so now for something completely different, we're going to find yet a third algorithm. It's not going to be the sort then probe algorithm we started with and coded on the whiteboard. It's not going to be the algorithm that relies on the max heap that we just talked through, but rather what we can think about is going through our arsenal of sorting algorithms, what else is useful? And we have a really interesting sorting algorithm from Quicksort where we use a pivot behavior and we recursively sort different parts of the array based on partitioning the array into the smaller than the pivot and larger than the pivot. And so what we can do now is recognize that sorting was useful for solving our new problem, and so maybe we can use a sorting algorithm and modify it in some way to make a new algorithm that's useful for the current problem, the problem of finding the kth smallest element. And so what if we picked a pivot in our elements, in our array of elements, and thought through what happens when we partition the array into the elements that are smaller than the pivot and those that are bigger than the pivot. Now, we're not looking for a fully sorted array at the end of this procedure. What we want is the kth smallest element. And what's really useful here is that if we partition the array into those that are smaller than the pivot and those that are bigger than the pivot, then if we only have, say, 3 elements that are smaller than the pivot, then the third smallest element overall is going to be the maximum of those 3 elements, because the pivot's going to be bigger and all of the other elements in the array are going to be bigger than those bottom 3 elements, and so they're not going to be the third smallest. And so the beauty of this approach is going to be that we only need to recursively look at only roughly half of the elements each time if we're lucky with our choice of pivot. And so what we can do is at each stage pick some random element of the array, partition the array into those elements that are smaller than the pivot, those elements that are bigger than the pivot, and then look at the size of the set of elements that is smaller than the pivot and compare that size to the rank. Because that size of that set is going to tell us whether the kth smallest element belongs in that set of elements that are smaller than the pivot, or maybe that kth smallest element is the pivot, or maybe that kth smallest element is bigger than the pivot, and so we need to look in the rest of this the array of the rest of the elements in the array. And so we can code up this strategy, and notice that this is going to be a recursive method, which is great if we can come up with a recursive solution to our problem strategy. We're demonstrating yet another skill in programming and algorithmic development in our interview. We're demonstrating our breadth of knowledge, and we want to still be careful about the code that we write. We're doing the input validation. We have a helper method, and so we're demonstrating that we know the difference between the private helper methods and the public method call that we have. And then as we go through this recursive function development, it's going to be very important to test the code, which is why we had that base example that we can keep tracing through. Now, as we develop this new strategy, we still want to think about performance, and the performance is going to hinge on the fact that when we compare to the pivot at each recursive function call, we hope that we're going to divide our array of elements into the smaller thans and the bigger thans, and those are going to be hopefully roughly the same size to one another, and so we get to reduce our problem size exponentially by reducing the array size in half each time. And so what we're hoping for in, on average at least, is linear time and a careful analysis of the recursive performance of that function would really get us that it's expected O of n time. Now, in an interview situation, this might seem a little daunting to come up with such an elaborate algorithm and to do its performance analysis, but here's the punchline. What we want to make sure to do in the interview is always keep going. We never want to be content with the problem with the solution that we have at hand. And so when we do have a solution, it's really important that we think about, does it match the assumptions that we made at the beginning? How would we change it if we had different assumptions? If, for example, we allowed repeated elements in the array, what would we have to do differently in our methods? We want to consider performance every time we come up with a new problem-solving strategy. Have we made progress, or maybe have we gone backwards? Are we coming up with better solutions, or are we coming up with just different solutions? And then are there trade-offs that we can consider there for time versus memory? And keep going, keep going. Think of ways that we can bring in our tools. And what we want to do is, through our practice, have a wide array of tools that we can apply to new problems. It may well happen that you've done so much practice that in the interview situation, you're asked a question that you've already solved. Now, it's really important in this situation to mention that you've actually worked through that solution. And then the interviewer might ask you to still write out the solution, but then they might ask you to go further, like we did with those additional algorithms, and take different assumptions or go in different paths so that you can demonstrate your novel problem-solving skills. And when we are approaching a problem that's very new, what's useful is when we've done all that practice, that we can go through a mental checklist of all of the useful data structures that we have and all of the known algorithms that we've worked through, and really help solve the new problem using what we've done before.
So when I was having this interview, he asked me a data structure question. So as I was trying to come up with the solution really quickly, I realized by the end of writing down the code in the Google Doc, I made the solution O of n squared. The interviewer said it was all right, but a few weeks later, I didn't get the job. So what I've been telling myself since is, even if I think about a wrong answer, or just sort of get nervous because I really want the job, I should slow down and think, and then just do what I do at any other day, write code the way that I think is the best way to do it. And I've since been sort of like, before like each interview, just think about positive qualities of myself, and that makes me a little less nervous, but I think it makes me do a lot better.
Prior was a software engineer at an investment bank in New York, and I think through that tenure, there are three things that I found to be super important. The first would be brand, and I think this would be important for someone to focus on within their career, regardless of their demographic, but for someone like myself, I think is super important, right? And so often there will be opportunities, types of projects, areas of growth that I would have, and because I focused on my brand, I really empowered people to know who I was, what my goals were, what my strengths were, and where I wanted to go. I empowered folks that I worked with the opportunity to give me experiences, projects, exposure to different things that I had not had in the past. I think the second thing that's super important would be relationships. And so that might be something that you might not have thought of initially, but relationships are key, right? You work on, again, with a diversity of people on global teams sometimes, and it's really important that you know who's on your team, that you know the things that you may not necessarily consider are super important. Ask about how their weekends were, know who their family members are, right? Know about their hobbies, know about what their personal and professional goals are, so that as you work together, you can make sure that those things are highlighted. I think the third thing is definitely technical excellence, having a central drive and ambition to learn. Technology is always changing, and the stronger technically you are on your team, the more value that you can add towards building XYZ products.
So at this point, we've talked a fair bit about algorithmic problem solving on the fly. And what we're going to do now is think about how this process is being evaluated. So we'll talk about some criteria that recruiters and interviewers might use to evaluate your problem solving, and then you'll have an opportunity to try it yourself. So when we think about evaluating this activity of doing problem solving on the fly, there's really two categories of evaluation criteria. The first category is about how well you understand the task at hand. And that part of really figuring out what the problem is asking, making sure that you ask for clarifying questions if you have them, and getting all of the additional pieces of information that you need in order to really get started with a solution, it demonstrates a lot about you as an engineer. It demonstrates a lot about you as someone who is going to be working at the company. Because not only does it tell them about your technical competence and familiarity with what it would take to solve a problem, but also with your ability to think critically through the specifications of a problem that's set out, and also to foresee problems and to think ahead to what the client or what other team members might need, and what changes might happen after the fact as well. So how open you are to seeing all of the possible avenues that the problem might take later on. So in particular, the interviewer might be looking to to make sure that you're listening carefully, and that's demonstrating some of those positive soft skills that we've been talking about, and also the fact that you can actually understand the question that's being asked of you, and that as they try to help you, that you're responsive to that help, and that you're able to recognize it and then use it. And then that leads us to the second set of criteria, where the interviewer wants to make sure that you can actually solve the problem, that you can do the job. And so when you're doing the job, the interviewer is looking for you to be flexible in your problem-solving strategies, and to consider multiple alternatives and evaluate them before really plunging in deeply in any one method. But then also to make sure that you have time to actually solve the problem and get it done. But that you're open to working working with new ideas even after you have a solution. And so demonstrating that you're never really done, that you always are thinking about the next step and thinking about evaluating and iterating is a very positive aspect of this whole exercise. Now, these are the two sets of criteria that we have for while you're solving the problem that's given to you. But what the interviewer might also be looking for is that you might be ready to go to the next step as well. And so even if you start with a particular question, what you might find is you've solved the problem, you've got beautiful code written out on the whiteboard, you're proud of your work, and then you might feel like the interviewer is throwing you a curveball. Like they ask you something that isn't really in the scope of what you were asked earlier. And instead of viewing that as a negative, you should really view that as a very strong positive, that the interviewer is now feeling like you might be ready to go up to more complicated lines of reasoning and use some higher level analytical thinking. And that means that the interviewer thinks that things are going pretty well and wants to probe just how much further you can take it. Okay, so those are the criteria that the interviewer might be considering as they're evaluating your problem-solving process. And now it's your turn. So what I'd like you to do is take some time now to actually put our algorithmic problem-solving strategy into practice and come up with your design for a data structure that has public functions for three tasks: inserting an element into the data structure, removing an element from the data structure, and getting some random element from the data structure. And what I'd like you to do is actually go through the algorithmic problem-solving strategy that we've talked about. So think about asking clarifying questions, working through an example, coming up with some naive implementation of a solution, but then evaluating it and iterating to get to a version of the solution, a version of the solution that you would like to actually write out in code. And then what's really important is actually write out the code on whiteboard or a piece of paper and write it out not on the computer, as though you were in the interviewing situation. And then we'll come back and think about what you've just done. So I hope you found that exercise of going through our strategy for problem solving useful. And what we have now are a couple of clips from Google engineers who have taken on the role of actors and have done a couple of mock interviews for us to look at and analyze. And so let's take a look at an example of someone working through the very same problem that you just went through and see what they might have done well and what might be improved.
So has insert, remove, and get random. Is it storing any particular kind of data?
You can just assume that they're ints for now. We can generalize that later on.
Okay. All right. So we have insert, remove, and get random.
Right.
Okay. So you said they're just storing n, so can I assume like insert just takes in an integer?
Right, that's fine.
Cool. Remove will take in the int. And then, do they return anything?
What do you think they could return?
So, actually, how are duplicates handled? So if I have this data structure and I insert like 3 twice, how is that dealt with?
Well, for now, let's just not worry about it. Let's just assume that all of the input is going to be unique.
Okay.
We'll handle that later.
Okay. So in that case, insert and remove can return like a bool if, for example, if it's inserting a value that's already in the data structure, maybe it returns false, and likewise with remove.
Yeah. Sounds good.
Or just void or something.
Yeah, sure. I mean that's a good way of doing it. Let's make it simple. Let's start simple. Let's just have them be void for now if you want.
Okay, cool. So for get random, how exactly is that working? It just returns like any element in the data structure?
Yeah, so from the elements that are currently in the data structure, you should return one of them at random, so all of them have equal probability of being chosen.
Okay. Okay, so just to double check that I understand this, let me go over an example. So if I have my data structure, let's call it my data structure, and I insert, let's say, 1, and then 5, and then 10, and then I do remove for, let's say, 5. So at this point, 1 and 10 would be my data structure.
That's correct.
Okay, and then if I call get random, there will be a 50% chance that the 1 is returned, and a 50% chance that the 10 is returned. Okay, cool. The first thing that comes to mind is just I could use an array list. So that way when you insert a value, you just add it to the array list. And then for remove, you can do array list.move, remove. And for get random, can I assume I have some kind of like random number generator?
Sure, yeah. Okay. So you can assume that you have like a rand function that has a min and a max and returns uniform values between min and max inclusive.
Okay, cool. So if I have that, then I can, if I know the size of my array, which I do, I can just essentially get a random index using the bounds of the size, and then just return whatever value is there. So that's how I would do it with an array list.
Okay, sounds good. Yeah. Yeah, so what's the complexity of that solution?
Okay, so insert, I believe you're just adding it to the end of the array list, so that would be constant. Remove, you're just, okay, so remove is a little trickier because you have to find the element that you want to remove. So if there are 10 elements, then it's possible you have to kind of iterate through every one of those elements to search for the value you want to remove. So that would be linear, and get random would be constant. Can I assume that the random generator works in constant time?
Yeah.
Okay,
that's
cool.
Fine.
Let me see if I can think of a better way to do this. Let me see. So the problem here is that for remove, I have to search for the element that I want to remove. But I can use, if I use a hash set to store my values, then I can do the lookup in constant time. So, okay, so this is with my list. With my hash set, I can just insert the element in constant time because it's a hash set. I can remove it in constant time. And get random, get random is going to be a little trickier because I can still get a random index, but a hash set isn't, indexed. It's not in any particularly sorted order. So I guess what I would have to do for that is, if I want to get like the third element, I would kind of have to just iterate it through it 3 times.
Okay.
So that would be linear then.
Can you think of a way to combine those two, perhaps, to sort of get the best of both worlds?
Okay. Yeah. What if? Okay. What if I still kept my elements in the array list, but I used the set to track the indexes of the values? So if I add some element to my array list into like the 5th index, I can kind of keep track of that index that I've added it to. And that way when I need to remove it, I can just kind of look up where it's located.
Okay.
And I can remove it in constant time. And then I still have all the values in my list, so then get random should still work in constant time.
Okay, sounds good. Let's see some code for that then.
So for insert, like I said, it just adds the element to the end of the array list, and then I need to update the location in the hash map. Can I assume I have, like, there's an insert?
Yeah, sure. Yeah,
Okay.
yeah, that's fine.
So at this point, let's say I insert 1 and then 5. We insert the 1 at the end of the list, and then we put the 1 will map to the size, which at that point is 1 actually. So we'll need to subtract. So the 1 will map to the size, which is 1, minus 1, which is 0. So the value 1 will map to the index 0. And then if I insert 5, 5 will map to index 1. Okay, so your job is to write a data structure that will have 3 public functions: insert, remove, and get random.
Okay. Random.
Okay, so before you start coding, can we kind of pause for a second and can you just go over your high-level approach?
So what I was thinking is have an array where I can start putting like the values, and then sort of get random would be just returning a random element from the array.
Okay.
And sort of, yeah, I guess I need an array.
Okay. It also might help if you kind of clarify what arguments these functions are taking.
Right. Yeah.
And what they're returning. So like, what exactly are insert and remove taking as arguments?
Yeah. So they would just take the value.
Yeah. So for with remove, right? Like if it's storing 10 elements and you want to remove 5, how would you do that?
So it just takes the index, right, to remove, and I can just.
So.
So it's very similar. So the hash map also implements the collections. So I can also do insert and remove, like I was saying.
Okay.
But for hash maps, the remove is fast.
Okay.
It should run in constant.
Okay. And how would get random work?
I could do the same thing. I could just return one of the values at random. No?
So does the hash map have like this getter function where you can kind of give it an index?
I guess they're not indexed. I can just get the first one.
So would that be random though?
It's a hash, so it should be random.
So can you kind of clarify what you mean by just return the first one?
So I think like the hash map has a first and a last method, so I could just return like first.
Okay. And then how is this random? So let's maybe take a break and kind of explain how get random should work.
Okay.
So think of it this way, like if you have this data set and it has 5 elements and you call it get random, it should return one of those values with equal probability.
Okay.
So if there are 5 elements, there should be a 20% chance that any of those elements are returned.
So
So in this case, if you just return, the first element, you're just always returning, right? Like
Right. So this
given
doesn't
value.
change, right? So if I insert something, yeah, okay, but it should work always. So.
Okay, so what's next? We've seen one example and we've gone very deeply into that example, but one example is not going to make you feel prepared for your own technical interview. What you want is a source that has lots and lots of practice questions, but you need to make it real. And so what you ought to do is to take that book and flip to a page and start actually working through these questions as though you were being asked them in a real interview. And what's even more effective is if you have someone who is also preparing towards these interviews, preparing for this career path, is actually form a study group. And just like we talked before about what the UC San Diego students often do, work together and take turns role-playing. One of you be the person who's solving the problems, one person be the one who is acting the role of the interviewer. And the more you have the experience of solving problems on the fly, on a whiteboard or piece of paper rather than at the computer, the more comfortable you'll feel when you get to the hot seat of the interview and have to do this in a real live situation. So good luck with your practice.
Congratulations on completing this course. We're confident that the skills that you've learned throughout this course are really going to open doors for you in your career.
And when those doors open, whether they be a job interview, an internship, a new job, or even promotion, please report back to us through the Learner Stories forum or the discussion forums.
We're really excited that you've joined us on this journey, and we want to make sure that you can develop the software engineering skills that you need for your career. And so remember that we have 3 other courses in this specialization, and when you've completed all 4 of these courses, the capstone project is waiting for you. We'll see you there.
So why don't you implement a method that converts a string to a number?
Okay. I want to go through some examples to make sure I understand the question correctly. Can I, is the string going to be integer? Can it be floating point?
Well, ideally yes, but let's start by just thinking about how you would do an integer.
Okay, so I can assume, let's say, if I'm given a string 1, 2, 3, and I should get back 123. Is that correct? Okay. And I don't have to consider numbers like e or pi, anything like that, right?
No.
Okay.
No, and in fact, you can stick with positive numbers for now.
Okay. And can I assume the input is just a string, plant string?
Yes.
Okay. So public int start to int and input is a string. Oh. Is a string. And can the string be empty?
Sure.
Do I have to?
Yeah.
Okay.
So think about what you might do.
All right. Should I be returning 0, or should I prompt the user that they should enter a different number? What should I do?
You probably will talk about why you would do each of those things.
Okay. Well, if it's required for the user to enter a number, I probably will prompt them the error. But if it doesn't really matter, I can just default to 0. I can come back to this case and add a comment here. Is that okay?
Sure.
Okay.
Actually, can I pause for a second? Meta comment.
So should I consider if the input string is empty?
Yeah, definitely make sure you handle that case.
How should I handle? Should I throw an exception to prompt the user that there has been an error in the input, or should I just return 0?
Which do you feel like is a better solution?
Well, if it's absolutely crucial for the user to enter a number, then I'll probably throw an exception. But if it's like it doesn't really matter. I can just default the value to 0.
Okay, if you did that, how do you think you distinguish between a 0 value and a 0?
That's very true. If we're assuming that all the inputs are non-negative numbers, then we could return a negative number to indicate there's being an error too.
Okay, good idea.
So let me just make sure that the string is not empty. And if that's the case, I'll just return -1 for simplicity for now. And I think there are other corner cases, like maybe the string is like a space or like non-numerical values. Should I be considering that right now?
Not right now, but we'll come
Okay,
back.
okay. Okay, so I'm just going to add a comment here that says like non-numerical cases. Edge cases. Oh. All right. So I think what I'm going to do is basically converting. I think there's a method call that just converts the string to a number. Is it okay if I use that library function?
No, can you do it without the library function, please?
Okay. So I think I'll try to somehow get each individual digit. I think there's a library function that converts a string to a char array. Is it okay if I use that?
Sure.
Okay. So let me declare a char array. I think is it okay if I don't have the exact syntax for?
Yeah, that's fine.
Okay. Yeah, it's hard to remember the API without the Google Doc or the Java doc. Okay, so input. Okay, so now I have the string parsed into a char array. I can loop through the array. And I listen. And I know it should be length, not, because length is a field with arrays, not a method call. And I'm going to increment my index, and here we are. And so if I'm looping through each digit, I'm going to multiply it by powers of 10s. So I'm gonna need an integer that keeps track of the value that I want to return in the end. And so I should add the digits to this value and multiply it by powers of 10, and there's a pal function in the math library. So 10 I, and then I can just return value in the end. Value in the end.
All right, you said you wanted to add that value, value every time. I think you probably meant.
Yes, sorry, I missed the plus sign. There you go. Yeah.
Great. So let me ask you to think about the body of your for loop.
Okay.
There's a slight problem with it. Can you figure out what's wrong?
Yeah, okay, let me go back to the example that I had and then see. So, I'm going to have char array would be equal to, after, it would be equal to 1, 2, and 3 after I parse the string. And oh wait, I'm looping through the beginning to the end, or the front to the back, which means my number would be reversed when I return this value. So what I should be doing is have this equal to char or length. So then I would just look backwards. So then the values are, and then there's off by 1 there, right there. And then as long as I is greater or equal to 0, and then I minus minus. So what this will do is you'll get the first or the last index first, and then multiply that to the end so then the number is correct.
Great. Okay. So that fixes one problem, and I still see one problem that might lead you to get the wrong answer here.
Okay. I'm not quite sure what that error is. Could you possibly give me some hints?
Sure. Well, let's think about the char and think about how strings are represented.
Okay.
And how characters are represented.
Well, I know these are ASCII characters, and ASCIIs have their own values. I forgot to convert these characters to actual integers. So, again, I think there's a function call that just converts the card to an int. Is that okay if I use it?
Sure, go ahead and use it for now.
Okay. String, or I think it's actually in the character class. CTR two digit maybe. Yeah, and I think this should fix the problem.
All right, great. So there is a library call, and I am confident you could look it up if you needed it. But how might you do that? Can you think of a way, knowing what you know about ASCII, how ASCII works, can you think of a way that you could solve that problem of converting the char to its int value without using that library call?
So I know they're ASCII values, and they have unique ASCII values, and it starts with 0 and it goes to 9. I guess they're consecutive. So if I subtract the value from 0, then I would get the actual numeric value if since the difference is the same as the numeric value.
All right, good. That's the right idea.
All right. Would you like me to implement that?
No, that's fine.
Okay.
All right. Well, thank you very much.
All right. Thank you.
All right, great. I see a little problem with the body of your for loop. Can you maybe just check that that's correct?
Okay, so let me go back to my example. So if my input is 123 as a string, then my char array would look like this. 1, 2, so it will be parsed into different digits. And then I accumulate that in value. So value is started with 0, and then I move on to, I look at index 0, which is 1, and then I do 1 times 10 to the 0th power, which is 1. So then value becomes 1. And then I go to the second digit, which is so let me write in I equals to 2 or 1, and then I'm on the second index, which gives me 2, and then 2 times power of 10 to the 1th, which gives me 20. Oh wait, then I'm going to have the number reversed. So let me see. I would have to do some math to figure out what the I value would be.
So I'll just suggest maybe the math.pow is kind of throwing you off a little bit. Try a solution that doesn't use math.pow.
Okay, well, Basically, what I want to happen is to have 100 plus 20 plus 3 to give me 123. So let's see. I guess what I can do is instead of doing this. So again, if I'm looping from the beginning to the end, then I would loop through 1 first. And I loop through the loop 3 times. So if I multiply 10 each time, I would get 100. And then for 2, I'm going to have 2 iterations left. Yeah, and then I'll be when I have 3 iterations, I only multiply it 2 times, and then this one I'll multiply it by 1 times. So I think that should work. So let me just write that out. Yeah, so I would use the current value multiplied by 10. Oh, actually, let me take what I said back. When I have 3 iterations, I'll still be multiplying 10 by 3 times, but because value is initially 0, so it's going to stay 0, so it doesn't really matter. And then I can just add the char array, or the character that I'm looking for here. Yeah, so I think this will work. Yeah.
All right, great. So you've got the right logic now, but there's still a small problem. Do you see it?
No, not really.
So think about the way that chars and strings are represented as opposed to the way numbers are represented.
Okay, well, I know these are ASCII characters, and they're represented by ASCII values. Oh, I guess ASCII values are different from integers, and I'm adding the character right away. So if I remember correctly, there's a method in the character class that converts it to a digit. Is it okay if I use the library function?
Sure, that's fine.
Okay, so if I do this, character, yeah, the value that gets returned in this case would be much bigger than what I intended to be. So this should fix that problem. And let me just run through this example again to make sure that it absolutely works. So again, I have the char array, and when I equals to 0, I have value equals to 0 times 10 plus 1. So then I have 1. And when I equals to 1, I have value which is 1 times 10 plus 2, and then that gives me 12. And when I equals to 2, I have this times 10 plus 3, which gives me 123. So this should work.
Okay, great.
Awesome, thank you.
Thanks.
Hey, I'll be your interviewer today.
Hi.
Let's get going. Okay, so your job is to write a data structure that will have 3 public functions: insert, remove, and get random.
Okay. Insert. Random.
Okay, so before you start coding, can we kind of pause for a second and can you just go over your high-level approach?
So what I was thinking is have an array where I can start putting like the values, and then sort of get random would be just returning a random element from the array.
Okay.
And sort of, yeah, I guess I need an array.
Okay, so you're allocating 10,000 elements. But what happens if you have more than 10,000 elements in this array?
Are they going to fit in memory?
Yeah, you can assume they fit in memory, but you don't know how many elements you're going to have.
So I can't just like pre-allocate.
Okay, well, is there a different data structure, maybe something similar to this, where you don't have to worry about kind of pre-allocating the amount of memory?
Ah, right. So I can use like a list, an array list.
Okay.
Yeah.
How would that work?
Okay, that's much better. So. So, okay.
Okay, so before you start jumping into coding again, can you kind of explain how each function is going to work?
Right, so if I have this array, then, I mean, yeah, so the array list implements a collection, then I can, like an array list implements the collections, so that means it already has an insert and remove, so I can just pass that directly here. And then the get random would get, and then I can just do like a random, like I was explaining, I can just get like a random element.
Okay.
And that would be what returns, and these two would be just sort of calling the insert and the remove for the array list.
Okay. So for insert and remove, what would the runtimes of those functions be?
So inserting in an array list, it's like, I don't know, it takes like 4 or 5 operations.
So is this going to be constant time or linear time?
Yeah,
or
constant.
squared?
Yeah, I guess constant.
Okay. Can you kind of explain that a little bit more?
So because it's an array list, it should be it's constant.
Okay. What about remove?
It should also be constant. No. It has like, I don't remember how it does it very well, but I think maybe it just sort of swaps it to the end, and then you can remove from the end very easily. You just, because the array has like a size internally, the array list, and then.
So keep in mind, it also might help if you kind of clarify what arguments these functions are taking,
right?
And what they're returning. So like, what exactly are insert and remove taking as arguments?
Yeah. So they would just take the value.
Yeah. So with remove, right? Like if it's storing 10 elements and you want to remove 5, how would you do that?
So it just takes the index, right, to remove, and I can just.
So which index are you removing from?
Which index? So are you asking me how the array list does it?
Yeah.
Because I mean, okay.
So in the context of runtime, because you were saying you weren't sure whether or not this is constant or linear. So when we do the remove, what will the runtime of that be?
So I think that the array list sort of, so I guess it has to find the value to remove.
Yeah, it's a little tricky because the implementation of array list is kind of under the hood. But as you can imagine, if you want to remove element 5, it kind of has to search for that element inside the array list.
Okay. Yeah. So I guess the worst case would be like the size.
Yeah. So that would be linear.
Right. So linear. Yeah.
So insert would be constant, remove would be linear, and let's talk about getRandom. Can you explain how getRandom is going to work?
Well, I have the array, so I can just get a random element.
Yeah, but how does this random helper function, how exactly is that helping you get the index you want to get the value from?
So it's just a random number?
Okay, so what exactly is random returning? I'm a little confused by that function.
So it's just a random number generator. It just returns a random number.
So is it like a double, or is it returning any random number?
No, an integer.
Okay, so how will it work if you have 5 elements?
Right.
What?
Right. Yeah. So I guess this doesn't work, right? So I need to.
Okay, so let's say to kind of clarify this a bit that for the sake of this problem, random is just returning a random positive integer.
Right.
Just
yeah.
some
I
random
think it's like
positive
between
integer.
0 and some constant.
Okay. So in that case, then you're taking that random value and then you're modding it by the size.
Yeah.
Okay. And what would the runtime of this be?
So that I don't know how the implementation of random is, but I think maybe constant.
Yeah. So we can assume that random runs in constant time. In which case, then that'll be constant. Okay. So this is one approach. So you have this array list. Insert is constant. Remove is linear, and getRandom is constant. Is there another approach you can do that will be better than that?
Better how?
So if this is the worst case here is linear, can we do an approach that is better than linear, or have different trade-offs perhaps?
Okay. Oh, right. So yes, I can just use like a hash map. And then sort of insert. It's fast for a hash map, but also remove. So remove.
Okay, so let's take a break for a second. So before again you start coding this, can you kind of explain how each of these functions will work?
Right. So it's very similar. So the hash map also implements the collections.
Mm-hmm.
So I can also do insert and remove, like I was saying.
Okay.
But for hash maps, the remove is fast.
Okay.
It should run in constant.
Okay. And how would getRandom work?
I could do the same thing. I could just return one of the values at random. No?
So does the hash map have this getter function where you can kind of give it an index?
I guess they're not indexed. I can just get the first one.
So would that be random though?
It's a hash, so it should be random.
So can you kind of clarify what you mean by just return the first one?
So I think the hash map has a first and a last method, so I could just return
Okay. And then how is this random? So let's maybe take a break and kind of explain how getRandom should work.
Okay.
So think of it this way, like if you have this data set and it has 5 elements and you call it getRandom, it should return one of those values with equal probability.
Okay.
So if there are 5 elements, there should be a 20% chance that
Right.
any of those elements are returned.
So,
so in this case, if you just return, the first element, you're just always returning, right? Like
right. So this
given
doesn't
value.
change, right? So if I insert something, yeah, okay, but it should work always. So, okay, so I could like instead like get a random index. Right, and then I can just like iterate until I find that number, incrementing a value.
Mm-hmm.
And then when I get I can iterate in a hash map, right?
Yeah.
So I can just do that, and so if I have like, then okay, I can get like or I don't remember how to iterate in a hash map.
Before we jump into that, let's kind of take a step back again and think about this is the best way we kind of want to approach it. So let's kind of summarize. So we've gone over a couple of different approaches. We talked about using an array list. And for that, the insert will be constant, the remove will be linear, and the getRandom will be constant. So with this one, we established insert and remove will be constant time, and what will the runtime of getRandom be using this approach?
Well, I have 4, so I guess it will be linear.
Okay, so in this case, getRandom will be linear. So in both cases, kind of the worst, runtime for one of the functions is linear. Is there anything else we can do? Another approach we can take to maybe have a better, worst case than linear?
Mm-hmm.
Have it where every function is better than linear?
So how do you mean better than linear? Like,
so if for getRandom, right, you have to kind of iterate over every single input element, right? Mm-hmm. And likewise with the array list approach, for remove, we had to iterate over every element to identify the one to remove.
Okay.
So is there another approach where, we don't have to iterate over every single element for one of the functions?
So if I could have the values sorted, then that would be faster.
Okay. How will sorting help you?
So what I was thinking is that it would be better than linear.
Okay. But how exactly?
So like I'm thinking like if for instance I had like an array and the values were sorted, sort of finding a value would be like better than linear, right? That would be like with a binary search, like
okay. So
something like that.
Okay, so what do you know the runtime of binary search?
So it's like, I think it's, I don't know, like log. I mean, it's better than linear, right? So
yeah, so if you remember binary search, you have your input, right, and every iteration you cut it in half. So that's a logarithmic function. So yeah, that would be log n. So which is, yes, faster than linear.
Right.
So if we were to kind of keep things sorted, how would you do that? Like, what data structure would you actually store all these?
A tree.
Okay, what kind of tree?
Like a balanced tree.
Okay. So what do you mean by a balanced tree?
Like if I one of the trees that so like a red-black tree or something that it keeps things sorted.
Okay, well, let's think about like the simplest, situation that you want now, right? Is to have some tree where you kind of keep things in sorted order, right?
Right.
So
Yes.
is there a specific tree where, maybe, it's good for keeping things very sorted?
So like the red black tree doesn't, it does that, no?
Okay. Is there a data structure that you could use that's a little simpler than that still keeps it sorted?
Like a search tree, like a binary search tree.
Okay. Do you know how a binary search tree works?
Right. So I think that what they have is that all of the values in one side are smaller, and all of the values on the other side are bigger. So if I do that, then finding an element for removal should be like however many levels the tree has.
So as you were saying earlier, this would be like a logarithmic, right? Type function.
Right. And so the insert would be the same. It would be like log.
Okay. That looks good. So in this case, the insert would be log n, the remove would be log n, and what would get random be?
I could do it like probably in log n, I guess. So I can, like with trees, I can do like recursion.
Okay.
And that would also give me a log.
Okay. Let's code that up.
Okay.
Okay, so if I'm understanding you correctly, you're trying to like write the node class for the tree.
Right.
Okay, don't worry about that. You can assume that there is some, binary search tree data structure already defined.
Okay.
And it already has like a node class within it.
Okay, so like I don't know, like binary search tree.
Yeah, you can just assume that it exists.
Root. I'm just going to initialize it.
Okay, yeah, it's an empty tree.
And so this would be just root, insert, then root, remove. And so the get random, so I can still use the random.
Yeah.
Can I have a something that returns something between 0 and 1?
Yeah, sure. So what are you trying to do?
So like I want the probability of returning the root, or I guess to be like 1 over the root size.
Okay. So you're basically saying that in this case the root size is the tree size.
Right.
So if you have 10 elements, then you want the probability of it returning the value at the root to be 1 over 10.
Yes.
Okay. You can assume that in this situation, we can just assume random returns the value between a double between 0 and 1. Is that okay?
Okay. So I don't need to change that.
Yeah, you can just
okay.
leave it.
Okay, so that would work. Then So that does it.
Okay. One issue I'm seeing here is that what would happen if this tree weren't perfectly balanced, right? So let's assume that there are like an even number of elements in this tree. And you have your, let's say there's 4 elements in the tree.
Okay.
And you have your root, and then you have, let's say, 2 elements in the left subtree, and then 1 element in the right subtree. So here you're saying, return the value at the root, you know, with a 1/4 probability, which is fine, that's 25%. But then you're saying, essentially, return an element from the left subtree with a 50% probability, and return an element from the right subtree with a 50% probability.
Right.
And since there's only 1 element in the right subtree, you're basically making a 50% chance that we return that 1 element in the right subtree. And remember, like, it needs to be uniformly random, so it should be 25% for everything.
But if it's balanced, like how can it have like two on this side?
So remember, like, balance just means that, you know, the kind of like the minimum depth and the maximum depth, the difference between the two is like no greater than 1. So for example, if you have like 4 elements in the tree, you can have, you know, 1 at the root and 2 in the left subtree and then 1 in the right subtree. So obviously if you have a tree where it's like an even number of elements in it, you can't possibly have, you know, a perfectly symmetric tree.
Oh.
So it's definitely possible, you know, one left,
Like that.
the left subtree
it's
has
not-
a different number of elements than the right subtree.
But so if it were complete, this would work, right?
Yeah, that would be fine. Because if it were complete, then you're right. Whether or not you go left or right is, you know, you want, you know, 50-50 chance of that. But you can't assume that.
So
is there any way you can think of handling that?
So if the tree has its size, so if I just have like the size of all of them, then what I can do is, like, instead of 50-50 in this case, for instance, I can just sort of say proportional to the sizes. Like, that.
So explain to me how this would work.
Trying to make sure that this is correct. But so the problem here is that I don't have the same number. So I have 2 here, and I have only 1 here. So I want to go there with double the probability that I go here.
Okay. And how does that address that?
So it's like if I have the left size being twice as big, then this is not correct.
Okay, so we're actually running out of time. Do you have any questions before we wrap up?
No, I think I don't have any questions now.
Okay, that's it then. The next interviewer should be here soon.
Thank
It was good talking to you.
Hi.
Hello.
Nice to meet you. I'm going to be your interviewer.
Hey, sweet.
Okay, so let's get to the coding question. What I'd like you to do is design a data structure that has three methods: insert, remove, and get random.
Okay. So it has insert, remove, and get random. Is it storing any particular kind of data?
You can just assume that they're ints for now. We can generalize that later on.
Okay. All right. So we have insert, remove, and get random.
Right.
Okay. So you said they're just storing n, so can I assume like insert just takes in an integer?
Right, that's
okay.
fine.
Cool. Remove will take in the int. And then do they return anything?
What do you think they could return?
So actually, how are duplicates handled? So if I have this data structure and I insert like 3 twice, how is that dealt with?
Well, for now, let's just not worry about it. Let's just assume that all of the input is going to be unique.
Okay.
We'll handle that later.
Okay. So in that case, insert and remove can return like a bool if, for example, if it's inserting a value that's already in the data structure, maybe it returns false, and likewise with remove.
Yeah. Sounds good.
Or just
but
void or something.
Yeah, sure. I mean that's a good way of doing it. Let's make it simple. Let's start simple. Let's just have them be void for now if you want.
Okay, cool. So for get random, how exactly is that working? It just returns like any element in the data structure?
Yeah, so from the elements that are currently in the data structure, you should return one of them at random, so all of them have equal probability of being chosen.
Okay, so if there are like 5 elements in my data structure, there'll be like a 20% chance.
That's right, that's correct, yeah.
Okay, all right, cool. So get random will return, a int. All right.
Yep.
Okay, so just to double check that I understand this, let me go over an example. Right. So if I have my data structure, let's call it my data structure, and I insert, let's say, 1, and then 5, and then 10, and then I do remove for, let's say, 5. So at this point, 1 and 10 would be in my data structure.
That's correct.
Okay, and then if I call get random, there'll be a 50% chance that the 1 is returned.
Yeah.
And a 50% chance that the 10 is returned.
Yep.
Okay, cool. Okay, so let me think about this. The first thing that comes to mind is just I could use an array list. So that way when you insert a value, you just add it to the array list. And then for remove, you can do array list.move, remove. And for get random, can I assume I have some kind of like random number generator?
Sure, yeah.
Okay.
So you can assume that you have like a rand function that has a min and a max and returns uniform values between min and max inclusive.
Okay, cool. So if I have that, then I can, if I know the size of my array, which I do, I can just essentially get a random index using the bounds of the size, and then just return whatever value is there. So that's how I would do it with an array list.
Okay, sounds good. Yeah. Yeah, so what's the complexity of that solution?
Okay, so insert, I believe you're just adding it to the end of the array list, so that would be constant. Remove, you're just, okay, so remove is a little trickier because you have to find the element that you want to remove. So if there are 10 elements, then it's possible you have to kind of iterate through every one of those elements to search for the value you want to remove. So that would be linear, and get random would be constant. Can I assume that the random generator works in constant time?
Yeah,
Okay,
that's
cool.
fine.
So yeah, I can get the number in constant time, or I can get the index in constant time, and I can return it in constant time, and that'll be constant. So yeah, let me erase this. So for this would be O of 1, this would be O of n, and that would be O of 1.
Okay.
But let me see if I can think of a better way to do this. Let me see. So the problem here is that for remove, I have to search for the element that I want to remove. But I can use, if I use a hash set to store my values, then I can do the lookup in constant time. So, okay, so this is with my list. With my hash set, I can just insert the element in constant time because it's a hash set. I can remove it in constant time. And get random. Get random is going to be a little trickier because I can still get a random index, but a hash set isn't, indexed. It's not in any particularly sorted order. So I guess what I would have to do for that is, if I want to get like the third element, I would kind of have to just iterate it through it 3 times.
Okay.
So that would be linear then.
Okay. So basically what you have right now is one solution in which you have insert and get random to be very fast, and remove is a bit slower. And the other one in which insert and remove are fast, but get random then becomes the slower one, right? So can you do better? Can you do better sort of in the worst case, getting better than linear time?
So you're right. The problem with remove was that I had to find the element that I wanted to remove. And the problem with get random is that with the map, I can't like randomly retrieve the element with a given index. So let me think. I'm trying to think if there's another data structure that would be better than both of those. Let's see. So I need a data structure where I can still look up the value to remove in faster than linear time. So I guess the array list, something like a list or like a linked list wouldn't work for that. But I still need to be able to access a random element in faster time. So I need something that's kind of like sorted at least. Not necessarily sorted, but at least in some kind of order where I can kind of access it, more quickly.
So okay, so let me just recap. You have 2 solutions, right? Mm-hmm. One in which get random is really fast because you can index, right? And another one in which you can remove very fast because you have a hash, right? So can you think of a way to combine those two, perhaps, to sort of get the best of both worlds?
Okay. Yeah. What if? Okay. What if I still kept my elements in the array list, but I used the set to track the indexes of the values? So if I add some element to my array list into like the 5th index, I can kind of keep track of that index that I've added it to. And that way when I need to remove it, I can just kind of look up where it's located.
Okay.
And I can remove it in constant time. And then I still have all the values in my list, so then get random should still work in constant time.
Okay, sounds good. Let's see some code for that then.
Okay, cool. I'll just erase this. Okay, so this is my class. Call it my data. So actually, so I guess for this, I will need a hash map instead of a hash set, because I guess the idea is that I want to map the value to the index where it's stored.
Cool.
So actually, let me go over an example. So if I insert, 5 and 10 and 15, then what I'll do is when I insert 5, I have my map, and it will map 5 to index 0.
Okay.
And then when I insert 10, it'll map 10 to index 1. And then when I insert 15, it'll map 15 to index 2. And then if I do something like, remove 10, then I know that my element, the 10, is stored at index 1.
Okay.
And I just remove that value at index 1. So yeah, that should be pretty straightforward to do. Okay, so let me code this up. So I have this global variables. I'll have my hash map and my hash set.
Okay.
What's this? So that's my map, and then I also need my array list. Okay, so I have my map and my list, so I'll write the insert. So for insert, like I said, it just adds the element to the end of the array list, and then I need to update the location in the hash map. Can I assume I have, there's an insert?
Yeah, sure. Yeah,
okay.
Yeah, that's fine.
So at this point, let's say I insert 1 and then 5. We insert the 1 at the end of the list, and then we put the 1 will map to the size, which at that point is 1 actually, so we'll need to subtract. So the 1 will map to the size, which is 1, minus 1, which is 0. So the value 1 will map to the index 0. And then if I insert 5, 5 will map to index 1.
So just a quick question. Do you want those to be private?
Oh, good point.
Cool.
So for remove, like I said, I know where the value is located in the array list, so I can just remove it from that index. And then I would also need to update the location in the hash map. Essentially just remove that key from the hash map. So first I'll check that the value is in the hash map.
Okay.
And I'm pretty sure the array list has a remove at, or I can just return
Yeah,
the
that's
value.
fine. Yeah, don't worry.
Okay. Actually, now that I think about this, using remove at is a little problematic because if I remove an element and kind of in the middle of the list, all the elements to the right would like shift over, would have to be shifted over,
Right.
and that would actually take linear time because they kind of all have to be copied over. So let me see, is there a way to, I'm trying to think if there's a way to remove the element still in constant time. Because I guess I don't actually care about the ordering. So what?
So yeah, when is remove from an array list constant?
When it's at the end, it would be constant.
Right.
So what I could do actually is swap the value that I'm removing with the value at the end of the list. That way, I can just remove from the end in constant time. So, for example, if I'm removing, the value in like index 5, and there are 10 values total, I just swap the value index 5 with the value at the last index, and then I just kick off the last index.
Sounds good.
Okay, so let me rewrite this. So, can I assume there's like a swap
Yeah,
function?
don't worry. Yeah, you can assume that you have a swap function. That's fine.
Okay, sweet. So this will just swap the index where this value is stored,
Mm-hmm.
and then the index of the last element.
Right, that's fine.
Okay, so once I remove the element from the list, I just remove it, kick it out from the map as well. Okay, and for get random, that should be pretty straightforward. Like I said, I just calculate the random index. So actually, is it okay if I erase this and put the get random?
Yeah, that's fine. Yeah.
So random takes in the range of 0 and the size -1, and it just returns the value in that range randomly, and that's what we'll return from the list.
Okay.
Okay, so that's remove. So let me kind of go over an example just to double check that this is working. So
Sounds good.
let's say that I insert 1, 5, and 10. So as I add 1, I will update the hash map with the location. So 1 will point to 0, and then 5 will point to 1, and then 10 will point to 2. And then if I remove 5, then I check to see if the map contains 5. Does, it's here. I swap 5. I swap the index where 5 is at with the last index, so 10 and the 5 get swapped. And then I remove the value at the very end, which is the 5. And then I kick out the 5 from my map. Okay, so actually a problem that I'm seeing here is that I'm not updating the location of the 10.
Yeah.
So I need to do that as well. So what I can do is after the swap, I can just update the location. So actually, is it okay if I kind of just write some
Yeah,
code
that's
to the
okay.
side? All right. So over here, we just do map.put. Actually, it'll be whatever value is at the end. So this is where I swapped it. So this will be the list dot get the index. Okay, sorry. This will be, so I'll swap it, and then I'll put the value at the new index I swapped with. So actually, if I can just store this value ahead of time. And then whatever value's at that index now. And with the actual index. Okay, so sorry, it's kind of messy, but
yeah, no,
basically
I can see what you're doing. Yeah.
After we do the swap, I update whatever values at that index I just swapped to, or swapped from, with the actual that index. So now the 10 will get updated with the 1.
Okay.
Okay, so that's remove, and then get random. At this point, there's 2 elements, so we're getting a random value between 0 and size 2 minus 1, which is 1. So a random number between 0 and 1, which is what we want. So there's a 50% chance of these getting selected.
Right. Sounds good. Yeah. So how would you make sure that this is correct?
I guess there are a few different ways to test it. You can, so you pointed out that we don't have to worry about duplicates, but we can test this with negative numbers, which should be fine. We can see what happens when you remove a value that you haven't put in there in the first place. You can, insert a value, remove it, and then insert again to make sure there aren't any weird, side effects of that. Yeah, stuff like that.
Yeah, sounds good. So we were talking about the return value of, for instance, remove, and I told you not to worry about it, but how would you, for instance, return whether the value was found or not in this case?
It'd be pretty straightforward. Like here, I check to see if the map contains the value. So if the map doesn't contain the value, I can just return, false. Otherwise, here, return true at the end.
Okay, cool. Now, for a more interesting part, which is what happens if you actually have repeated numbers? How would you handle duplication?
So that would be a bit trickier because the concept here, right, is that I'm having this map where I map each value to the index where it's stored. But if you have duplicates, so if I have, 10 in here twice, then that value 10, I guess, conceptually now maps to two indexes, right? It's at index 1 and index 2. So what I could do is, instead of having it map from integer to like index, I could have it map from the integer, the value, to a set of indexes. So instead of this being integer, it gets to be a set.
Yep.
And then that way, when I want to remove a value, I can just kind of choose any one of those indexes in the set. Somewhat arbitrarily.
Sounds good. Yeah. And while we are at it, so also, how would you allow for this to store arbitrary data rather than just integers?
So like an object or something?
Yeah, sure.
So it would be fine. Like, I don't think much would need to change. I mean, as long as that value can be included in a hash map. Okay. So as long as it's hashable. And yeah, I think that's about it. As long as it can be in the hash set, and as long as I can, yeah, do hash set functions, it should be fine.
Okay, so just quickly then, the complexity of this solution as it is?
So get random will be constant time, remove, the swap will be constant, and removing from the end will be constant, and then updating the mappings will be constant. So remove will be constant time, and then insert should always also be constant, because you're just updating the mapping and adding to the list.
Cool, sounds good. Yeah.
Hey.
Yeah, thank you very much. We're almost out of time, but I want to give you a chance in the next couple of minutes to ask any questions if you have any for me.
Yeah. One question I have is, what's it like being an engineer here?
Yeah, it's actually very nice. We have a bunch of perks, of course.